We are live. Exciting. There's the camera. Hard to recognize where it is. Good morning, everybody, and welcome. This is our live stream. 26 hours.
26 hours.
Non-stop.
Teaching
Yep.
of science.
Yes, that is the thing. Unlike last time, and we'll talk a little bit about last time. Last time we had all these different subjects. We had lots of things we could dip in and out of. We were doing French, we were doing Mandarin, we were doing
phonics.
Oh,
You loved the phonics.
that was my favorite.
You loved the phonics.
I absolutely loved that. But this time it is just science, 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 non-stop. So, I mean, science is massive, right?
Yeah, science is a huge part of the curriculum.
Yeah.
And there's lots of things that we can do.
Yeah, there's like plans.
Exactly.
Yeah.
Plans. Now, very quickly, if you're watching, we have got a live chat up at the moment. Could you please, if you can, just let us know that you can hear us. Type it in the chat, just so we can check that you can hear us clearly and that you can see us clearly too.
Now, Mr. Keeling, I haven't told you something, is that I actually have a series of special guests through the day.
Oh, right.
Which I didn't tell you about.
Morning.
Morning. And look at this. Do you want to come on, sir? This is our local councillor.
Oh, morning.
Waseem.
Nice to see you.
Is this live?
This is live. We're currently live at the
So I'm
moment.
not going to talk about Aston Villa football.
You know,
No.
Talk about Aston Villa football.
it is the start of the Euro. So, I just wanted to say first a big thanks because Waseem, last time we did this 24-hour, you were supporting us. Do you remember? You sent us those videos.
I remember, yes.
And we did really well and really successfully, and it's really nice to have you here. And
My
I know
pleasure.
No,
Thank you for everything you guys are doing.
yeah, and you know how important science is to the kids. You've met our children. Waseem's here often. Science is very important, right?
It's incredibly important, and you have the brightest kids in the city, so it's absolutely amazing.
You heard it here first. And
Well, I would say that Causeway Green
Causeway
as well,
Green. 2 schools.
which have partnered with Anglesey, are also some of the
the brightest kids in the
best
country.
scientists in the country and future scientists, no doubt.
Now, Waseem, we were going to do a little experiment with you. Are you up for it?
I'm always up for it. I don't know what you're going to do if I'm up for it.
I'm not sure either, but are you ready?
I think so. I think we're good to
My
go.
series of special guests for you.
Wow, fabulous.
Yeah.
Completely unexpected. All right. Just before we do get going on that, I just want to say we've got a QR code up here. You can access our Just Giving site as well.
In the description, there's a link.
It's in the description to the video, in the link. Go down. Please donate as much as you can for a worthy cause. But we're going to start off exciting with... and explosion. That's what we're going to start with. We are going to start with an explosion. Now, we are going to use some basic science to achieve this. What we're going to do is we are going to work on creating a change. Now, there are different types of changes. There are reversible changes, there are irreversible changes, and then there's the two that we're going to focus on right now. We'll learn a bit more about changes later on in the day, but the ones that we're talking about right now are physical changes and chemical changes. Now, physical changes are easily reversed. So, for example, a physical change might be melting ice, turning it into water. That has physically changed the composition of that object. It's gone from a solid, which is ice, to a liquid, which is water. We're not going to look at that one, though. We're going to look at the other one, not physical changes. We're going to look at chemical changes. And chemical changes are a little bit different to physical. One, they're much, much harder to reverse. You may not be able to reverse them at all. And there are different things that happen when you make a chemical change. The most important thing, do we know, sir, that what we'll be looking at for the explosion, which part of the chemical change we are interested in?
There are different chemical changes, and I guess part of it is understanding which chemical change is going to happen. And Waseem is going to be doing one with me, where we're going to be looking at the reaction between Mentos and Coke, and we're going to see what kind of chemical change that is. And you, Mr. Keeling, have got a very exciting one with a multitude of different... What are these?
Well, these are different types of vinegar, and we're going to look at the reaction with bicarbonate of soda. But really, what I'm looking for in this chemical change is I'm looking for gas. Because when you have a chemical change, it usually gives off gas. We are going to put these chemical changes into a sealed container, and we are going to use that gas to build pressure. And hopefully, if we do it right, we should be able to get the bag to pop open. So what we're looking for in terms of our chemical changes today is gas. Now, as Mr. Jordan just said, he is going to be working with Mentos and Coca-Cola. He's actually got the simple explosion because he doesn't need to test this beforehand. However, we need to test beforehand. What we need to do, because I have 3 different types of vinegar. I have balsamic vinegar of Medina, I have cider vinegar, and I have red wine vinegar. What we need to do is we need to test which one of these gives off the biggest amount or the highest amount of gas, because that will give us the biggest explosion.
I want to ask a question here, sir.
Sure.
In a second, I'm going to get Waseem to make a couple of predictions, because to make this a fair test, we need to have some things that stay constant, don't we? We need
Absolutely.
a fair test constant, or else this isn't a proper scientific experiment. So can I just go through some of our constants?
Absolutely.
To keep? One of the things that will be constant, making this a fair test, is we need to make sure that the bag for each test is exactly the same. Because if we have different bags, different sizes, then the reaction might happen in different ways, and then it won't be a fair test anymore. If we need to make sure that we keep the same amount of liquid that we're pouring into each one. If we pour way more liquid into one experiment, then the reaction might end up being different, and that isn't going to make it a fair test. The other thing we need to do is make sure that the same amount is going into each one. So we have all of these things that throughout are going to stay as a constant to make sure that it is a fair test.
Absolutely. And we are going to use very, very accurate measures.
Ooh.
So we are going to use a tablespoon of bicarbonate of soda each time in each bag, and you are going to test the different amount of Mentos that go into each bag. That will be your variable, sir, the amount that you're increasing that by, and my variable will be the amount of bicarbonate soda. Another thing that we are going to keep the same, using the cups to measure, we are going to measure an equal amount of liquid, so an equal amount of Coca-Cola and an equal amount of vinegar, to see how big we can make these explosions. Yes.
So now, Waseem, do you have any predictions? We've got a variety of different chemicals here. Which one do you think might create the greatest reaction?
I think the cider vinegar would probably create the biggest reaction.
Yeah. Any reasons? Any justification? What do you think it might?
I have no idea what's. I'm just taking a wild guess. I ain't got a clue what you guys are up to, but I'm happy to participate.
I love it.
So you think that the vinegar is going to produce more pressure within that bag to pop that bag open and make a bigger explosion than the Coca-Cola and Mentos?
Yeah.
That's what we're thinking.
Because you've got this is a Sainsbury's cola. If you had an Aldi's cola,
Yes.
that might make a bigger reaction.
Obviously,
Okay,
other
we didn't
colours are
think about
available.
types of Coca-Cola.
Yes.
But yes, please know that we
I'll
don't
fall in love with
advocate
it.
one type of Coca-Cola.
I fall in love with an Aldi cola.
It's also very affordable, which is very important.
Absolutely, that is very important. Okay, now I need to get this started because I need to test these vinegars, and I need your help if you're watching to tell me which vinegar you think made the biggest reaction. So I'm going to use a small amount of bicarbonate of soda, and I'm going to use this plate, and I'm going to demonstrate to you on the camera the reaction between the vinegars and the bicarbonate of soda. I want you to watch carefully, and I want you to tell me, and we'll go for the one that's voted the most. I want you to tell me which vinegar we should use for this test. In a second, we're going to start writing up this test, but first I want to do this mini experiment. So I'm going to take the bicarbonate of soda and I'm going to add a little bit to the plate. So I'm just going to take a tiny, tiny bit, like so. And first, I'm going to introduce the red wine vinegar. So I'm going to pop that on here.
That'd be really helpful.
Oh, wonderful. Thank you, sir. Do you want to hold it right up to the screen so that they can see as close as you can? Perfect. Okay. I'm going to introduce a little bit of vinegar and we're going to see what happens. And if you could just hold it there. So as you can see, it's starting to fizz, it's starting to change, it's reacting, it's forming a solution, it's bubbling, and it's giving off that gas. And that gas is later is what is going to give us that pop.
I've got a really good idea. Might I just interrupt you? We've
Absolutely.
actually got an amazing testing zone over here. So should we?
Oh, fabulous. That's even better.
We'll show it on the big screen.
Absolutely. Should we go over there then? So that was the first one.
Right, so they've gone off screen. It should be popping up. Can you see that up here on the screen? You can. Will you press the focus button for us, sir?
Certainly.
Yeah.
How are we looking?
Ah, lovely, brilliant. So you can
Fabulous.
see where the bicarbonate of soda was in there, and you can see that the vinegar has been added and the chemical reaction has happened, and the bubbling tells me that something is coming off. Okay, see that in a bit closer detail, please.
So I'm going to add another little part of bicarbonate soda now. Little bit of bicarbonate soda. Here we go. Can you see that okay, sir?
Yeah, it's coming up on the screen.
And then I'm going to add this time cider vinegar to it, and let's see how that reacts. So a little bit of cider vinegar. Let's see how it reacts.
Was this the one, Waseem, that
This is the one I predicted.
This is what Waseem was predicting.
So again, it's creating the bubbles. It's reacting with the cider vinegar. We can see that coming off. I don't know if if it was as big as the red wine vinegar. I'm not quite sure about that. Let's try our last one. So we have the balsamic vinegar of Medina. We'll mix that with the bicarbonate of soda, and we'll see how that reacts.
And while Sarah's mixing that, remember that one of the things we said to make this a fair test, we need to keep certain constants. So that's why Sarah's using the same measurement of bicarbonate of soda and the exact same mathematically
Exactly the
calculated
same
measurement of vinegar.
Whoa!
Whoa, now that is a
reaction.
that is a mega reaction.
Interesting, and that's
Wow.
quite a reaction from Sir as well. Okay, voting in the chat. Which one are we going to go with?
Yep.
Are we going to go with the cider vinegar? Are we going to go with the red wine vinegar? Or are we going to go with the balsamic vinegar? Let's have a look what people are putting. Yo. Well done from King's Rise Academy. Hello, what time will this begin? Be here. Anybody have any opinions? Are we going to use the red wine vinegar? Are we going to use the cider vinegar? Or are we going to use the balsamic vinegar? Type it into the chat.
You know, the other thing is
We've got cider. That's first vote.
we can also have this later on in the chat, so you can come back and you can make a comment at this point anytime during the video. Okay,
Absolutely.
so you can
Or
add your comments at any
after.
point.
Absolutely. What do you think, sir?
Well, it was quite the one I predicted had the least reaction.
Oh, well, there we go. That's how it happens.
You can't trust
sometimes.
my predictions.
Absolutely.
The balsamic, I thought, had the biggest reaction.
It certainly got the biggest
And Mr.
reaction from me. Yes.
And Mr. Jordan.
And Mr. Jordan,
It
yes.
gave me the biggest reaction.
Mr. Jordan was absolutely giddy. All right, okay. I think we've got a couple of people saying cider vinegar. You know what? I thought it was the balsamic vinegar that did the biggest reaction, but I think a few people are siding with you, sir, and want to see the cider vinegar. So maybe we do both. I think we use this one, the balsamic vinegar, because I think it got the biggest reaction. But we'll also use the cider vinegar because that seems to be a popular vinegar, sir. And we'll see. Okay, what we're going to do then is we're going to start writing this experiment up, and we're going to start with an hypothesis.
I'm going to go down here, please.
Oh, thank you so much.
Can you press application?
Application, I
And
can.
then can you press the sort of red coloured one that's going to pop up in a second, I think. Maybe press X potentially.
Absolutely.
It's new technology that we're trying out. We'll definitely make. There we go. That's
And
it.
we'll go to our
Perfect.
whiteboard.
There we go.
And we will add a slide. Okay. So we're going to start writing this experiment up, and we're going to start doing that by coming up with an hypothesis. And the hypothesis is basically a fancy word for a prediction. So we have several choices here. So we could say the difference between the competition. So we could say, I believe, or I predict that mixing the Coca-Cola with the Mentos will have the grandest or largest reaction. We could say that mixing cider vinegar with bicarbonate of soda is going to have the greatest reaction and cause the largest explosion. We could say that balsamic vinegar of Medina is going, when mixed with bicarbonate of soda, is going to create the biggest reaction and make the largest explosion. You could say that the same result might happen, which might be that the bags will not open. Or you could say that the explosions are all the same and all of the bags open. Now, I am going to make a prediction, just because I'm working with the vinegar.
Yeah.
I'm going to predict that that balsamic vinegar will have.
What I like about your handwriting is you're following all of our letter join systems there. Very good.
Fabulous.
Yeah.
Well done for getting that in, sir.
Thank you.
Have the largest Largest, is that the best scientific word, do you think, sir?
Largest, greatest.
Greatest reaction to, I think greatest. So I would probably change that if you were writing it yourself at home. The greatest reaction, or the most volatile reaction to.
Such a lovely word.
Oh, it's a lovely word,
I really
isn't it?
like that.
The most volatile reaction to the bicarbonate of soda, hence producing the largest explosion.
Now, I've got a question as well, sir.
Certainly.
I obviously want Waseem to get in and do this experiment quickly, but what? There is a reaction going on here. Did you know that this is an acid?
An acid?
Yeah. So this is a bit of an acid. And what do you think that might bicarbonate of soda might be?
I have no idea.
Well, this is an alkaline.
Alkaline?
Yeah. So when these two are mixing,
but can I just say something?
Yeah.
I have this on my salad. How could I possibly eat acid?
Now, that's a very good question. Now, there are different levels of acid. Okay, it goes with a very broad range of acids. This is not a very strong acid. However, if you're going to tune in later on at about 4 o'clock this afternoon, which I hope you're going to be with us later on, we're going to have a look at how these kind of acids react with the enamel on our teeth.
Oh,
So
wonderful.
we're going to do an experiment to see that and see how different acids, alkalines, they might react with different things. So, acid, alkaline, that reaction's coming together. And actually, you were talking about this gas that's coming off. Did you mention what that gas is?
No.
Well, the gas that is coming off from this is carbon dioxide,
Wow.
CO2.
CO2.
So we don't want to be breathing it in. Right, shall we get...
Yes, I am really excited. Should we do a couple of experiments with the Coke? We're going to measure it using the cup. We've got a measuring line on the cup here so we can ensure the same amount. Should we try it with 1 Mento, 2 Mentos, and then maybe 5 Mentos?
What do you think, sir?
What do you think? Numbers?
Yeah, 1, 2, and 5.
1, 2, and 5.
That's a good variation.
That's the lucky numbers. Okay, there's the cup, there's the Coke.
I'm going to do
there are
it.
the
Would
Mentos.
you change the screen over to the other one? And maybe if we get Waseem to do this, and then I know you're going to have a lot of other things that you need to do as well, sir. Oh, we've already had a bit of a reaction there. So we need to pour the same amount into each cup, if that's okay.
And we've got a particular...
Should we get up to that line right there? Right, bro. I can actually already see, and you'll see on there, that there's a reaction going on. This is actually carbon dioxide that is already coming off the cup. I'm going to pop that under here. That will be our number 1. Oh, yeah, it's up already.
And what input are we looking for there, sir?
HDMI 2, please.
HDMI 2.
The cups are over here. We're going to pour another one, please. We're going to go to the exact same level because it's really important that we have a fair test and that everything is done equally. So, brilliant. I'm going to come and pop that one
Do we have another glass?
over here. And we do have one other cup just here. Absolutely.
Is that right?
Maybe a little bit more for that one. Perfect. I'm going to pop that one over here. Right, we can see. Can we see, so all 3 are there?
Yeah, we can see all 3 on the screen. Just move it a little bit closer. There we are.
Okay, lovely. And I'll let you get the Mentos out. Now, Waseem's going to
Wonderful.
go and get this Mentos out. Now, this is slightly different to a chemical reaction, and we're going to do that test in a bit. Maybe after, because Waseem's going to go and talk with those of the kids and get engaged as well, because all of our classes at Causeway Green and at Anglesey Primary School are getting really engaged with these lessons. This is a slightly different reaction, okay? It might look the same, but something very different is going on, isn't it?
Right. Okay.
So what's happening with this one, instead of the acid reacting with an alkaline and putting carbon dioxide off, which is a chemical reaction, this one, and I've forgotten the exact name of the type of reaction. Can you remember the exact type? Right, that's great. I'll find out for you. We'll get back to you on that one. But this one is actually to do with the surface area. Now, as I've already said, when Waseem was pouring it out, you saw that there were lots of bubbles coming up and off it, yeah? Carbon dioxide being produced. Well, the Mentos actually, and when we zoom in, and maybe we can get a picture of it zoomed in, has a lot of little ridges and tiny little parts where those carbon dioxide bubbles can react and suddenly spurt out. Well, we're saying spurt out. One thing I'd like to say is this reaction here is going to be a safe reaction because there's a rather large open end to it. So when you see some of the other explosions that we might do, you'll notice that this narrows a lot to the top. So as the pressure builds up, the force becomes greater and greater up to that thin point, at which point it can all explode out. Whereas with these cups, there isn't that narrowing creating a much greater explosion.
But you are, sir, as a reminder, going to do it into the bag. So you'll pour one of the cups and one of the Mentos into the bag and then seal the bag to see if it
We will.
opens with the gas.
We may have to do that bit a little bit later. So we're going to do this one now because I've just
Right,
seen one
and
of
then
our-
we'll test them. We'll test them later because we've got a
one of
class
our
coming
groups
in
is coming.
to come and help us.
So,
All right.
Waseem, here's the big moment, okay? What is going to happen? This is not a chemical reaction when 1 Mentos gets put in, 2 Mentos, and 5 Mentos. So, are you ready to do the first one? Right, we've got 1 Mentos.
The one, get ready.
Oh,
That is rather disappointing. I am disappointed. Let's try.
Okay.
2 in the next cup,
Two in the next
please.
one. See, they go. Okay.
Oh,
I can
that was
see
slightly
increased.
better.
We might need more than 5, so I think we could just pour the rest.
Maybe the rest of the pack in.
But I
Scientifically.
you can see on here, can't you, a much greater reaction. So what's actually happened here is the surface area increased. This is really, really good. Okay, so, well, here we go. Here's the last one now. Will this have an even greater reaction? Remember, this is not a chemical.
So the rest of the packet.
Yeah,
The rest of the pack. Let's see
Whoa!
how we go.
Are we gonna
Here we
get
go.
something
Here we go. Here we go.
Okay, yes, definitely fits up. But I think, as Waseem said earlier, maybe if we got Aldi Coke instead.
Yeah, I think so. And maybe I think as well, leaving the cups, time to get rid of that carbon dioxide hasn't really helped either. So
well, later on, we're going to do the back thing. We're going to do the sealed experiment. Waseem, can I just bring you on at 1 second? I want you to shake your hand, and we just want to both thank you again very much.
Thank you for inviting me.
Thank you
so
so much for popping
Thank you for
on.
everything you guys have done.
No, that's great.
Please keep watching.
Yeah,
Please do.
And are you okay to go and see that class that wrote all the
Absolutely,
letters? Because
absolutely.
the children in year 4 and all the other year groups, they have been writing letters, and Waseem was kind enough to write back to get in contact with us straight away, and we're really, really grateful for that. So thank you so much.
Thank you so much, and
everything
thank
you
you
do.
for coming on.
Brilliant.
Thank you. Take care.
You got that one, sir. We're going to pause this experiment now because we've got something rather exciting. And we will come back to this in a second, but Mr. Keeling's going to very kindly pack that away whilst I introduce our next scientist. We're going to come back to this explosion. Don't worry, it's going to happen. It's going to happen.
It will happen. We'll try and get a really big explosion.
So will you talk for 2 seconds?
Absolutely. So just a reminder, very nice of Sir to pop onto the chat and to see us. And just a reminder that you can donate to our cause and you can help us raise money for vital IT equipment for the school. And you can do that by doing the following. One, you can look down at our chat below, not our chat below, sorry, our links below, and you can click to our Just Giving page. Another way that you can donate your money is by scanning this QR code. Let's get in a little bit closer so you've got a chance to scan that if we can. Let's have a look. Ooh, can we see that? Scan that now and it will take you to our Just Giving page, and you can donate. Anything you have will help with today. So let's have a little talk about what is coming up. At the moment, Mr. Jordan has just stepped out because we have a class full of visitors who are going to be coming into the room, and they are going to be working with us on a scientific experiment. This morning, we're going to have lots of different visitors and lots of different classes coming in to work on experiments with us. And then at about 4 or 5 o'clock, we're going to move in to some structured teaching. If we can get it up. Some structured teaching.
Sorry, sir, very exciting because I have a special surprise. I have a special surprise.
Your surprises just keep on coming this morning.
I have
Mr.
so
Jordan.
many special surprises for you today. So can we move this table out of the
We
way?
certainly can.
We are going to have a little bit of science, but this time it's going to be led by our children for a little
Whoa.
bit. Okay. So if we can put up the playing screen for 2 seconds.
Sure.
And we can have a little talk. Actually, we might be able to Google a couple of things. It doesn't matter. Right. Children, would you like to come on here? Now, I want to introduce you. This is our year 1 team.
Wow.
I tell you what I'm going to have to do is I'm going to just
Yeah,
put
lower
the
that down
camera
a little bit
down
so we can
a little
see
bit
the
so we
children.
can see
Hi, everyone.
all of this here. Let me tighten that up. Brilliant. Right. This is our year. Everyone say hi.
Hi.
Hello. I'll tell you what, can I just get you to come over here because you're absolutely hidden behind there. That's absolutely brilliant. Do you think we could introduce some names and then we're going to talk a little bit about science? Is that okay?
Yeah.
So, what's your name? Sanaya?
Yeah.
Yeah.
Kahlid.
Halima? Hamza?
Araf. Leon.
Fantastic. My goodness, aren't they absolutely made?
Should we do all, a little chair set? Should we all together? 3, 2, 1, do it. Let's go science. Yeah? 3, 2, 1. Let's go science. Yay.
What did you say just a second ago as well? Was it you?
Woo.
Oh,
Oh,
wow.
and woo. How can we not do a woo?
Everyone, let's do a woo.
3, 2, 1. Woo.
Okay,
So what's going on, guys?
Well, you guys have come to talk to us about something, haven't you?
Yeah.
Yeah, who would like to start us off and tell us a little bit about what you are going to explain to our YouTube? Yeah, would you like to start me off then? And we'll come to you second. Is that okay? Yeah. So I'll tell you what, the camera's just over there, not actually at the computer. So if you're going to have a little talk, is that okay? If I angle it a little bit like that, there you go. So if you look at that one, good lad. So what have you been learning?
I've been learning about some things, like the same things over again and again.
Wow. So you've been coming back to topics over again and you've been consolidating your learning, haven't you? That's really good. Thank you.
It's never that.
Oh, okay. Well, if you step back a little moment, that's really good. Thank you for that. And you can tell me, what have you been doing in science?
We have been learning about evergreen trees and
What was the other one? What was it called?
deciduous.
Evergreen and deciduous trees.
Whoa.
Now, our plan, I just want to tell the stream, our plan was we were going to go outside and we were going to go and look at some trees, and it's absolutely pouring with rain, isn't it? Soaking wet. You've just come in from it. So maybe you could tell us a little bit about, or maybe we could even draw some little things, or could we search maybe a picture of an evergreen tree? We'll get on the back. So who can tell me something about an evergreen tree? You would like to have a talk? Yes, go on.
Evergreen trees, the leaves stay on the tree and never fall off.
Whoa, so the leaves are on the trees and they never fall off. So do they just look like standard, maybe if we put leaves in at the top, sir, do they just look like standard leaves then? They look normal, are they big and they're broad? Oh, can we have a look behind? What do you notice then about the leaves on an evergreen tree? Because they don't look like normal leaves to me. They look a bit different.
Yeah.
So how are they different? Can you tell me? Are they big and broad? Are they flat?
They might be big and broad and flat.
But if you look at these ones, what did you say they were? They're small and spiky. Anybody else want to give some descriptions of it? How else would you describe it? Do you two want to come over here so we can see you as well? Look, and you've got the football kit on ready because it is the start of the Euros.
Ooh.
So they're very small, yeah?
They're a little pointy.
They've got a little bit pointy as well, which is really important. Now, why do they have these pointy, thin leaves, do you think? Have you got any ideas? Yeah.
So they don't fall off.
Ah, okay, so it helps not to fall off. Tell me something. Now, I know about the seasons. Have you heard about the seasons?
Yeah.
I haven't. I think we're going to learn a little bit more about the seasons later on, but it would be great if year one could give us some knowledge early on about the different seasons.
So could you tell me, who can tell me a little bit about the season? Can you tell me something about the season?
Winter has snow.
Winter has
and
snow.
It's so cold.
Cold, I love it.
Wonderful.
Good. Tell me something else.
Summer makes all the trees' leaves grow up again, and
Whoa.
it's so hot.
Can we pin that about the leaves, the trees' leaves growing? Because I'm going to come back to that in a second. But I love that. So we've got really hot in the summer, really cold in the winter. There's a little bit more, I think. Yeah. What?
In autumn, the leaves turn brown and a little orange, and they fall off.
Okay. I thought you said the trees were evergreen. Though. We'll come back to that. That's really interesting. What can you tell me about? We've got one less. Spring. What do you know about spring? It can be cold.
In spring,
Tell you what. I'll sit here. Yeah, go on. Who's talking? Sorry. Yeah, go on.
in spring, baby animals grow.
Oh, so we're kind of warming up. So we've got this thing, haven't we, where it's starting to get warmer and warmer in spring and more sun. We get to summer, and that's when we've got the most sun and the most warmth, and then we're starting to get a bit cooler in autumn. And you said something about the leaves changing color until we get to winter when it's really, really cold. Now, you did, didn't you? You said that. Now, I look at those leaves, and they look to me like they're quite tough, right? They're quite strong. And I don't know about you, sir, but I can see a kind of waxy seal on them.
Yeah.
Yeah. And I think one of the things about these evergreen trees, did you know about they have a kind of waxy seal to protect them? Yeah. Well, wax is, actually, I've got some wax to show you because that was from, here, let's have a little look. So what this feeling, if you want to feel these were made by, what was the name of it again?
It was Class 02, wasn't
Class
it?
02, yeah.
CLASO2.
Maybe a Z. If you feel this, can you feel that bit of wax? Can you feel what that's like? You feel a bit kind of almost slimy a little bit. Can you feel that? Yeah, if you rub your fingers on that. Can you rub your fingers on that as well? So this wax, can you feel it? Can you feel it's left on your thumbs after you, yeah, can you feel that still on your fingers?
Yeah.
So that waxy kind of seal from Class 02, that it gives it a kind of protective, thank you to one of our sponsors, a protective layer that keeps those leaves really safe in the winter. And it means that those leaves, they don't fall off. Is that right?
Yeah.
Or do they sometimes fall off and regrow? I don't quite know. What is it?
They fall off. Evergreen trees, they never fall off. They just stay there in autumn, winter, spring, and summer.
That's interesting.
All the time.
I think actually a bit like our hair on our head. You know how me and Mr. Keeling are kind of losing the hair on our head a little bit. But a lot of you've got loads of hair. And do you ever see that hair sometimes falls out in the bath You ever see, like in the bath or in the shower, do you see some hair on the floor?
Yeah.
Yeah, but you don't lose hair, do you? But just a little bit of it falls off.
When you have a haircut,
It shortens it quite a lot, yeah. But sometimes the hair's coming out of your head, but it's always kind of regrowing, isn't it?
Yeah.
So if you have a look at the base of an evergreen tree, and I'm really hoping it's going to stop raining and we can go and do it because I've got that all planned, then we would see that actually the leaves are falling off all the time. It's just they're also regrowing. And so why is a deciduous tree different? Getting really tight in on here, aren't you? Yeah, yes. So we just take one step back.
Step back, step back, step back.
That's really, oh, wow,
wow,
look at that. Yeah, tell me.
a deciduous,
Can we get a picture of deciduous leaves there?
a deciduous evergreen tree always stays in its leaves
That's true. So a
because
deciduous.
there's needles in it that keeps it warm,
Right.
and
And that waxy thing over the top of it, yeah.
and that deciduous tree
Mm-hmm.
always falls off between autumn and winter.
Oh, yeah.
And spring and because it doesn't have
One
any,
second, that's really good. Will you add to that?
on spring and summer deciduous leaves grow.
That is so true. So these do something slightly different. And every season on a deciduous tree, and you can see, what season do you think that is for that deciduous? Oh, we can definitely see that's an autumn season, isn't it? So in the autumn seasons, the leaves, they start to,
Fall off.
they do, the tree gets rid of all of its waste, all of its bad stuff that it doesn't want for over the winter, pops it all into those leaves, doesn't it? And slowly takes all the goodness out of the leaves, stores it inside its body, and it drops off all those leaves, doesn't it? So that in the winter months, what might happen to those leaves if they stayed on in the winter months? What might happen? Yes?
It might fall.
Well, yes, but they've already, yeah, it's true. Yes. Anything else? What might happen to them? I'll tell you what would happen to you, sir, if you were left out in the snow all night?
If I was left out in the snow all night,
Yes, sir.
I would get cold.
You would get cold. And you might get really cold. What happens when you leave something in the freezer? What happens to it? Yeah? Well,
Does it get dirty in the
hopefully you've got a
freezer?
clean freezer. It won't
Hopefully
get
not.
too
What happens to the
dirty.
freezer? What's the purpose of a freezer? What does it do to the object inside?
Yeah.
It freezes it.
Well, so do you think we could feel something from the freezer? There's something that one of those ice packs. maybe.
Absolutely,
Then
I'll
we
probably
know
go get
science
one.
in action. Right now, if I am this big flat leaf, it's a bit like me being outside in the cold, and I'm really big and white. Can everyone get really big and white for me, please? Now, whoa, this is me being a deciduous leaf. I'm really big. I'm really wide. Now, if I'm out in the cold and I'm like this, what's going to happen to me? I am probably going to get covered in snow. What's going to happen to my temperature if I'm out like this? I am going to get cold, okay? Now, if we have a look, this is something...
This is for an experiment later, but this is directly from the freezer. What can we see?
Yeah, tell me about it. Feel it.
Have a feel.
Touch it for a second.
What's it like?
Oh,
Let me touch it.
wow. Do
And
you wanna have a touch of it?
freezing and
Wow.
slippery.
Yeah, that's true. Is it really, it's like wet and bendy, is it? Is it bendy?
Yeah, it's bendy. You can bend it easy,
and
can you?
Soft, is it?
No.
No. So what is it? How would you
And it's
describe
very
it?
cold.
It's very cold.
And it's wet.
It's starting to melt. I think.
Now,
You're
yeah,
touching it.
well, that's really good. We felt that. So you know now what it's like in the freezer. Not dirty, is it? But it is really, really cold. Now, I'm thinking, if I'm the cold, you've just said to me, can we get back out to being a broadleaf, please? Thank you very much. You are still broadleaf. Here, do you want to come over here? We'll get you, make sure you're all in. Don't want you to miss out in case parents are watching or anything. And the wind is taking, I'm getting really, really, really cold. So guys, that's the broadleaf, what you are right now, okay? And I'm just going to go back and put the picture of the evergreen leaf, or if Sarah would be kind enough to do that. Now look, I want you to tell me, but broadleaves, hands out, broadleaves. Okay, it's getting really cold. Guys, could you show me, what would you do to stop yourself getting really cold right now? What would you do? Show me. Would you keep your arms out like this and be really big?
No.
So show me what you do. Show me what you do if you really wanted to be. Show me what you do.
Ooh, if you were really cold, what would you do?
Oh, look what you're doing. You're getting smaller. You're actually decreasing your surface area. Like this, you were a really big flat leaf and you were open. You were getting cold all over. But now when you get cold, you want to get small, don't you? You want to get tight. In fact, I'm looking a bit like an evergreen leaf, aren't I? Can you see that I'm like a sort of thin sort of shape? Because I'm keeping everything close and tight together. And that's a little bit what they look like. Can you see how they're really close, they're tight together, they're not big and broad. So on those deciduous leaves, because they're big, they're flat, large surface area, they would be very easy for them to freeze, they would snap, they would break, and that poor tree who spent all summer getting all of that lovely energy would lose all of its leaves anyway, so it might as well just drop them. Hey, now, earlier on, one of you said to me that in summer, you don't need to stay freezing, unless you are actually cold. Are you actually cold? Are you actually cold?
No.
No, okay. If you do get colder, that's a really good thing to do, isn't it? Because you're preserving your energy. Your heat, sorry. So tell me, one of you earlier on, you said to me that in summer, there's lots of sun, and the sun helps them all to grow. Is that right?
Yeah.
Can anyone tell me a little bit about that, please? I've heard a lot from you. You've got. I'll hear a little bit from you, then a little bit from you, and I'm going to pick on some of you as well, if that's okay. Go on.
And if rain comes in the summer, it'll just make the leaves grow a lot. And flowers might grow.
That's really good. Let's pin that idea of rain. That's really good. Can you tell me something else about the sun? The sun is hot. Does a plant need to be hot?
Not really.
Well, it depends, doesn't it? Because you do get plants in very, very cold places, but it doesn't want to be too cold or else like that ice that Mr. Keeling showed you, it would completely freeze. Can anyone else tell me anything about the sun in the summer and how it helps things to grow? Can anyone tell me anything? Do you think of anything about the sun? I'm going to come back to you in a second. Do you think about anything about the sun, do you know? Does a plant need the sun? Did you know? Do you know? Yeah.
It needs water and salt.
And salt. Definitely water and maybe sunlight might be the other thing. It definitely needs water to grow, doesn't it? Because that's something that we all need. All living things so far that we found, we all require water. I'm saying so far because obviously there might be aliens and other creatures out there who don't need water to survive. But on Earth so far, all the living things that we've found, they require water for survival. But sunlight, that's interesting. So, can I ask you, do you think a plant needs sunlight, or is it kind of fine without it?
I think it will be fine without it because it doesn't need sunlight for things like photosynthesis and making food in its leaves, and it doesn't need sunlight to stay warm and so it doesn't freeze. I think it'll be fine without sunlight, won't it?
Sir?
No!
Oh, sir, what are you
I
like?
don't know.
Well, let me tell you something, sir.
Okay.
It does actually need some energy.
Okay.
I planned obviously this perfectly. So
I
it
can
does
see.
actually need sunlight. Okay. So as you know, there is a beautiful big. What color, guys, is the sun?
Yellow.
Oh,
Okay,
wonderful.
brilliant. Right. We've got a lovely big bit of sun up here. Doesn't that sun look beautiful, guys? Do you like my sun?
Yeah.
Yeah, excellent. And now what color is a plant?
Oh, green. Good knowledge.
Green, isn't
Are
it?
all plants green, sir?
Oh, that's a good question. Are all plants green? Yes or no? It could be. It's really, couldn't it?
Yes or
I don't
no?
think all plants are green, but I would say most plants.
A lot. It's
Yeah,
it's
most
one of the
plants
most
are green.
naturally
I have
green.
noticed that it has stopped raining, so we might just go for a quick explore. It's okay. If that's okay. And now this little plant down here has come from a seed. Oh, we're going to be planting some seeds in a bit. Watching them germinate when we get hold of those. That's really good. If I can find that. Now look, this plant is growing, and can you see what are these green things that I've got coming off the plant? What are they? What are they?
Flowers.
They could be flowers. What do you think they are?
Yes.
I think those are some leaves that we've got growing off the plant. Now, I don't know if you knew this, right? But these leaves, they need some energy from the sun. And what happens is the sun's energy, it comes down. And these leaves, they're a bit like, who's ever used a calculator before? Used a calculator? Yeah. Oh, okay, maybe you haven't. I'll tell you what, let's think of that one. Have you ever seen on the top of some houses, have you ever heard of solar panels?
I think I
You think you have solar panels? Well, we have this amazing bit of technology where we're able to get energy from the sun. Well, and that's called solar panels. And we put solar panels on the top of houses and it gives us energy. And sometimes even, have you ever heard of a Tesla? Oh, some of you might have heard of a Tesla.
Tesla is a car.
It's true. We're hoping that Elon Musk is going to sponsor this as well, which would be really good.
Fingers crossed.
Yeah, so a Tesla, sometimes you might see some, they have a solar panel on the top and they're able to use the sun's energy to provide electricity. Well, the plant can use the sun's energy as well. Did you know that to help it grow? Right. So the sun's energy comes down to this plant, yummy, yummy, yummy. It takes it all on board, and it needs gas as well, sir. What gas do you think it needs, Mr. Keeling?
I think it needs helium to float.
Oh, do plants float?
No.
Mr. Keeling.
Does it need nitrogen?
Never.
Does it need hydrogen?
Never.
I'm not sure.
Oxygen?
No. Yes. Oxygen.
It might need oxygen. That's true. Oh yeah. Do you know plants have a little bit of oxygen? You can need it. But is there anything else there?
Is it that gas that we were looking at a little bit earlier with our experiments?
Yeah.
That one that was fizzing, that was coming from the Coca-Cola and that was coming from the vinegars.
Ooh.
Is it that gas, sir?
I think it might be. Do you know what gas we breathe out of our mouths?
Yeah.
What is it? What is that gas?
It breathes air.
It is a type of air. Well, yes, it is air. You're not wrong. But there's a particular gas that we breathe a lot of. Ooh, everyone's brush their teeth. Could be fog. Have you ever heard of carbon dioxide? Whoa! What an amazing carbon! Everyone, can you say carbon dioxide?
Carbon dioxide.
I'm gonna just stand over here, so we're looking towards that camera a little bit. Everyone, say again, carbon dioxide.
Carbon dioxide.
Now, don't worry, guys. You might not have heard of it, but do you know what? That's what learning is all about.
Whoa,
Okay?
I've learned.
So, about carbon dioxide, right? So, over here in the air, there's loads of carbon dioxide, and as we breathe, loads of carbon dioxide out. And this plant loves this. I'm gonna put this as CO2. Can you say CO2?
Now, why have you noted it as CO2, sir?
That's a great question, sir. Thank you for making sure that I answered that question.
Thank you.
Well, you year ones are gonna really like this. Gas is actually like a little molecule that's made up of tiny little things. Believe it or not, it looks like there's nothing here, doesn't it? Do you think there's something in between you and me?
Have a feel.
Have a feel. Can you feel anything?
Can you feel anything? Put your hand up and down.
But wait a
Can you feel
second.
anything?
Do it really quickly. And do you feel something?
Yeah.
Oh my gosh, that's the air you're feeling.
Oh, wow.
Let's do it. Go up and down really quick. Yeah. So when you're doing this really quickly and you feel something in your hand, you're actually hitting into the air that's all around you. And believe it, this is not empty space. This is full. We are swimming right now in a room full of air. There are all these different molecules flying around. Yes, sir?
Don't you need water for swimming, sir?
That's such a great question. Well, I was using swimming as a metaphor in that sentence. That's a great question. This is mostly a science lesson, but do you know what? A metaphor is when you say something is like something that it isn't. So, for example, has anyone ever said to you, "You're a superstar"?
Yeah.
Yeah, one of you two. When they say you're such a star, do they mean that you're a big burning ball of gas floating in the endless, infinite space of space?
No.
Surely they do, or why would they say it? Well,
This
that's,
means you're great.
well, that's a metaphor. It's when you say something is something and it isn't really that. That's what a metaphor is. But thank you for testing me on that, sir. That's
No
really
problem,
good.
sir.
So Sir was going back to asking why this is called CO2, and
Yes.
I'm not going to drop that. That's because we have one carbon molecule and two oxygen atoms.
And when they come together,
they are CO2.
they
So
form carbon dioxide. Is that
C
correct?
is there, and then we've got O2, two O's over there. Okay.
Fabulous.
Why not two O's?
That's such a great question. Thank you for asking. Well, the carbon, it combines in all sorts of different ways. You can have something called carbon monoxide, which just has one piece of oxygen, and next to it, carbon monoxide is very dangerous. Yes, you don't want carbon monoxide
Why?
anywhere near you. It's a great question. Why is carbon monoxide very, very dangerous? Thank you for asking. Well, carbon monoxide is very, very dangerous. One of the things it does, I don't know if you know, inside your body, you've got something called red blood cells. Did you know your blood is red? Have you ever seen that?
Yeah.
Well, these are kind of red blood cells. They look a bit like sort of donuts without quite a hole in the middle. And they float all around you. Your blood isn't just one liquid. It's actually full of loads of these little things floating around. And when they all come together, they look like blood, but they're full of these little things called red blood cells. Now, red blood cells are amazing because what they do is they've got something in it called hemoglobin. Can we all say hemoglobin?
Hemoglobin. Wow, these guys are superstars, and I know that is a metaphor. So.
Oh, very good. Well, hemoglobin, and thanks guys for asking. What hemoglobin does is when you breathe in oxygen, the oxygen attaches to your red blood cells. And I like you to think of your red blood cells, and we'll talk about this a little bit later in the live stream. They're like little buses. Okay, can you see this is my bus and here's my bus conductor? And what happens as I'm breathing in all this air, the little red blood cell, like a little bus, it says, "Hello, I want some oxygen, can you get onto the bus?" And the oxygen, which is actually called O2, jumps onto the bus. And that's your red blood cells, and it pumps all around your body, because all of your body needs oxygen. So as that bus goes all around your body, it drops off little bits of oxygen along the way. And when it's empty, it comes all the way back to your lungs. Take a nice deep breath, and I put more oxygen into it. Now, why is carbon monoxide bad, you say? That was the question, wasn't it? Well, the reason carbon monoxide is bad is because it gets in the way of that bus and it blocks the little door onto the bus. And it stops that oxygen from being able to get on and off. And if we're not getting a lot of oxygen running around our body, well, we become tired and lethargic.
It's just not very good for us, is it?
So there's one very bad thing that can increase your carbon monoxide in your body. Do you know what that very bad thing is? Have you ever heard of smoking?
Yeah.
Oh my goodness, it's such a terrible, such a dirty thing. And what happens when you smoke? You're smoking in all of this carbon monoxide, and all of your lovely, healthy red blood cells are being destroyed by the carbon monoxide. That's terrible, isn't it?
My dad does that.
Oh my goodness. Well, you're going to help your dad to reduce his smoking intake.
I
I'm sure.
do,
Good
but my
boy.
dad doesn't listen to it.
Well, you're just going to keep going, and I'm sure one day you're going to get through to him. Well, don't
So
worry.
back to plants, sir.
Plants. Here we go. Let's get over here back to plants. Now, thank you for that. So, where exactly were we on the plants?
We were using the sun's energy,
Yeah.
and that's when you went on a little
Right.
tangent there.
So, well, we did say on BBC Radio this morning that
We
like
would go on
tangents.
tangents,
It's
absolutely.
all about tangents. Did you know we're on the radio this morning?
Yeah.
Yeah, we're on the BBC Radio this morning. Yeah, look at that. Right. So, the sun is providing some energy to the plant, but the plant can't just have the sun's energy. It needs something else, which is carbon dioxide. And this carbon dioxide gets yummy, sucked up by the plant, and it combines the carbon dioxide. I'm going to write a little bit up here as well. I'm going to change the color. What color should we go for, guys?
Oh,
Purple.
Seems
Purple
pretty
sounds
unanimous.
unanimous.
Dark blue's kind of like purple. Let's go with
Should we have rainbow color?
Oh, rainbow.
All right. So what we have is oh, you was a great choice. We have carbon dioxide, which is CO2, plus sunlight. Okay, and that gives us carbon dioxide plus sunlight in a plant. It gives us yummy. What does this word say? Can anyone read it? Energy. Everyone say energy.
Energy, energy,
It gives
energy.
us lovely energy plus. Oh my goodness, and it's all coming full circle, sir.
Wow.
Plus, it gives us a gas in the air that we love as humans. What is our favorite gas? I told you it's what the red blood cell buses take around your body. Can anyone remember what is the name of that gas? Sir?
Helium.
It's. Do we float like a helium balloon?
No.
Mystic
Carbon dioxide.
Is it carbon dioxide?
No, that's the one.
Who can remember it? What do we breathe in?
Oxygen.
Whoa.
Can we all say it on 3? 1, 2, 3.
Oxygen.
Ah, so it gives us that amazing oxygen and energy. And so the plant gets the energy, it grows nice and big and strong, and also it then gives off oxygen for us to breathe. And I love breathing oxygen. Do you love breathing oxygen?
Yeah.
Oh, it makes it so good. Now, I think so. Should we be a little bit daring? Should we go and just look at some...
I would love to. Can we go through? I've just brought a little book along, and I'd love the year ones to help with this. Because this book is a year one book about the changing seasons. And I'm going to read it out. And then after I've read each page, what I would love the children to do is I would love them to act out what's happening, to show everybody who's watching what is going on in the book. So the book is called Changing Seasons.
So
We all say Changing Seasons.
Changing seasons.
Okay, let's have a little read and have a little look inside there. The weather is getting warmer. The snow is melting. Can you show me snow melting? Can you all show me the snow melting? Lovely. And what happens when the snow melts? What does it turn into? Water. So the weather is getting warmer and the snow is melting. There are streams of water running through the snow. Can you be a stream of water running through the snow for me? What noise would it make, those streams? Lovely. So we're in winter at the moment and the snow is just starting to thaw. The water is running down the mountain. What happens to it? Where does it go?
So can I ask something?
Absolutely, sir.
You said Thor? Is that the god from the Viking mythology and with a massive hammer?
You are absolutely right. So when I say the snow is thawing.
We're talking
That
about...
is Thor with his hammer
Right.
knocking the snow down.
Do we-
Of course not. Let's
Doing
say
that.
no, Mr. Jordan.
No, Mr. Jordan.
What we are talking about when the snow thaws is we are talking about that snow melting, warming up to a certain temperature so that it changes from that solid back into a liquid.
Got it. Thank you, sir.
Okay. Then, after the winter, after the cold starts to go, everything comes to life. Leaves are growing on trees and blossom is coming out. Can you show me those trees growing? And can you show me those blossoms, those flowers? Wonderful. Well done, year one. Fantastic. Days are getting warmer. Show me those days getting warmer. Oh, it's nice and warm now. And each day is longer than the day before. It is springtime.
Spring. Like a...
Spring.
You mean one of those coils that bounces when you push it back down, sir?
Let's all say silly Mr. Jordan.
Silly Mr. Jordan.
Now, whilst there is an item called a spring, we're talking about the season when it starts to warm up and the plants start to wake. Okay?
Like this.
Just like that.
Brilliant.
Many animals are born in springtime. They grow quickly and become big and strong. Show me big and strong. Show me the big and strong animals.
Being born as well, sir.
Bees search for pollen. The meadows are full of flowers and the bees are busy looking for their food. Let's buzz around looking for our pollen. Oh, these are busy bees, sir.
Wow.
Ow, that one stung me.
Oh.
Ow, what did you do that for? Ow, 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 ow.
Okay,
Good that this is on off camera. There we go. The bees, they get covered in pollen and they take that pollen to other plants to pollinate them. And we'll learn about that a little bit later on when we talk about plants. The days become warmer and longer and spring turns into summer. The sunshine is very hot and we can see here a diagram, and today we're going to be doing lots of diagrams. I'm going to be drawing them and I'm going to ask you to draw along later on. We're going to do lots of diagrams, but here we can see the sun's heat hitting our planet, and when our planet is tilted towards the sun, the northern hemisphere, it will be summer there. When it's tilted away at the bottom, it will be winter.
Did you know that we're like on a big ball floating around in space? Did you know that?
Yeah.
That's what planet Earth is, yeah. Round like a big ball, isn't it?
If
Yeah.
we were in space, we would be out of it.
Whoa! That is some good knowledge for year one. Okay, it's summer and it's time for holidays. On the other side of the earth, it is winter, but we are enjoying it because we're on the northern hemisphere. We're in the Norman hemisphere. We're in the Norman. That's an era, yes.
Right.
Forget that. That's history. We're not teaching that today, sir.
Okay.
We're on the northern hemisphere, so it is really nice and really, really warm. So I want to see you on your holidays. I want to see you in your sunglasses. I want to see you relaxing. Show me being on holiday. Show me relaxing. Very nice on the beach, enjoying that sun. Wonderful. Oh, sun cream, very important. Get your sun cream on. Sun cream on. Don't look at the sun. Don't look at the sun. Not very good for your eyes. Keep those sunglasses on. Wonderful. The animals that were born in spring are growing up. Soon they will leave their mothers and live on their own. Can we all say goodbye?
Goodbye.
Everything is very dry now. During the hot days, the farmers are busy. They need to cut the wheat before it rains. Let's get farming on our tractor. Show me on your tractor. Show me on your tractor. Farming. We need to get all that food in for everyone. Watch out. There we go.
Right, come back over here.
Come back. And then the days begin to get shorter. Although the sunshine is still hot, the nights start to become colder. Can you show me that you're cold?
So when you say knights, you're talking about those guys in big shining armor with like swords and axes?
Silly Mr. Jordan! We're talking about night as in nighttime. When our planet has made a half rotation and the sun light is shining directly on the other side of the world.
And the moon comes out.
So the days begin to get shorter and the nights begin to get colder.
Yeah.
The fruit is ripe. The apples are picked and sent to the market to be sold. Some apples are kept for winter. Can we show the audience picking apples? Those apples. Have a bite of a couple. Oh, how do they taste? What words?
So we might be able to see some trees.
Oh.
Yum.
How do they taste? Give me the words for it.
They taste incredible.
Incredible. What else do they taste like?
Delicious,
Juicy,
scrumptious,
wonderful,
magnificent,
magical.
How about
mouth-watering.
awesome?
Awesome. That deserves an ouch high five.
Can you sting it
Okay.
again, sir? Stung you again.
The birds are ready to migrate. Mr. Jordan, what does migrate mean?
Migraine is when you've got like a really sore head.
Silly Mr. Jordan! I'm going to give you one chance to explain it as scientifically as you can.
Well,
What is
children,
migration?
Migration is a great thing. Do you know that we like to stay in our houses and we stay in the same place, don't we? Because we've got everything we need in our habitat. If we need some food, we can go to the shops. If we need some water, we can turn on the tap. And we've got pretty much everything. So we don't need to migrate. But some animals, they don't have everything they need all year round. Because what happens to all the plants and the trees in the winter?
They start to fall off.
They start to fall off and there's no fruit growing and there's no nothing. So what do all the plants, what do all those birds do? What can they eat? Can they eat anything there?
No.
So do you know what they do? They pick up and they start flying and they fly away to another place in the world where it is summer. And that is called a migration. You go from one place where there's everything you need, and then you move all the way over to a new place where there's stuff you need. And then when that place runs out of food, what do you think you do?
Go to another place.
Go to another place, or actually sometimes just go back. So there's actually a lot of birds around us. Have you ever seen those Canadian geese?
I have not seen those Canadian geese.
Well, have you might have seen a big goose walking around. And it's big and it's white and it has a bit of black on it. It's known as a Canadian goose. Okay.
Ooh.
Well, these things, you see them all around in the summer. I've been doing a bit of this. Everyone can be a goose. Go. That's a duck. All right.
That's a duck.
What's the goose, mate? That's a goose noise. So, then you see with that goose, when it gets to winter again over here, they fly like that. Do you know where a Canadian goose might fly to?
I know exactly where a Canadian goose might fly to.
Blackpool. Do you think he's right?
No.
Say silly, Mr. Keeling.
Okay, where do you think a Canadian goose might go?
Canadian.
Oh, very close. Anybody else?
Do you know a country that sounds a bit like Canada?
Canada.
Canada! Is that right?
Yeah, pretty much.
Okay.
So, definitely, there's a North America, Canada. That's it, bang on. So, flying over. I'm actually guessing that based on the name.
We'll check that. We'll fact check that later. Let's conclude our book because I really want to get outside. I really want to get outside and go and have a look. So the birds fly to warmer places to get more food. Could you show me the birds flying? Go on.
Very good.
Leaves, and this is what you were talking about before. So
Yeah, so-
leaves fall off trees. Can you remind me, year one, what type of trees lose their leaves? Whoa, deciduous trees, lovely knowledge. It's too cold for their leaves. They turn yellow and brown and fall off. It is now autumn. It is now autumn. Can you show me those falling leaves? Can you be those falling leaves, those leaves falling down? Lovely, well done. Okay, animals are ready for winter, so they're preparing for winter now. The days are short and the sunshine is not very warm. Some animals grow thick coats to keep out the cold. Can you be an animal and put on your coat? That's it. That's how animals do it, isn't it, Mr. Jordan? They go into Next
That's right.
or Primark and they get a coat and the cow goes up to the counter and goes, no.
Everyone say silly, Mr. Keeling.
Oh, so how do animals get coats?
When they're born.
When they're born. So some animals, absolutely, some animals are born with thicker coats. They already have fur. And that's what we're referring to, isn't it? The animal's fur. So how did they get more fur? What do they have to do in winter?
They have to grow it.
They have to
Nice.
grow it.
Do you have any kind of like sort of fur stuff on your body anyway?
No.
No, 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 no.
No.
It's a bit like head hair, isn't it? All over here. This is a bit like an animal's fur, isn't it? You might not have it. Do I have any on my phone?
No.
Oh, I do as well, don't I? Yeah. And you might have it if you have a look at Mr. Keeling's arms. Can you see he's kind of got fur all over there as well? So yeah, we don't have as much.
And that's because we have adapted, obviously, to use clothing and to produce warmth so that we don't need fur.
Nice one, sir.
Okay, so animals, they're growing their coats, they're getting ready for winter. And on cold nights, it's frosty. In the morning, everything is white and sparkling. Up in the mountains, show me the mountains. It's snowing. Can you snow? Snow for me. Snow for me. And on the other side of the earth, it is now summer. Well done, year one. Let's give you all a massive round of applause. Wasn't that lovely? In all of your knowledge, you've certainly shown that Mr. Jordan needed your help. But I think Mr. Jordan has a short adventure for us to go on.
A quick short adventure. Are you up for a quick short adventure?
Yeah.
Right, guys. Well, I think this is going to be complicated and it might not work and blah, 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 but we'll try. Okay? Yeah? What we're going to do, we're going to have a look and we're going to see if we can identify some deciduous trees. You know about those? And some evergreen trees.
Yeah.
Are you up for doing it?
Yeah.
All right,
I
guys.
have one question.
Yes.
Why couldn't we just record and do everything we needed to do in videos?
Well, we're going to do it live because we have got people from all over the world who are going to be tuning in, who are donating, and it's so that we can have a really big challenge, okay? We are challenging ourselves to be teaching non-stop for 26 hours. That means we're not going to stop this lesson until Saturday.
Should we do a check-in, sir, to see how much money we've raised so far in this
We
first
could
hour?
do you want to
I can get that up and we can have a little look. We can see.
Yeah.
So how much have we raised so far?
Well, that's the date today, and that's the QR code if anybody wants to scan it. Now, what I'm going to do...
Whoa, we have raised, get ready, children,
Are you
get ready
ready?
for this. We have raised so far £1,525.
Everyone say,
Whoa! And that is all going to our schools and our communities, buying equipment for you guys. Yay! And if anybody's watching now, what should they do?
Give us money.
Yay!
Okay, all right. Well, guys, are you ready to come on a little bit of an explore with Mr. Keeling and I? And so you're going to carry that? Whoa! Right. Oh, it's a little bit wibbly wobbly, but that's okay, isn't it? Right? You're going to come with us. Brilliant! Look at this. Live.
Okay, guys, following Mr.
One
Jordan.
other thing you're going to need, sir. You're going to need this, which is going to be your internet connection.
Okay.
Let's just double check that's all okay. Yes, it is. Right. Well, guys.
Following Mr. Jordan, then, guys.
On a little
Let's
adventure.
go and see if we can
We're
find
looking for
any
the
evergreen
deciduous.
or deciduous plants.
No, we won't. Yes, go on. Put your coats on very quickly. Okay, well, you don't. Not really that long. Go on, let's-
Okay, following Mr. Jordan, off we go, everyone. Let's go, let's go. Do you want to follow us out, miss?
Look behind you, wave to the camera. Okay, right, guys, we're going to come out this way, so because let's go through.
No, it's fine.
Come stand over here, please. That's really good. Come stand over here. Now, Mr. Keeling, going to get a little bit closer. It's gone a little bit on the old bright side. Can't really see very well, which is a bit unfortunate. Will you let go of that for 1 second, sir? We're going to try and make this work. It's a little bit saturated. I don't think it matters too much. Okay, right, guys. We've got over here, and I know it's a little bit hard for our viewers to see at the moment. We've got these big, broad leaves. Okay, what do you think these big, broad leaves are? Are they evergreen or deciduous? I like it, which means that these leaves are going to fall off when? When are they going to start falling off the tree? Autumn. I like that. Okay, they're going to fall off in the autumn. I think in the summer, because we're coming with spring. We're almost in summer. Are we in summer right now? Spring still. We're about to be in summer, and you can see they've got really big. And can you see how big they are? And what energy are they trying to get? Where are they trying to get their energy from? That's not the energy from the water. They're getting the energy from the sunlight. Absolutely right. Right. Well, shall we go and keep walking over this way?
Okay, follow Mr. Jordan, everyone.
Right.
Follow Mr. Jordan.
I'm going to hold on to the camera just for now, if that's okay. We're going to go through this way. They are sorrel, I think, and there's some animals.
All planted by the children as well, isn't it, sir?
Planted by the children, absolutely right.
Come along, children.
Oh, sir. Earlier on, sir, were you talking about being able to eat a really scrummy, yummy fruit?
I said earlier, remember, guys, I said eating a delicious, awesome apple. Do you remember that?
Can you see what is this, guys, that you can see here? Really? Oh, look, now you can see what is that on the live stream. That is an apple, guys. That is a fruit that this deciduous tree is growing. And that fruit is actually a way of this plant delivering its seeds to other animals. Because when an animal comes along and they eat on that apple, do you know what's on the inside of the apple? There are seeds. So the animal eats the seeds. They eat the seeds.
Mr.
It goes down
Jordan.
into the gut, and then the seed comes out down at the bottom in their poop, and it lands it somewhere else. So I've seen something else over here about seeds. You want to come have a look down here? Whoa! What on earth is this down here? So can I look at the camera?
Raspberry.
Oh, perfect. Can you see that raspberry?
Yeah.
Now, I'm actually going to pick this raspberry. Don't tell Mr. Martin. Look at that lovely raspberry. Now that raspberry is a load.
Mr. Martin.
It's a packet full of seeds, okay? And in that, loads of seeds. And if an animal eats that, then it can digest. So look, if I look at
No,
oh,
I ate it.
it tastes so good. Can you believe that?
You actually ate it.
I actually ate it. Right.
No way.
Now, so there's a little area where we've got some evergreen trees. We're gonna
Right.
go and walk over
Fabulous.
to those, okay? So come with me, guys.
Okay, careful, year one. Follow on with sir.
I'm
Oh,
allergic
guys,
to
do you know the name of this flower over here?
It's oxide daisy.
Wow.
Oxide.
It's oxide. Can I get a real close? Is it coming into view? I can't cover it. Oh, look at that. Can you see that?
Wow.
What did you call it? An oxide daisy?
It's an oxide daisy.
How fantastic is that? I absolutely love it. Brilliant. Right, come along now. Hello. Yeah, very saturated, I know. Not much you can do. Right, what we're going to do. We're going to just sneak down to one last place. We're going to go and see.
Okay, careful of the step, everyone.
Taking us on a journey through. We're trying to avoid looking at the other children. Right, year ones, are you with us? Can you come out front, year one? If you come out to the front. Not in this. We're going to go over to these trees over here. Can you come and have a look at them?
Yeah.
All right, brilliant. Let's go under here. It might be nice and dark, and then it'll be a little bit easy for us to see what's going on. Okay, let's get into the darkness under here, because this camera works best when it's nice and dark. Can you come in here, guys? Oh, that is so good. Come over here. Come.
Looks like an
You
evergreen.
come
around.
around over here, guys.
Stand in front of the
See
camera,
where
guys.
my finger's pointing. Oh, we can see you all perfectly now. This is what this camera needs. It's darkness. Right, guys. It does look like an evergreen tree. Do you think you could have a little look at these leaves? Do you want to pick a little bit of leaf? That's okay. What do you notice about them? Are they like those broad leaves? Are they like those?
These are evergreen tree.
Yeah, they are, aren't they?
When we saw that first.
Yeah.
Now,
you did?
sir, earlier you said that these leaves were covered in a type of wax. Is that the same wax that we do make?
I have absolutely zero idea. But I know that it is a kind of waxy kind of surface. Now, do you remember, guys, you said that they keep their leaves all year round. But if I look at the ground, what can you see all over the floor? Have a look. Get close. Close. Go down. Have a little look. What is it that you can see all over the floor? Oh, yeah.
But then it's not evergreen.
Yeah, but these, like your hair, these leaves are falling off all the time, and then they're kind of regrowing.
Even in the summer.
Even in the summer, sir, just like your hair, even in the summer, is clogging up those toilet drains. Then yeah, and also something that you'll see. Something else you'll see. Do you know what? This is an interesting thing specific to this tree, guys. Guys, you know the floor around here?
Yeah.
Can you see loads of grass and plants growing on it?
Yeah, no.
Have a look closely. Can you see loads
No,
of
no.
plants?
No.
Grass?
No.
Whoa, it looks pretty dead around here. Do you have any idea where that movie? Because if I look over there, I can see loads of grass. Oh, you can't on camera, but there is loads of grass. But over
So
here,
what
there isn't.
do you think, guys? What do you think these evergreen trees are blocking? What's stopping the Oh, what did you just
What did
say?
you say?
Sunlight.
They're
Ah,
blocking the
Two
sunlight.
things. One, yes, they do have a limited sunlight, although plants could grow. But there's also another thing: is that there's actually a kind of poison in the leaves.
Oh,
No.
Well, it won't be okay. It won't harm you, so don't worry about it. But it does damage the ground, and it stops any other plants from growing because this tree wants to be the only thing growing here. So
whoa.
it is kind of poisoning all the ground around it and stopping all these other plants from growing. That seems pretty incredible, doesn't it?
Yeah.
Yeah, and you can see what are these things in the ground over here. We're going to talk about these later, sir. Might as well maximize for 5 minutes.
Are you
Absolutely.
talking too fast? It looks like.
What are all these things in the ground? What are these?
It looks like branches.
Sticks or something? Well, these are the roots. Have you ever heard of roots?
Yeah.
Wow.
How's different than the
Roots, sir. That's what you have at the base of your hair, isn't it?
Oh, it's a bit like what you have at the base of your hair. You're actually not wrong, sir. The roots are digging into the ground. They're helping to take in all the water. Did you almost fall off that root? That's a long way to fall, isn't it? Terrifying. And they also help to give the tree a little bit of structure, solidity.
Yeah,
Right,
they anchor it in, don't they,
anchor
sir?
it.
They
Right,
anchor it
guys,
to the
We're
ground.
going to head back now. Are you ready to come with us?
I want to go today.
Good. We're going to go this way. You can do that when you come to Key Stage 2. Now, look, I want to just tell the live stream. It's going to get a little bit bright and you won't be able to see very well just for a minute because it's very sunny out here. I'm just going to hold the camera for now. Yeah, one, can you come in front of me? That's it. Very well done. Very good. Skipping away.
So, just a quiz then, sir. What have we learned so far? Is there any questions that we can ask our audience? I could ask, for a start, question 1, what is a deciduous tree?
That's a really good question. If we could put that into the chat and we can get the answer. What would your second question be, sir?
Oh, I would probably ask, what does evergreen mean?
Ooh, great question. Don't forget to write that down. If you've got a piece of paper, you can write that down, or if you want to put that into the chat. What's your third question, sir?
My third question is, why does the grass around evergreen trees not grow?
Why does, in some evergreen trees, why does it not grow?
Absolutely.
That's a very good question.
Could you also name for me the 4 seasons?
Oh, my goodness. 4 seasons. That's a hotel, isn't it, sir?
It is a hotel, sir. Well done, but it is also periods of the year.
Periods of the year. We're doing well. We're going to get in eventually. There we are. There we
Okay, and we go year 1. Thank you so much. Let's go inside.
go. Right.
Just get the marathon.
Oh, okay. Right, we're just going to pop this back onto here. Click that on. Lovely. Back to where we started.
Now what?
Now what? We're going to just take this out of Sir's pocket to make sure that doesn't get disturbed. And now what, guys? Well, the thing is, I think we've learned so much today, haven't we?
Yeah.
I said I think we've learned so much today, haven't we? Yeah.
Oh!
Really good. You're going to come onto here so we can see you as well. That's really good. Right, remember, there's the camera over there. Guys, you have been absolutely amazing. We have loved having you here. You have taught me and Mr. Keeling so many
much.
things. And we are really, really grateful for that. So thank you, guys. Thank you so much for that. Yes, and I'm going to have to say goodbye now. So will you say goodbye to the live stream for us? Can you say bye-bye?
Goodbye.
Brilliant. Right, guys, you're going to head off. We are so grateful for all that. And don't
Thank you
forget,
so much,
you
year
can watch
1.
exactly what you did.
Amazing
on the live stream
knowledge.
Later on.
Is it home time?
It's not home time.
No, it's the start of the school day.
Start of the school day.
Learning.
You've got maths.
Is it home
I
time?
don't know if you do. Do you do phonics? I'm not sure if year 1 does phonics,
We
but you
do
definitely do
do
maths.
phonics.
You do phonics. You've got phonics as well. Have fun. Bye.
Thank you so much.
Bye. Wow.
Wow.
Mr. Keeling.
Wow.
We learned
Lots
so
of knowledge that
many
we learned
knowledges.
there.
At least 6 or 7 different.
Yes, there
knowledges
was
there.
plenty of knowledge. Now, What time, sir, are we having our next guest?
We actually very shortly have a next guest. I'm looking at our timetable. That's why I'm moving them off. We've got a couple of minutes. That's
Fabulous. Well, I'm going to go into our slides and we're going to start because throughout today we are going to have visitors and that's going to be the main part of this morning. So Sarah's planned lots of visits from different classes. Later on in the day, though, we're going to move into full lessons using the board, a lot of written things and a lot of quizzes to keep us going through the day. We'll also learn about some famous scientists and we'll read some more texts. Not quite as exciting as the ones with the year ones, though, because there was lots of drama there. But we're going to have a look at some of the slides and we're going to get started because one area that we are looking at is, if we get it up, one area that we're looking at is going to be around plants. So we're going to dive in there straight away.
We're not really going to dive in there straight away.
Oh, we're not going to dive in there straight away because our next guests have come. Don't worry, though, we will go into that a little bit later on. No,
That was really
absolutely
cute to
fine.
teach that,
I was
but-
keen. I want to get onto my slides. I've made so many slides
Right.
for today. All right,
Well-
should we invite them straight in then?
I think we might as well. Let's do a little bit of preamble.
All right, preamble.
Could we have the screen that I can draw?
Absolutely.
Also,
Let's get rid of the one
For
that
some reason, the heat has turned on. So I've got to turn it off. It's absolutely boiling in here. And
So,
someone's turned the air conditioner off.
review in the chat. How are we doing so far?
Right, let's have a look. We're doing great. Look at that. It's amazing.
Whoa! Oh, we have got lots of
Yeah,
chat.
lots of chat. Right.
Lots and lots and lots of
I'm
chat.
going to put
Good.
this out over here.
Home time hidden there as well.
Are you ready?
I'm ready. Let's get our next
guests. Okay, guests. In you come, please. Come. over here.
Whoa! This has got to be year 6, right?
No, Mr. Keeling.
Hello.
I think you're my sister.
Don't say names. Don't say names.
Yeah, we don't say names,
That's
but
good, that's
great.
good. Very good.
What year group are you? You would look so big. You must be year 6s, right?
No.
What year group are you?
You're 4.
No, you're not year 4s.
Guys, I should tell you a little thing before you start this. That's where the camera is. So if you look at the screen, you won't be looking at the camera. Okay. So don't worry about what you look like over there. That's where you need to be looking if you're answering any questions. Is that okay?
Fabulous.
Yeah. Understand that? Brilliant. Sir.
Yeah.
I think they should tell us what we are doing. Who's going to tell us what we're doing? Yes.
You're going to be teaching for 26 hours.
That's very true. That's what we're doing overall. You're right. But you are teaching us something right now. Because me and Mr. Keeling, we found out from year 1 that we're very silly, aren't we?
Yeah, we got a lot of answers wrong. So
Yeah.
actually, we need your help.
So, yes, what is it you're doing?
We are doing science.
We're doing science. Now, you've all had all your things signed. I think it would be nice if we just had your first name and not your last name. Is that okay?
Yeah.
Could I just go through? What's your name?
Sabiha.
This is Sabiha. If you have a look into this, that's Sabiha. This is
Faizan,
Faizan. This is
Zachariah,
Zachariah,
Zara,
Zara,
Hamza,
Hamza, and
Mohammed.
Mohammed. Right, that is our team who's going to be
Wow.
helping us today. I wasn't listening to you. What did you say, Mohammed?
We are doing science.
We are doing science. He's so
Science,
right. And
wow.
specifically, guys, what have you been learning in science? Yes.
Digestion.
Digestion. And actually, if you pause there, that's the first thing. You can tell us about the other things in a minute. Is that all right?
Yeah.
I think, sir, we're going to start with digestion. Is that okay?
Digestion, yeah.
I'm
Let's
going to
go for
write
it.
digestion nice and big. Oh, I've still got the rainbow colour. Right, digestion. Now, I'm going to change this colour.
Yeah, try and go for a solid colour, sir, so it shows up on the stream a
Solid
bit
colour
better.
showing up on the screen. I'm actually going to get rid of all that and I'm going to make that nice and clear. So, digestion. Guys, whilst I am writing this about digestion, do you think, Mr. Keeling, you could tell him, just before we do an experiment, what do you know about the digestive system?
Should we take it one at a time? So it was in Mohammed? Right, Mohammed, could you tell me anything that you know so far about digestion or anything you've learned about digestion?
How it works and how the food goes from the mouth to the rectum.
The mouth to the rectum, that's quite a journey because actually inside the body there's lots of different organs that the food passes through, isn't it? It's not as simple as just eating it, it falls into your stomach and then it's a waste product. There's a journey through the body. So you've been learning about the body from...
It's like an adventure.
It's like an adventure. Oh, I love that. Okay, what was your name again? First name? Hamza. Hamza, can you tell me another fact about digestion?
Most of the organs we probably know called the mouth, esophagus, stomach, liver, rectum.
Whoa.
Intestine.
Whoa, large intestine and small. And is that true? Is the large intestine the large one and the small intestine the small one?
No. The small intestine is like 7 meters long.
7 meters? That's taller than me. How does that all fit in my belly? Okay. What's your name again? Sorry.
Yeah.
And remember to look at the camera, because this is where the people are watching you. Yeah. So I'll stand over here because you can look at me and you can look at the camera as well. What's your name again?
Zara.
Zara, could you tell people watching anything that you know about the digestive system?
The digestive system starts from your mouth, and the esophagus is 25 centimeters long.
Could you show me how long that is, roughly? How long is 25 centimeters? Do you know? Well, if we think about a 30 centimeter ruler, that's about that big, isn't it? 30 centimeters. So 25 centimeters is just smaller than that. Do you want to show me? Yeah, maybe a little bit longer. About like that. Yeah, about like that. So that is the length of the.
Esophagus.
Thank you. What's your name?
Zachariah.
Zachariah. Would you like to tell us anything that you know about the digestive system?
In the stomach, it breaks whatever we eat. It stays there for 4 to 6 hours.
And why does it stay there? What's it doing whilst it's in the stomach?
So it can break up into little pieces.
And is there something that we do before it gets to the stomach that helps us digest that food and helps us to break down that food?
Yes.
Could you tell me about that?
Because our mouth helps us chew it and
Chew it. Fabulous. What's your name again? Faison. So he was saying that the mouth, that's where you first start breaking down your food, isn't it? You start chewing it there. Is there anything else in your mouth that you know that helps you break down that food?
the teeth.
Well, the teeth, absolutely. And we're going to be doing a couple of lessons on teeth later.
What? If something's in your mouth, a lot of the time, you feel it, it's in there. And do you know what? More of it, when you see something really tasty.
Yeah, your mouth just
saliva.
fills.
What did you say?
Oh, saliva. And what is saliva? What does it do? Does anybody know what saliva is and what it does it do? There's a special word for it, isn't there, sir? For what it is. Yeah.
It moistens the food so it can swallow down more easily.
Absolutely. So
True.
it softens, it moistens. Absolutely.
And in it are something called
Enzymes.
Whoa, that's the word. Can somebody tell me something about enzymes? Could you tell me something about enzymes? Do you know anything about enzymes? That's right. You get your fact in your head, because I'll come to you in a moment. You get your fact in your head. Can anybody else tell us about enzymes, please? Go on.
When you see something yummy, your saliva it makes you want to eat that food.
Yeah, so you build up those enzymes in your mouth. Go ahead.
Like the enzyme, the saliva, it comes out automatically out of your mouth because you're looking at something good.
So your body, it registers the fact that you're about to eat or that it wants to eat, and it produces that. Mr. Jordan?
So, well, I know, and I think we remember that the enzymes, they help to break down our food as part of our digestive system, don't they? And different enzymes are produced at different parts of our bodies. And one of the things we were talking about, in fact, we could even test this. I think there's some bread, sir. Oh, there it is. We can even test this because you can do this at home as well. This is not our main experiment. It's not what we're doing.
Keep it in your mouth. It sweetens the
Oh my goodness. So one of the things that the enzymes in the saliva are doing is they are interacting with the carbohydrates. And what they're trying to do is they're breaking those carbohydrates. I'm just going to get rid of the crust bit, and I want to just have the main bread bit in the middle, if that's all right. They're interacting with the carbohydrates, and they're breaking them down and turning them into sugars that we can then start to get a bit of energy out of. Now, if you want to take a little piece of bread, now I want you to put it in your mouth. Okay, you can take a little piece of this. My hands are clean, don't worry, I just wash them. And what we're going to do is we're just going to put them in our mouth, and we're just going to keep it in the side of our mouth for a little while. Okay, and so we're all going to sound really silly for a bit. Is that okay?
Yeah.
We can do that. Okay. We're going to leave this in our mouth, so whilst I carry on talking with bread in my mouth. Okay, so
Just before we carry on talking,
Yeah.
I know you really want to because you've got the bread in your mouth and it's already making the sound.
Yeah.
We still need one more fact. So I'm just going to go back and do you think you can tell us a fact even with the bread in your mouth? Yeah? Go on, let's have a look. So what's your name? Could you tell me your name? Just on camera. Go on. Sabiha, could you tell us one fact, please, about the digestive
With the
system?
bread in your mouth, though, yeah? Good.
The digestive system starts with the mouth, then it slides down to the esophagus, then pops down to the stomach, then the stomach's acid breaks down.
Wonderful. The stomach's acid breaks things. And we mentioned acid earlier today. And do you know what I really loved about what you just said, Sabiha? I loved how you described the digestive system like it was the neighbours. They just pop round. Just pop to the just pop to the stomach. Really nice. Okay, so I'll let you talk now.
Well, all I'm going to say is, as we got this in the mouth, now we don't think of bread as being sweet, but I don't know if you occasionally taste it a little bit, and it might take a little bit longer. I'm starting to get a slightly sweeter taste in my mouth. Are any of you getting a little bit of sweetness in your mouth? Yeah, you're getting a little bit of sweetness. Now, bread is not something we normally think of as being sweet, is it?
Yeah.
But what's actually starting to happen now is the enzymes in your saliva are starting to break those carbohydrates down, and they're turning them into sugars, and it's starting to feel a little bit sweeter, isn't it? So I've still got it in my mouth. Does everyone want to be a bit disgusting and put it on their tongue and show the camera? All the disgusting, don't you want to do that? Is that too gross? No. Okay. Well, you can bite it, you can chew it if you want, guys. I think you might taste a little bit of it becoming sweet in your mouth. It's not something that you can do at home. Now, so we do have an experiment that we're going to do.
Fabulous.
But I'm thinking, should we just talk through the different stages first, and then we'll talk about which stage it is we are doing?
Guys, what I want you to do is, if Mr. Jordan is saying anything and it sparks a fact in your mind, okay? So if there's anything you want to add in, put your hand up, and then you can add on to what Mr. Jordan's saying. Because Mr. Jordan, you don't know everything about the digestive system, and you need a little bit of help.
I need a lot of help with everything. I mean, year one really helped me, sir.
They did. And if I have any silly questions, could you correct me if I get them wrong, year 4? Yeah?
And make sure you say silly, Mr. Keeling.
Yeah. Make sure you...
Right. First things first, we've got the mouth. And is there anything in the mouth? You've already told me. Yes, what's in the mouth? We've got the teeth. Now, by the way, you can keep that in your mouth or you can swallow it now if you want. It's up to you, yeah? It's up to you. I'm not going to complain. So, don't forget to answer some of these things. So, we've got the teeth, yeah, Zara?
Your teeth has calcium in it.
Whoa, you're absolutely right. Now, can anyone tell me anything about the teeth? Let's do the whole journey. Let's start, because it really begins in the mouth. What have we got?
The protected layer of the teeth is called the enamel.
Whoa, and you know what? At 4 o'clock today, we're going to be doing a test all about the enamel in the teeth. You did a test in class, didn't you?
Yeah.
Testing enamel. Save that, because we'll do that later. Tell me about those teeth. We've got enamel, calcium. Oh, stuff is just flying. Tell me something else.
The molars.
I know all about the molars, guys.
You do, sir.
So molars are little animals that dig holes into the ground and they leave molehills.
Silly Mr. Keeling.
Everyone say silly Mr. Keeling.
Silly. Your molars are your teeth that help you chew down food.
Oh, and are those the flat ones that help you to crush down your food at the back?
Like the roll. Look, like it's like example. It's like this is your molars. It's like these are your molars. It's like
Mohammed, can you do something?
Oh.
You know the skull in our
Yeah.
room? You can go and get it. You know where it is?
Yeah.
You're going to go
Oh
together.
yes.
You know where it is? The head, the skull, the cow?
Oh, wow, that would
Go
really
grab
help
the
me.
skull. We're going to see
Thank
some
you.
molars, real molars.
So we say molars. Are there any other
Yeah,
types
yeah.
of teeth, guys?
Your incisors.
Incisors, and those are the things that you use to cut paper with, aren't they?
No, those are scissors.
Oh, right, those are scissors. So
Everyone
what?
say silly
are-
Mr. Keeling.
Silly, Mr. Keeling.
So what are incisors then?
Incisors are
Incisors, sorry.
Incisors are your teeth.
And which teeth are your incisors?
Like the teeth at your front.
But what are they used for then? Because they're thin, aren't they? They're very thin, those teeth. What are they for?
For like crushing the food.
Oh, I think they're the back teeth, aren't they? The crushing ones. What are the front ones for? What's thin? What might it be doing? Say you put a piece of food in your mouth. What are they
It
doing?
makes it smaller.
It does, so it breaks it down into little pieces so that you can crush. So it
There's
is
a 10.
cutting.
Tearing
Yeah?
and cutting. aren't they?
Cutting.
Yeah.
And then do we have any other teeth? So we've got incisors, we've got molars, we've got canines. And canines, very, very sharp teeth, aren't they? Because they're part of a dog. A dog is a canine. So we're talking about
No,
dogs.
silly Mr. Keeling.
They're doing it even without you now. So.
Yeah.
So what are canines then?
Canines are the sharp teeth.
And what are they used for?
They're helpful also making the food smaller, because if it's not small, then it might like go down the wrong pipe.
Yeah.
There's two pipes. There's one that leads to your lungs, and then there's one that leads to your stomach.
I think you're looking a little bit frustrated about the two pipes there, sir.
No, I like the 2 pipes. Sorry, sir. I was just trying to think about those canines. I like 2 pipes. A big fan of 2 pipes. I was thinking about those canines. So they're
Right.
very sharp.
Yeah.
And they could have another purpose. You said just to make things smaller. What else could sharp teeth be good at doing?
Not crushing. Those are the back teeth
crushers,
again.
Yeah?
Slicing.
Yeah, it could be like slicing and tearing. But you know what? There are some animals. So would you just help them?
Yeah,
make sure
of course.
There are some animals that have. Oh, yes, that's what we want. We're going to say that for just one
Thank you
second.
so
There
much.
are some animals that have really sharp canines. What animal can you think that's got mostly canines? What's got loads of canines in its mouth? What animal can you think of? Can you think of an animal? Yes. Lions. Now, what do lions do with a lot of those canines?
bite.
Yeah, they're used for biting and to tearing into that throat so they can tear it out and they can kill their animals. Now look over here.
So this then, I believe, must be a lion, because you were saying
No, sir, it's
that.
silly.
No. Let me finish, please. You were saying that lions have lots of large flat teeth for chewing vegetables and for chewing plants and for crushing, because lions love plants.
Silly,
Mr. This is a cow. Let me prove it.
Okay.
These are cow's eyes. These teeth,
Yeah.
you see, these aren't over here.
Right. Oh,
So
okay.
then that means these are the molars, and they chew like the grass. So then that means if they chew grass, then that means this is a cow.
Oh,
Oh.
I love that. That is an absolutely accurate. So you're saying full of molars, must be some sort of cow, or definitely a herbivore. It is a cow, you're absolutely right. But a herbivore would have a mouth just like that. So I would imagine a sheep or a goat or any other herbivore, a deer maybe, would have loads and loads of molars, just as Mohammed said, for crushing. And oh my goodness, that was such a good explanation, Mohammed. Right, so looking at these teeth, it's a really basic drawing that I've done over here. But we've got the incisors, which are there for the tearing and the cutting. We've got those canines as well, which are for the sort of grabbing, the ripping, the biting into, and then the molars there are sort of crushing. So I'm going to just rub this out because we've got a lot of different things that we're going to be adding onto our journey. That's the mouth. You also spoke about the saliva for moistening things. What time are we on, sir?
We are on 10:30,
We've
sir.
got time. Right. For moistening things up and sending them down, because when you ate that bread in your mouth that people might be doing at home, what happened to that bread?
The sweet.
It got sweet, and also, was it stay dry?
No.
No, it got nice and wet and gooey, didn't it? So that we could swallow it down. What's this?
Esophagus.
Now, I happen to know a lot about esophagus, so I would
Brilliant.
like to come in and talk about this.
Yeah, take the
So,
pen, please. Take the
The
pen.
esophagus,
Oh.
which I've just rubbed out,
We'll go to this one here. So, there we go.
is part of ancient history, because when we talk about the esophagus, that is what they used to put mummies into.
Oh, yeah. Silly
Mr.
Mr.
Keeling.
Keeling.
He's thinking of a
the cough. Esophagus.
The sarcophagus.
sarcophagus. That's it.
That's what I was thinking of. All right, so what is the esophagus then?
Esophagus. It leads to your stomach. It doesn't. Because if it's in your mouth, how are you gonna get the mummy and put it inside the mouth and then it goes
Oh,
inside?
I'm so sorry. I'm forgetting we're doing
Mr.
digestion.
Keeling.
So at this point, then, food has gone into the mouth. Correct me if I'm wrong. Food has gone into the mouth, and I've used my different types of teeth. So I've either torn using my canines, or I've cut using my incisors, or I've crushed using my molars. I've used the saliva in my mouth and the enzymes that are in my mouth to break down my food. Then I've swallowed the food. The food then travels down the esophagus, down, which is basically a pipe, isn't it, that
Yeah.
connects the mouth to the
To the stomach.
stomach. So the broken down food travels down the esophagus into the stomach. And then you gave me a fact earlier about the stomach, because you said that inside the stomach
There's acid and then
there is
like
acid, and the food that travels down there waits inside the stomach for 4 to 6 hours. What happens during that time that food is in the stomach? Yes.
The food gets broken down by the acid in the stomach, which is named as the logos.
Wow. So it's broken down by the acid in the stomach. Why does it need to do that?
Because it has to move through the intestine.
Okay, and our intestines next then on our journey.
Can I ask you a quick question about the acid? Were we playing some acid earlier on? Sir?
Yeah.
Oh yes. What acid were we playing with?
You remember what that acid was?
Yeah.
What is this? Yeah.
Vinegar.
Oh yeah. Did you see the reaction this morning?
Yes.
Yeah, it was bubbling away because that acid was. So there was a reaction, wasn't there? When things went into it, it started bubbling and reacting. Is that a bit like what's going on in my stomach, sir?
I think so, and that's why when it gets into that stomach acid, it bubbles up and you get
What
lots of
sometimes happens when it bubbles up?
We burp, don't we? Because those gases travel back
Two
up
things.
that
One,
reaction.
you could vomit, couldn't wouldn't you? And then you would actually feel the acid in your mouth and you would have that horrible taste. That's the acid. And sometimes you feel it on your teeth, and it's not very nice.
If it's like the real acid, then it will like break your teeth down.
Oh, it would eventually. But we're talking about the bubbling that we saw earlier on. Bubble, bubble, bubble. It comes up, and then it's a burp. So your burps are natural. There's nothing wrong with them.
And that happens with everything, right? So everything I eat reacts with the acid, and all the gas always comes back out.
Absolutely, sir. Sorry, I just wanted to interrupt. Let's go.
Let's go.
Shall we, instead of talking about the next bit, shall we actually show what the next bit looks like? And do some actual... Shall we do this, sir?
I think we should.
Right. Now, guys, you are going to have to lead this a little bit more than me, Mr. Keeling, because I haven't done this experiment and you have done this experiment, which does sound surprising considering you're my class. But I have. Do you remember you did an experiment with tights? What were these tights representing? Can you remember? Yes, sir.
The stomach.
Yeah, part of it was the stomach and
The esophagus.
the
Intestines.
the intestines. I think it's the main
Or the rectum.
thing, or it could be the rectum, and it looks like I've got the wrong type of tights here, which is a little bit frustrating.
We need just need to cut something.
Right, you know, this is live.
These are something.
And these are very short.
Okay, if you do this at
short
home, you
tights.
do not want tights like this.
No.
These are totally the wrong type of tights.
And there's holes in it.
Yeah, but you want long kind of. So let's say you do this at home. You want long ones, okay? You know the tights that your mum or your dad might have that are really long. They go from all the way to the bottom, all the way to the top. That's the ones you want. But I tell you what, it doesn't matter. We're going to have a go with this tiny one. I tell you what, why do you think this tiny one's a bad example for your intestine? Who can tell me? Why is it a bad example? Yeah?
Because the intestine is way longer.
It's way longer, yeah.
And it's way wigglier.
And it's way wigglier. So we're going to do our best with what we've got. It's live. What can we do? I should have looked in the tights a little bit more. So we've already got holes at the end of it. Now, let's get a tray out in front of us. The tray's over here.
So you need a plastic bag as well.
Plastic bags I've got. Don't you worry. We're going to have a plastic bag for our stomach. Is that right?
Yeah.
And then we're going to put it into the intestine. Guys, will you all take a plastic bag each, please? A plastic bag. I'm glad that you're taking control of this. I didn't even realize we were doing a plastic bag. Just in case, that's all right.
I need one.
So here, I've got more plastic bags, don't you worry. Okay, and what shall we have? Well, we just ate it, so what would be really good to eat, do you think? Bread, right, guys. Do you want to get a little bit of bread? In fact, the first thing we're going to do, now can you hold that up to the camera for me, please? Can you just move out a little bit, Faizan? Is it Faizan? What's the name again? It's Faizan, sorry. So here's the stomach. Now, does bread go into the stomach like this? Guys, question for you. Look, is bread going to be in the stomach like this?
No. It's missing the acid.
One thing is missing. One thing is missing.
Coda.
Let's hang on. Let's slow down 1 second. So one thing, hold that up. One thing it's missing is the acid. I think there's something else missing from that bread. What has happened before the bread falls down into the stomach? Yeah.
It's broken down. It needs to be broken.
What is breaking it down?
The teeth.
The teeth. So guys, it's never going to end up in your stomach looking like this. It's going to need to be a little bit broken down. So would you guys mind just imagine you have the teeth. Don't break it down loads and loads, but just tear them up a little bit. I want all those little pits going into. So if you move to under here, would you go this way? I just want Mohammed's up on the screen because if people want to do this at home, they can see. You're going to hold it that way. Good lad. So we've got this, and what Mohammed's going to be doing, he's got the bread, and he's imagining that he's chewing it, and then as he chews it, he's dropping the little bits into the stomach bag like that.
Do that.
Okay.
Break
So
it down.
Mohammed, I'm going to leave you to do the rest of that, if that's okay. You don't need to hold it up. You can just carry on doing it like this. I'm going to put the camera down a little bit so we can all see what you're doing. Brilliant. So you get yourself over there, Faizan, into there, and you're going to go and grab yourself. Brilliant. Look at this. This looks like real science in action, sir.
Whoa! I really like the bit with the bread, sir.
I like the bit with the tights. That bit
Was good.
when I opened the tights.
And they weren't what you wanted.
No.
That was fun.
That was
good.
my favourite part.
Done.
Okay, so that's exactly what it's like, isn't it, in your stomach? Little bits of bread that are completely dry and nothing else.
Yeah.
Is that correct?
Yeah.
Is he right?
Am I right?
No.
Little dry bits of bread
Dry
in your
bits
stomach
of
with
bread.
nothing else.
No.
Can you explain what you say?
Sorry, what did we say? We need a liquid to act like, well, it's not saliva that's necessarily in the stomach, is
Well,
it?
it would have come down with saliva.
It might
He's
have
not
come
wrong.
down with
He's not wrong.
saliva.
Yeah.
But what do we need to act like? What do we need to replicate the stomach? Well, it's already gone down the esophagus if it's in the stomach. What's
The acid.
inside? Ah, the
Brilliant.
acid.
And I
Wonderful.
think we're going to use this. I don't even know if Coca-Cola is an acid, but we're going to use the Coca-Cola.
Well,
anyway.
vinegar certainly is.
It is, but
an
it
acid.
stinks too much. I'm not going to put that.
Oh, yeah.
Right, we're going to maybe Coke probably is acidic, isn't it? I think that's part of the reason why it's damaging. We're going to put a little bit of that in. I'm going to pour. If you hold that and face that way for me, that's perfect. Now look, we're going to replicate both the saliva and the acid that might be in your stomach by pouring a little bit. And guys, what is happening? Can you see all the bubbling and the reactions? If you hold that right up to here for me, I don't know if you can see on there, but this is bubbling away, reacting. And let's pour a little bit into all of yours. Thank you to be here. Right, I'm going to pour a little bit into yours.
Oh, no.
That's good. Pour a little bit into yours.
That's a little bit too much
A
now.
little bit too much. I'm going to pour that
Look at
into yours. You be very careful. Very sticky at the top.
Do we
pour
mash
that
it?
in.
Do you mash it?
Yeah, we are going to. We'll do it all together, shall we? So
Yeah,
everyone
so just
can
wait for everyone.
do the same thing, if that's okay.
Okay.
Gonna pour this in there, is that all right? So would you like it a bit in yours?
I would love a bit in mine. Thank you, sir. Oh, that's wonderful.
Don't mash it
Very
yet.
kind
Okay.
Right, there we go.
Please stop, Mohammed.
Right, now, one thing I don't know if we mentioned earlier on is that the stomach is not just like just a plain sac that just sits there, is it? What else does the stomach do? Who can tell me? Sorry, you're answering low. Just wondering if I can get some more involvement from Zach. Can you think? What else does the stomach do? I want your brain switching on. Well, come on.
It breaks up.
It does what? What's it doing?
What's it do that?
It crushes.
It crushes, it
Oh,
squeezes,
wow.
It
doesn't it?
crushes it really smaller as soon as it's food to get more lower.
Right, guys, can you do that then? And can you show? Yeah,
Right,
let's
there we go. We're going to break
Oh,
down
nice.
that food.
Oh.
So, I don't know if this is true. Could I fact check something with you?
Yeah, please.
Is it true that when you are digesting your food, it takes a pint of blood within your system to help break down that food as it's moving through the digestive system?
So,
And because you're using that pint of blood to help you with the breaking down of your food, you become more tired during the process
I've heard that.
of digestion.
Do you know what I'm going to do? I'm going to give a full fact check on that. So,
Fabulous.
do you use?
Oh, this is starting to look a little bit more gross than when I started, to be honest. Let's simulate that action of the stomach. Grab it and crush it right down like the stomach would do. Mix it with that acid and show the camera it breaking down. Everyone, can we see what's happening to it? What's happening to the bread?
It's getting crushed. You can barely see the bread, guys. Look. Guys, just believe it. It's supposed to be cool.
Well, that's interesting, isn't it? Because you're saying at the moment that this currently looks like food. And actually, the body, when it breaks things down, it takes out the key nutrients, the things that you need to survive
Isn't that
for
what
your
it
body.
is?
Yeah, absolutely.
Can I come into your
And as
fact
it
check,
moves
sir?
along. Oh, yes, my fact check.
So I've done some fact checking online. There is no scientific proof of exactly how much blood is used in the process of digesting food. However, sir,
Right.
it does say one of the reasons you might feel tired is because blood is being more redirected towards the digestive area. So even though it's not a number,
Wow.
it more is being redigested there and maybe less energy up here is the implication from the internet.
So it must be why I'm tired, because I'm digesting so
It is,
much.
that bit is exactly right.
Wow. And later tonight, when we're on for these 26 hours,
Mhm.
we'll be tired
Yeah.
because we're digesting.
We are digesting. And do you know, guys, I hope you tune
Our
in.
bread is going to the process right now.
Whoa! Tell the camera that. What's happening to the bread, Mohammed?
Our bread is process right now.
Yep. It's going through the process right now of
Because
digestion.
we ate it when we were showing you how the bread sweetens.
So literally what is happening in your stomach right now is literally what's happening right here. Is that right?
Yeah.
Wow.
Yeah, it's green.
Right, guys, now this bit now. Are we mushed up enough, do we think?
Yeah.
Right, okay. I'm concerned that I put way too much
Mushing
coke in,
bread
but hey ho.
now. I can punch
What can we
you
do?
with your-
Right.
So
Okay.
what's the next step in the experiment then? So this is the stomach.
Yeah.
What comes next? Because like Sir said, we weren't there.
Intestine.
So it needs to travel through the intestines. And what
No.
are we using as the intestines?
The tights.
So what are we going to have to do then?
So we're gonna pour it tight inside the tights. Pour it into the tights.
And I think because Mr. Jordan was the one who purchased the tights,
Well, I found
he
the
should
tights.
definitely be the one that holds the tights as we push the liquids through. What do you think?
No.
I think so, Mr. Jordan.
Well,
I might save mine to the end because mine is really, really quite moist and wet in here.
They do say tights on them, don't they?
They do say tights on.
Yeah, on the front.
Yeah.
You turn over.
There must be some I don't know. I don't wear
Yeah,
tights.
those are for some tights. Like,
That's true. During the week, I don't wear tights, so I don't know what. They're
those
right.
are skirt tights.
Okay. Right. Let's. Should we start this off then? So who's
Yeah,
going to pour a
me.
little bit in? Right.
Me.
Zara Singh, is you there? So we're going to pour a little bit in. Oh wow! Now it is going into, and you can see. Can we do it that angle? We can see that we've got the stomach is now pouring. Oh, now look at the bottom. I don't know if you can see, but liquid is actually coming out already, and that is true. That would be happening in the digestive system. That the liquids are going to be coming through and putting. Now I need to get some more of that. Oh, okay. Now as it comes so short, so we can't really see the process. Now look inside here. I don't know if you know, but can you see on the screen maybe that as it's squeezed through, the liquid is being squeezed out. That's going into my body. And I've not actually had a solid out of the bottom yet. So we're going to pour a little bit more in if you can do. Just going to squeeze it down. We've got the last bit in the toothpaste, yeah? That's brilliant. And if you want to pop that other way, I think I've got enough in there. So as it's going through the intestine, it's being sort of squeezed. The liquids are coming out. This is all the goodness and juices that are going into my body. But eventually, something is going to have to come out at the bottom. And as it goes through, and I keep pushing it, if we can get a shot on this, sir.
Yeah,
Going
let's go
through.
right in. Can somebody hold my digestive?
Uh-oh, so it's already starting to happen.
Oh no, okay, we're coming
It's
in.
already
We're coming
starting
in.
to happen. That if you go down a little bit more, is that as
Oh,
this
no,
goes
okay.
through, bit of dried up kind of, what is this that's coming out at the bottom? Yeah, it
The
is.
stories.
Oh, some
Feces.
feces.
Yeah, absolutely. So it's the
So
waste product from the
So-
digestive system. So what would all of this liquid be then,
This
sir?
is the dried. Can we have a little shot on that?
Yeah.
The dried bit of feces. No, wait a second. The dried feces that's coming out. Should we do that again and have another look if someone else has got
Yeah,
one?
does somebody else want to put it through the tights again?
The tights.
All right, this one's quite a thick one, sir. Maybe we try this one. How
Right.
about that?
Okay. I'll tell you what. We can pour two of them in.
Yeah,
So
go
let's
ahead.
Get this one poured in, please, to the top of the.
So that's the food traveling from the stomach
leaving the stomach.
into the. Is it the large or the small intestine
Ooh,
first?
guys, which one first? Are you sure it's the large first?
Small.
It is the small one first. So can you
It's
get
not
some of that?
actually small.
We've got the. It's not actually small.
Yeah, it's longer than that, but the
Oh, lovely. So
thick intestine.
yeah.
The big
You
the,
get yours in as well.
the thick intestine isn't large; it's just thick, and the small intestine is thin and it's very long.
Right, I love that. Now, look, we have got a couple of stomachs in. This is killing my back for some reason. I need to just slightly change my angle a little bit.
No.
Don't worry about that. That's a little bit sick. Just being a little bit sick there. That's okay. Right, now, look at all that is in here. Now, look, in here, this is quite important. As it squeezes, can you see what's happening as we
Yeah, you can
squeeze?
see
And does that happen in the body? Does it actually lose
Yeah.
water through the intestines?
Absolutely.
then?
I don't know which exact part, but we are constantly, as the food is passed through as a liquid, your body is taking out the things that it wants. Now, whilst it's in here, guys, can you answer me this, just whilst I'm squeezing this? Because is it just us doing our digestive system on our own?
No, it's our body doing it with us.
True. And is there anything else that helps us with our digestion other than us and our body?
Is there anything inside of us that might
Bacteria.
help us?
Bacteria,
Oh,
A
microbes!
Right. We have a
Symbiotic relationship.
We do. We have a
The
symbiotic.
white blood cells kill all the bacteria.
You're absolutely right. So we have a symbiotic relationship going on inside our body.
Yeah,
And
and
as
when-
this is going through, and the other creatures that live within us, the bacteria and all the other, there are fungus inside us as well, aren't they? Go on, Zara.
And when you get like dots and then yellow things oozes out of it, it's our white blood cells that fought for us for
Yeah,
our
your white
body.
blood cells are fine
And
for your
if
body.
you see like just clear thing, it means that it survived, but
Now that's really good. That's a little bit less than the digestive system, but that's about, you're absolutely right, that's about your body's defense against infection. So those bacteria that are in our digestive system, what are they helping to do?
Yeah.
Yes.
kill the pathogens.
Well, that's the ones that are inside. You're right. We do have microbes in our body that are helping to kill pathogens. You are 100% right. Can you think of any other things they're doing? Remember, it's a little bit like what the saliva is doing.
It moisturizes. It breaks it down.
It's helping to break down the food, and it's helping us to get out something. I know you all did say, helping us get out of it. Right, getting this nice and squeezed. Now let's have a look, sir. Now, what I'm also doing with these, am I sort of just grabbing at it? What am I kind of doing with this? I'm kind of massaging it down, and just like in your esophagus, did you know you can drink upside down?
Yeah, but you know the blood, it rushes to your brain. And
That's true. You shouldn't stay upside down for too long. But I sort of think maybe we should test that out, so whether you can drink upside down.
No.
I think later today, if we're low on ideas, I'll try and drink upside down for
Okay,
you.
I so think we should get a child to do that right now. But okay. No?
I will do it. I'll do it.
I think we finished digestion first. Let's go through that.
I really want to hang one of you upside
Can
down
we
and make
do
a drink.
our food?
Right, hold on.
There we go.
So now, look, what's happening is being squeezed through. So can we get a nice close shot, please, into a little bit closer maybe? And now what's happening at the very end, as that squeezes through, we're going to be left with, it's
The poo.
really
The
not
feces.
come through like I was hoping. I'm going to try one more time.
It's coming. It's coming.
Okay, it's coming. Now this we can fit. Oh, so can we see in there? Here we go. Yeah, and that's pretty much it, I think. Oh, a little bit left. Bam. There we go.
And there we go, the
and
waste product.
You can see it's brown. All the goodness has been taken out. It's kind of dried up as well. And can you see where it was all liquid earlier on and gooey, it's now turned into this kind of solid mass. And that's a bit like the poop.
And does the body, sir, a quick question, does the body always take out all of the good things from what you eat? Is that the only thing that it takes out and then gets rid of all of the waste?
Unfortunately, it's not.
It also takes the bacteria.
It takes all sorts of things out of food, doesn't it?
You can save someone with your poo.
You can save how?
Because if someone has an infection in their intestines,
Yeah.
and
What's that
then
wrong?
you can get something.
No,
your poo
that is
out.
that is
You
that
are
is true. That is an
absolutely-
absolute
that's a very
fact.
Smart fact. Yeah.
In fact, you know,
Yakult.
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 Yeah, Yakult is a good fact.
It's healthy
Yakult
poo.
was originally made.
Yeah.
I mean, we can't say that every bottle is full of healthy poo.
Right.
It's full of healthy bacteria that started from someone's healthy stool.
Yeah.
And that's quite interesting. Yeah.
I noticed they've tried to hide that fact recently, but it is bacteria from healthy inside of your bowels. So I think that's absolutely amazing. I did have another question. I got really distracted by the healthy poo thing, which I really enjoyed. I really enjoyed the idea of healthy poo in case you get poorly.
Yeah.
It's totally taken me off track. Where were we?
Well, we got to the excrement part
Excrement
of
part.
the digestive system, and you were maybe going to draw some diagrams on the board about what is happening in the different organs
Do you
at the
think
time.
whilst I'm doing that, the remaining stomachs, and maybe the children could do this experiment rather than me doing it each time. I'm going to wash my hands and I'll put some facts on. So if we cover over children, you've got a few more stomachs. If you want to take a few of these,
Yeah.
so we can see what you
Over the
do
tray.
yourself.
Why don't you push it through and see what comes out the other side? Make sure you hold it over the trays as you do it, yeah? And we'll see
Sir, can we put
what
yours
happens.
through
Here we
there?
go.
Sir, can we put yours through
Yes,
there?
you can put mine through. Put it all
Zach,
through.
Zach, can I have Mr. Keeling?
Make sure you grab it at the top though, like that as you push it in, because otherwise it will go straight through. Make sure you hold it. Okay, and we can get the water coming through here. Push it through. Okay, all of it. The solid. One of you will have to hold it like I'm doing so that the solid doesn't get through straight away. Okay, make sure all the solids get in as well. Okay, I can start feeling the solids passing through. Can you remind me again the length of the small intestine?
7 meters.
Okay, so it's got to travel through those 7 meters
It
of
also
small
It
intestines.
takes 36 or 32 hours to travel all around your body.
Okay, so obviously this is a lot shorter, so it's going to travel a lot quicker. But do you want to start pushing that waste through now that it's dry, so we can see it coming out the other end? All right, boys, that's it. We need to open up the bag. Oh, sorry. Need to open up the bag so it comes through, and let's put. Oh, that one's. Oh.
I could feel
Someone's got a lot of liquid there, haven't they?
It does look like diarrhea.
Yes, so maybe this one's been broken down a little bit too much.
Do
as
you
it's
know when
passing
you've got
through the body.
diarrhea? That's because your body
It's,
is.
your poo is runny because it's been going around.
Okay,
your
push
body
that
for
through.
long.
Yeah, but your body is really trying to expel everything, any kind of dangerous
Remember,
bacteria.
try and catch that, because otherwise it's just going to completely drop through, isn't it? And it's not going to work like that. So
Get out.
generally, that's it.
So
Push it in.
the poo. No. Okay, I think we should put those types
Okay,
in.
I think let's try
We'll
and
keep the types maybe
push that
inside
through.
here, all the dirty stuff. We'll just
That's
keep it
solid.
in.
You want to work that
I think
through,
that's a good
boys.
idea.
and we'll see what comes out.
Our hands are very
And
red.
I would
you
say,
don't
sir,
think
I would say we've made quite a mess.
Oh,
Wouldn't you agree?
quite. Do you know what? That's the fun of science: making a mess, exploring things, having science. There's definitely over here now. That's interesting because these ones are a bit more diarrhea-y than mine, and I think part of the reason why they're a little bit wetter, a little bit more diarrhea, could be two things. One, they could have had a little.
More acid.
It could be, yeah, it could be an infection. Maybe that your microbiome wasn't functioning properly, and what was happening is, oh gosh, that's been flicked right into my eye.
Oh,
Is
same.
that I'm fine? Yeah. Is that the microbes, because of the illness, weren't responding properly? They weren't breaking down the food properly, and it was being expelled. Yeah. So, and it could have just been that your gut, your intestines weren't working properly. They weren't absorbing that water out in the same way. If you do ever have diarrhea, it's really important to stay very hydrated. What I would say is, if we use a little bit of tissue here, whilst I tidy some, take a little bit of tissue. Then can you go over to the sink, guys? Can you go and wash your hands? Leave all the mess inside the containers rather than on the outside. Go over to the sink.
Okay, guys, while we're washing our hands over here, if sir, you'd like to start explaining the digestive system,
I'm going to explain the
then
digestive
the guys
system
can join back
whilst
in.
trying to tidy some of this. So I think those children did a really good explanation, and not really much that I can add to it, but I'm certainly going to try my best. So we started off with the mouth, didn't we? And the mouth is a very good place to start. It has all of those teeth. If you remember rightly, if you can put into the chat, what were the 3 different types of teeth? Well, there are 4 different types of teeth. What were the different types of teeth that we managed to see in the mouth? If you can pop those into the chat, that would be really, really good. See a little bit coming up. That's great. So yeah, we did. We had those molars, which are kind of flatter and larger. Actually, I'm trying to rub it up with my fingers. We had those molars, which are larger and flatter, and they are literally for grinding and grinding. We had those canines, which are really for biting in and holding on to that food. And we had those incisors, and they're really for kind of cutting and for tearing that food into little bits. So depending on what animal you've got, obviously if you've got a herbivore, the herbivore is going to have predominantly the molars, because the molars are used to breaking down the vegetables, which need a lot more grinding. If you've got more of a carnivorous creature, whether it be some kind of lion or a wild dog or something, they're going to have predominantly the canines. The canines, not only are they used for tearing into that meat, but they're also used as a weapon that they use for attacking and killing their prey. And the other thing about the teeth, if you're an omnivore, a bit like us, I hope I brushed my teeth this morning, but I've got the incisors, I've also got the canines, and I've got the molars at the back. Because I'm an omnivore, I do all different things. I kind of predominantly have a vegetable-based diet, vegetables and fruits and things, which I'm using for breaking, which I'm using my molars to break down the food as much as possible. But I'm also eating meats and other things that I need to tear with my incisors and my canines for. So if you looked in an omnivore's mouth, you would probably see that they would have a variety of all the different teeth. So the next part, we came out of the mouth and we went into the esophagus. Now the esophagus, it's not really doing anything major, but I would say it's part of the digestive system. It's massaging the food down and getting it into the stomach. And part of the reaction from the saliva is happening still whilst it's going in the esophagus. So all of the enzymes that are in the saliva are still in the process of breaking it all down. If you just get your hands off that, so it's not so obvious, that's great. In the esophagus on that long journey down. And it isn't just a droppy tube, okay? Like I said, you can drink upside down. It is taking these things and it is massaging it. So even if you're upside down, it will massage that drink or liquid or food into your stomach. It's not great to stay upside down for long periods of time, so obviously. Now, once we're into that stomach, as we said earlier, we've got all of those acids that start getting into it, but the stomach is also doing another thing where it is crushing and it is grinding and it is mashing it all up. And it is a place to store it. Actually, your food stays in your stomach for quite a long period of time. At lunchtime, you might still have your breakfast inside your stomach.
Now,
so that's why.
Sir, I'm so sorry to interrupt, but just checking the time, I can see that we're about to have new visitors. So would it be very sensible for me to just say goodbye from the year 4s and for me to walk them back so that they can get back into the school?
That is probably a good idea. Should we, or either that, sir, or unless you do want to go back in school for reasons, the person who comes to drop off the year 3s will be able to take them back.
Oh, is that correct?
Yes.
Sorry, sir.
Not a problem at all. So, guys, I tell you what, seeing as you're about to go, we don't need to listen to my voice too much. You are the absolute science expert. Is there anything more? I tell you what, you know what? You don't even have to talk about the digestive system. It's a science day.
Oh, yeah. it'd be great if you've got any questions for us about science.
Just
Then
generally.
maybe me and Mr. Jordan could answer for
If
you.
you're going to move back a little bit, I'm just going to line you up and I tell you what. So, would it be helpful if we're both on this kind of side, so looking at us, or you just remember to look that way?
I think, yeah. So if it's just you guys,
Yeah.
if you ask your questions,
Then
we
you can-
will try and answer those questions for you.
Yeah. What's
So,
your questions?
any
Science
questions about science at all? Yeah, go ahead.
Yes, Zach.
How long is it? How long is the esophagus?
That is such a great question. I heard the answer earlier
It
on.
was 25 centimeters, wasn't it long? Because
Brilliant.
we all showed it on our hands, didn't we?
We did.
That's cheating.
You know.
I was fact checking.
You know.
Dr.
that-
Google.
You know that
But you cannot tell them how much.
a school ruler is 30 centimeters, and you know how a big school ruler is. Show me a school ruler. Yeah, right. Well, yeah, about that. You use them all the time. So just take away 5 centimeters, is a tiny amount. Just take that away. That's what your esophagus is. So if you can imagine that from here to here,
cheating.
then that's great. He's just keeping on top of it.
Okay, any other questions?
Next question.
Yeah, go ahead.
How long would it take?
Mm.
Like, how long would it take if you stored like loads of food into your digestive?
So from
System,
mouth
like
to
you-
rectum, how long would it take? Is that your question?
Yeah.
Right.
No, like
Usually
like,
takes about 36 to 48 hours,
No,
doesn't
like-
it, to
no,
travel all the way through?
You're like you're
Hold on.
eating a lot of food.
So if you're eating a lot of food, I don't think the amount of food changes massively, but I'd have to fact check that one.
I would have to fact check because I don't know if it pushes the rest through
Yeah,
or if your body
through.
reaches a limit. All right, we're asking a lot about the digestive system, but this is anything. If you've got any questions about anything scientific, ask it now.
Zara.
Why does a food chain start with the producer?
Oh, that's a great question. Now, I think all food chains, sorry, I'm jumping in. I don't want to jump in.
Cheating.
All food chains start with something. What do all food chains start with? Zach, over there, concentrating, aren't you? What is at the start of all food chains? Yes.
The producer?
Can we think? What could it be? There's one thing, there's one thing that, yeah.
The plants?
I think there's something before the plants. So.
No, the
I think year one taught us that this morning.
Mm.
Yeah?
The sun.
Oh,
The
the
sun.
energy from the sun. Because if we remember, if we didn't have energy from the sun, if we didn't have light, and if we didn't have that energy, there would be
Then
nothing,
you
would
nearly
there?
all of the
Go for it.
in 2 weeks, nearly the whole entire world would be covered in ice because there's no sun to
She's
make
so
it.
right. It'd probably be less than 2 weeks,
Or
Yeah.
probably like 1 week.
Yep,
It wouldn't take
pretty
very long.
instant.
It would be,
Yeah.
it would be very, very cold.
Very
Life would suffer very, very quickly. So, yeah, absolutely. It starts with that energy from the sun. And from that energy, plants can grow. But they also need something else to grow.
Water.
You are so right.
Absolutely. They need
And
water.
without water, we're all useless. Sir, can we come in a second to this?
Absolutely.
Into here,
Because I
sir?
think
And
we've
can we
got our
just
new
say
visitors, haven't
a
we?
massive thank you here to Year 4. You've been absolutely fantastic. So thank you, guys. And would you all, have you got anything you'd like to say before we go?
No.
No?
No.
That's it?
All right.
Done? Nothing?
See you later.
Right, everyone say bye-bye.
Bye.
Thanks so much. Oh, guys, don't forget, because we're trying to raise money, aren't we? Yeah. So
Yeah,
our
yeah.
donation
Let's check on the
code
donation. Where
is
are we at?
just. Oh yeah, let's have a check.
We're
Let's
going
just
to
have a
live
check.
check just
Just
before
be
Miss
a
Love
minute,
just
miss.
comes in.
We'll
We're going
call
to do
you
a
in a
live check.
second. All right.
And we're going to see how much money have we raised so far. How much money did I have?
Okay.
2 million.
So
2 million.
2 million, close to 2
500
million.
pounds. I think 500 pounds is a good guess. So we've got 500 over here. Someone want to get
Okay.
something around there, yeah?
6,000.
That's
Please
very large
give
amount of
us a
money.
donation.
You're
So
thinking
here we
there,
go. Get
okay.
ready. We are at the minute. We are
Can we have a
at
drum roll, guys? Drum roll. Where are we at?
1,585 pounds. We are so close to 1,600. If you're watching
What do
now,
we need from people?
please donate.
We need their money. Donate. Excellent. Right, everyone say bye.
Bye.
Right, guys, you're going to come this way, so if you'll come to the screen in a second. So we've got
Absolutely.
somebody not in the screen. I'm going to keep my hand here just to make sure we're still in. We're still in.
We're still in.
Stop,
We're still in.
stop. Right. Excellent.
Okay, so we are now awaiting our year 3 children who have been working hard on magnets and magnetism. And later in the stream today, we're going to have a lesson all around magnets and magnetism. Year 3, would you like to come this way for me? Come on. And then we'll introduce you. Can you stand up? Come on. Okay. Right.
we'll go from this side first. This is the
Can we?
camera, so-
Sorry, can you make sure you just say your first name and not your last name?
Yeah, not your last name, just your first name. When you're speaking, if you have a look into this camera, because that's where everyone's watching at the minute. And can we start off by asking everyone to please donate as much as they can? If they've got hundreds in their bank, ask them for hundreds of pounds. Yeah, please donate.
Please donate.
Please donate.
Lovely, wonderful. And let's go through our names then. So, what's your name, please?
Isa Hussein.
Oh, remember, we're
Oh,
gonna do
just first name,
aren't we?
Isa.
Just
Thank
first
you.
names.
So, Isa. Okay, and we've got
Kian.
Kian. So we've got Isa. We've got Kian. What else have we
Isa.
got? We've got
Isa.
another Isa. So Isa and Isa. And we've got Kian. And who have we got here?
Tahin.
Tahin. Nice to meet you. And who have we got over here?
Fan.
Hassan. And we've got.
Mehmed.
Right, now I see that you've brought some things.
Miss took your suggestion very seriously.
I can see that Miss took my suggestion very seriously. And
Okay.
I've actually built a football
Do you
game.
think before we show the football game, we could talk a little bit, and then we'll do this as the thing?
Yeah, no,
that'd be
this
good.
can be the
So,
thing.
guys, I tell you what, will you put your players down here, and we'll find out a little bit about what is
Yeah,
going on
that's
with
a good
these
idea.
in a little bit.
Okay.
I'm very excited to see this whole situation. I really am. I can't
But
wait.
could you start off, guys, by telling us why are you here today? What are you going to be telling us about? Can someone? Yeah, go ahead. Tell the camera. What are you here to talk about today? Go ahead.
We're here to show what magnets are about.
So we're going to be learning something about magnets. Can anybody else tell me anything about magnets? Anything you want to share? Thank you, sir. He's written magnets on the board in the back there. That's very helpful because now we know for sure that we are going to be talking about magnets. When you said magnets, I wasn't 100%, but now that sir's written it, I'm pretty sure
Now
we're
we
going to be
know.
talking about.
And
Now
you know
we
what
know.
year they're in now. So
We know. Yes, now we know. Okay, and over here, what else?
When two poles meet together, yeah, they repel.
Okay, and what do you mean by poles?
Then two poles called north and south.
I know what
North and south. So what are we talking about when we talk about north and south poles? Do you mean like the top of the earth and the bottom of the earth?
No.
Well, I mean, actually, the top of the earth and the bottom of the earth is magnetic, and we will learn a little bit about that later on as well in the lesson today. But can you tell me what you're referring to when you speak about a north and a south pole in relation to magnets? What do you mean?
Like the magnetic things that connect.
So each magnet has a north pole, doesn't it? And a south pole, yeah? So one half of the magnet is its north pole, the other half of the magnet is the south pole. And what you were saying was something about repelling, because there's two words that are key for magnets. One is repel, and what does repel mean? Yeah, go ahead.
They go directly.
Yeah, they push, don't they? They push away from each other. It's a force that makes them repel, push away from one another. What is the other word then for the opposite of that to do with magnets? Yeah.
Attract.
Attract. Lovely. So magnets can either repel each other or they can attract each other when they pull together. Right. Can you tell me what would happen then if I put a north pole of a magnet next to a north pole of another magnet, please? Go ahead.
They will repel.
They would repel. So what do I need to do then to attract two magnets together? Yeah.
Put two different poles together.
So what two poles could I put together?
North and south.
I could put north and south, south and north, yeah? When they are the opposite poles, they will attract. But are magnets the only thing that are attracted by other magnets?
Please say.
So if we're talking about magnets, if I have a magnet like that, and we've said that a magnet has a north and a south pole, we've said that magnets, if the north poles are together, they will repel each other.
Wow.
And if the south poles are together, they will repel each other. We've also said that if the opposite poles are together, so if I have a magnet here, and the south pole is next to the north pole, and the north pole is next to the south pole, they will attract each other. That's what we've said, yeah? What if I just have one magnet? I have one magnet with a north and a south pole. Is there anything else other than magnets that can attract? Ooh. Sir?
Is it bees?
No, you are thinking of flowers, sir, and we'll talk about pollination and plants later.
So
But right now, I think we all need to call you silly Mr. Jordan. So can we all turn around to Mr. Jordan? Because every time he says something silly, we're going to say silly Mr. Jordan. 3, 2, 1.
Silly Mr. Jordan.
Okay, so you're thinking of plants and pollination, and that would be a very, very smart answer, sir, if we were on the right topic, which we are not.
Got it. Okay.
Okay, so we have our magnet. Can anybody tell me something that is going to be attracted to our magnet? Yeah, go ahead.
Metal.
Metal. So if I take all metal, let's say I have zinc, a zinc coin and a copper coin there. Both of those are going to be attracted to the magnet. Is that what you're telling me? What do we think?
Did you say zinc copper?
Zinc and copper.
Oh, zinc.
Do we think they are going to be attracted
No,
to
no.
the magnet?
Not all metals can be magnetic.
Oh, I really like that. So someone said that metal is attracted to magnets, but then we were told, sir, that not all metals are attracted to magnets. In fact, there's very few objects that are magnetic.
I've got a battery over here, and this battery is made of metal. So presumably this battery will be attracted to this, right? Metal, right? Surely you can feel it. Oh, that's amazing. Well, Miss, would you just mind grabbing that up?
That's
Would you mind
zinc
bringing that
carbon.
over?
Fabulous, thank
This
you.
is very important.
Mr. Jordan, I don't think it's zinc carbon.
Well, feel it. It's metal, though, right? You agree? He's right about the zinc in it. So that's perfect. I'm going to use that in 1
I
second.
don't think that might be magnetic.
Well, shall we check? Because we can tell if we look on here, this is definitely metal. I can see that. And here we have a magnet, don't we? So shall we try it? What do you think is going to happen? Do you think it's going to be magnetic or non-magnetic?
Not magnetic.
Okay, I'm going to hold it upside down. So the reason that's there because we can put it on the screen. And
Oh, it was on the screen. Okay.
yeah. And look, we're going to. Oh, you were wrong. Oh, so some metals are, some metals are not. And you know what we're going to do now? We're going to explore magnetism with different materials, and we're going to go over to another table. But just hang here 1 second while I make sure that this works. Let's change this to this. Computer's gone off. That doesn't need to charge. Oh, brilliant. So we're just going to angle
Okay.
a little bit. Other way.
Other way.
That is perfect.
Okay. Great.
Oh, actually, can you turn it? Can you flip it around?
Sure. How's that looking?
Amazing. Can I just describe these, sir, before the kids go over to you?
Absolutely.
So we've got here, and do you mind if I'm going to bring this camera a little bit further forward because we are all going to watch it through this screen. Basically, I'm going to move it to. Can you just watch out for the? There we go. You can't see your head. I'm going to put this up here. Right, so let's just move out the way a little bit whilst we just go through, and I'm going to explain these materials. Oh, there's a monster! I'm going to explain these materials first, and then you guys are going to go around with Mr. Keeling, and you're going to go through and make some predictions. So, just to be very clear, up here we've got some seashells. Over here we've got some wood. Sir, can you point to the wood? Brilliant. We've got some plastic beads, if you could point to those for us. We've got washers, string, chalk, foam, paper clips, brass screws, cloth. Let's go down again. Paper. We've got drawing pins, pebbles, aluminium foil, polystyrene, feathers, copper clips, nails. Are we talking fingernails there, sir? I think we are. Stainless steel. And the final one there is rice. So we've got a variety. Oh, it's here all along. Great. Thank you, sir. We've got a variety of all sorts of different materials. And guys, do you think you would be able to now go to the science zone and do some testing for me? Right, guys, let's go over there. We're going to head over to the science zone. You're going to go that way, and you're going to come around here, and we're going to go and do some testing.
Okay, guys, gather round. So we've just looked at all the different materials we've had, and we want to involve people who are watching on the stream as well. Okay, so we're going to give them a chance to predict. Now, you've already told us that the what is attracted to magnets is metal. Yeah, you've said that metal is attractive, but we've also said that it is not all metal. So what we've got to know, key knowledge here, is which of these have metal in them and what type of metal is going to be attracted. So we're going to work our way through. We're going to let the people that are watching make a prediction first in the chat,
and then we're all going to make a prediction. Okay.
I'm just going to check in the chat, sir, if we can hear you okay. If somebody could just say okay or something, and if not, I'm going to just move the microphone a little bit, if that's all right.
Yes. Just can you hear my voice? Testing, testing. 1, 2, 3.
I think we're okay, sir. So I'm going to just move this in slightly closer, and then we're also. So there might be a little bit of noise for a second. Noise. Brilliant. Thank you, sir.
Brilliant. So the first one that we're going to test, and how we're going to test it is we're just going to put this magnet here over the top of the item. And if it is magnetic, it should be attracted to the magnet. So we should see it move.
Are you making a prediction, sir?
So let's make a prediction. We're going to start with seashells, okay? Let's make a prediction on the chat. Chat, do you think a seashell is going to be magnetic?
Let me have a look.
Not.
Right. The chat is saying they think the seashell is not going to be magnetic. So.
Okay, guys, let's help out then. What do we think that the seashell is going to be? Oh, throwing my magnet. Do we think the seashell is going to be magnetic or not? Yes or no?
No.
And can you explain why you don't think it's going to be magnetic? Well, let's have a look. So I'm going to test the magnet. I'm going to pop it over the seashell. Oh, it's attracted to the other magnet. That must have been the North and the South Pole, or the South and the North Pole. But let me put it over the seashell. We can see that seashell is not moving at all. I'll try the other magnet just in case. We can see that seashell is not moving. So if you predicted that it would not be attracted to the magnet, the seashell was not. Because the seashell, as we say, is not metal. Okay, and we've said that metal is attracted to it. All right, back to the chat then. We've got wood next. We've got wood. We've got 3 pieces of wood here. Yes or no? Do we think that is going to be attracted to our magnet, please? Pop it into the wall.
Okay, let's have a look at the chat. The chat is saying, well, you got a beautiful haircut, sir.
Oh, yours or mine?
Yours, I think they're talking about.
Did they say Mr. Keeling?
Mr. K.
Mr. K's got, who said that?
Beautiful haircut. That was from Little Donkey 212.
And I've got a lovely haircut.
Yes.
That's not really relevant to science, but my gosh, does it flatter me.
Yep. Okay, let's have a look what else in the chat. It also says here, we think that, well, they said that they think wood, they don't see a lot of metal collecting around the bottom of trees. And they think that wood might be non-magnetic.
What do we think then? Year 3? Non-magnetic. All right, let's put our magnet over the top and we'll see what will happen. Again, I'm seeing absolutely no movement. I think you're spotting something that we shouldn't spot. And I hope we weren't watching just then because we might have given one away.
We didn't see it.
The wood is definitely not moving. All right, moving on to plastic beads. Chat, yes or no?
So we interesting. Something has arisen on the chat. We've now got an X with a magnet symbol. We've got an X and a magnet symbol.
Not magnetic.
That probably means not magnetic.
Not magnetic. Okay.
Okay.
That's okay. So we're going on the chat. We're going not magnetic. Guys, year 3 then. What do we think? Plastic beads.
No.
Let's test.
Is there an Issa here?
Yep.
Got a shout out to Issa from some parents. Very
We've got
good.
2 Issas here.
2 Issas, right? Shout outs to all the Issas in the house.
Yeah, if we've got Issas, let's raise our hands and go, hi, everybody.
Hi, everybody.
Lovely. Plastic beads. Oh, they are moving, look.
Wait, hold on. We're not on the screen, so we can't
Guys,
see it.
they are moving. Look at that.
They're moving.
They must be magnetic, right? Oh, is that the vibration that I'm making? Oh, sorry, I was all excited there.
Can I ask something, sir?
Yes.
From earlier on today, we spoke about the importance in science of doing a fair test, didn't we, sir? Do you think Mr. Keeling is doing a fair test?
No.
What do we need to say to Mr. Keeling? Silly Mr. Keeling. Mr. Keeling, we need to have a fair test for this to be scientific. Is that okay?
Oh, okay, test.
Oh, no. What should we say to Mr. Keeling? Should we say he can do it?
Yeah.
You can do it, sir. We believe in you, sir. You can do it. Come on, pick up that mat. Come on, let's go.
Right, guys, we're going to move on to washers. Now, these are shiny. These look metallic to me. So, in the chat, what do we think we're going to say? Yes or no?
Let's have a look in the chat. Can you point out the one?
Magnetic.
The chat is saying they absolutely. Oh, next stop Hollywood for Mr. Keeling.
Whoa.
Next stop Hollywood. They really believe.
If they get me the ticket, I will fly there.
Yeah, they really believed that acting was true. We've got this one has a lot of magnets. We've got at least 5 magnets showing up from just one piece of
Wow, so we think magnetic. Guys, year 3, what do we think? Magnetic or not?
Magnetic.
Let's have a look. Washers. Oh!
Sir, right, I'm really enjoying all of this, and I've just realised we need to do something else. Because
Right.
as fun as it would be to go through all of these
I
one
think
by
we
one,
need to go through all of
could
these
we
one
come
by
back
one.
to that? Could we come back to that? Because
Absolutely.
I'm looking at
After
my
we
time
get
schedule.
to the first row being finished.
We really actually need to move on.
Oh, right, okay. We'll pause that. We will come back and we'll find out what else is magnetic.
Right.
Sir, could you just, before we move on,
Yeah.
tell us what metal the washers are made from?
Iron. Is that right? I don't know. I'm
Yeah,
thinking iron.
maybe they are.
Right, guys, could you come this way?
Okay, year 3. Follow
Could you
back,
come,
sir,
come,
please.
come,
Go
come,
back,
come?
sir.
Sir, we're all welcome in the zone. I'll tell you the only reason I'm moving you on, guys, I've got limited time and I've got another group of people who are going to be turning up very soon. And you've not even shown us something amazing that you created from this morning. We can come back to that later, though.
Oh, yeah.
I can't wait to come
That'll
back to
fill an
that.
hour.
I can't wait for that. I really can't. Right, that went way better than I thought. So, what have we got down here? You have made it. Guys, can you pick your thing that you've made up, please, for us? Gonna go and grab them. Excellent. Now, what have you made, guys? Can you explain what it is that you've made for us?
Oh, wow.
Yes? Go on.
Footballers.
Can somebody tell me an event that's coming up very, very soon that everyone's pretty
What is it?
excited about?
What is it?
Euros.
Everyone say Euros! Can you say, come on, England! Come on, England! Come on! Come on, England! Come on,
Well, if we're going to
England!
do a proper sing-song, sir, we have to sing 3 lines on straight.
Oh,
Football. Football's coming home. It's coming home. It's coming home. It's coming. Football's coming home.
Beautiful. Wow.
Another round of applause.
Hey, come on, England. Brilliant. Right,
Now,
now,
what have you
back
made?
to
Tell us
science.
about. So you made footballers, but what is special about these
I'm going to
footballers?
show
that
you
you've
one of
made?
the footballers they've made. Look at this. They've got now. Why on? Oh, that one's not got paper clips at the bottom. Now, why on earth would you have put paper clips at the bottom of them? Yes.
So we can make them move.
So you can make them move.
So if you put a paper clip at the bottom of a piece of cardboard, it'll just start moving.
No.
Well,
I'm saying.
I have, and maybe we could just put the camera down on this because I don't know, unless the other camera would be better for this, sir. No, it won't be. I have got here a box. I'm going to hold it up like this. Would someone be able to put their footballer onto the box that you've made? Let's have a look. Has that one got? That one's not got anything at the bottom. This one has got stuff at the bottom. Right. So we've got a footballer here, and oh my goodness.
Whoa!
What's happening to?
You're using the magnet.
Whoa, sir! I think I know exactly what's happening.
Could you
there.
one of you hold on to this while I find a bit of a stronger
I'll
magnet?
grab you one of the magnets.
Oh, you're going to.
sir,
Sir's
that's
going to
fine.
get us a stronger magnet.
Yeah.
Right. So even the magnet has this amazing force, and we can actually use it even
We are,
through a solid surface. Now let's have a look. Is this? Oh, now, sir, that is what we're talking about.
Let's have a look.
Look at.
Whoa!
Is that magic?
I know what that is. I
Is
know
that
what that is.
magic?
I know what that is. You have a magic box, sir.
Look, sir, look, there's no wires. There's no nothing. This is not a magic box. Hello.
It's because you're using the magnet to move it.
Wow. So the magnetic force
Because
is
there's
strong
paper-
enough.
Because there's paper clips under it.
That's amazing, isn't it? They're strong enough to go through this material, which is absolutely incredible. Can we put another one on as well? What might be really nice, we could see if maybe, could you put that piece of bread on there as well? We can pretend the piece of bread is our football. Put that piece of bread there. And let's
Oh,
see.
there we go.
Oh.
Stepping up to
Kicking
the
it.
goal,
Blah,
taking a
blah,
shot.
blah. Let's get another footballer into who's got them at the bottom. If they're on the side, you've got them at the bottom. That's really good. Let's get a football on. Keep it going. Right, here he goes. He's moving. He's taking the ball.
Here we
The
go.
other
Coming in for
footballer
a
is
tackle.
coming in for a tackle. Oh! What's going to happen at the end of this? He's pushing the football forward. He's knocking it through, but Mbappe's got the ball. He's knocked him off the pitch, and he scores a goal.
And if that isn't great television, I don't know what is.
Oh my gosh! I am so entertained by that. That is absolutely incredible.
So
Right,
just
guys.
talking to people at home very quickly
Yeah.
then. All that the children have
You
done
take-
here,
you grab your ones that you've got.
they've used their knowledge that paper clips are magnetic, and they've just got a simple magnet.
And all they've had to do is they've created out of cardboard their own football characters, and they've put a paper clip at the bottom. Now, what you could do at home is if you want to make your own magnetic football table, give it a wave. Big wave. If you want to make your own magnetic football table, all you need is a thin piece of cardboard, and two thin pieces of cardboard, one for cutting out your football player, one for being the football surface. You just need to attach a paper clip to the bottom of your footballer, and then you use the magnet underneath to move them. Hey, if you've got another a big enough piece of cardboard, you could get two magnets and you could play a real game against each other. Wouldn't that be really, really something?
Yeah.
Yeah. So why not? I'm sure the children in year 3 are going to be doing that tonight. Yeah, making your own football game out of magnets and plays. Yeah.
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 I said yes.
Yeah.
Brilliant. Right, I'm going to step this back a bit. Now, what me and Sir do before you guys leave, because we do have year 5 coming. I hope year 5 are coming, just in case anyone's listening to that. So
Year 5 are on the way.
year
Yes.
5 are on the way. So we are going to get you to quiz us.
Wow.
Oh.
Now I must say my science knowledge and so far has been middling at best.
Yeah, we've not done
So
well.
if you've got a middling at best question to ask us about science, please put your hands up. We need to
Anything
make
about
up
science.
any time for year
Anything
5.
about
We'll
science.
go back to our magnet box while Sir goes and fetches them.
Hey, did you say anything
So
about
does
science?
anybody have a question about science?
Anything like you?
Anything you want. Doesn't need to be about magnets. Can be anything you want to know.
Go on then, ask us questions.
Go on.
What have we
Go
got?
ahead.
What type of force is a magnet?
What type?
Move out
Well,
the way so we can
actually,
see
with
you.
all force is based on 2 very, very basic principles, and that's a pushing or a pulling motion. So actually, when you look at the forces, and we will look at forces later, we'll have magnetism. We will also look at, I believe we're doing air resistance.
We're going to be doing air resistance next.
Yeah, we're going to do a bit of water resistance, and I'm going to do an experiment with that later.
Yeah.
But basically, all the forces that are happening in all of these experiments are a push or a pull. Yeah?
Or a contact?
Contact, yeah. So I mean,
It's got you.
yeah, I mean, it would push against
Yeah, it
if
would
you
push
do
against.
contact, but yes, absolutely. We're thinking about friction and kind of stopping forces there, aren't we?
Ooh, we do got a good experiment for that if we need to. I've just remembered. That's good.
Fabulous. Any
More
other questions?
What have we got? Now, I'll tell you what you could ask me about. Why on earth would Mr. Jordan bring in, or
Why on earth?
why
That
on
was nice.
whoa,
Whoa, wow,
why
good,
on
well,
earth
good
would
one. Why
Mr.
on
Jordan
earth?
bring in this planet, and what
Whoa.
has this got to do with?
Why has Sir brought in Jupiter?
Why?
Jupiter.
Yeah, why is Jupiter here, guys?
Saturn.
Oh, everyone's so silly, Mr. Keeling.
Keeling.
Right, tell me about it. Why have I brought Earth in? We're learning about magnets. Why have I brought Earth in? Yes. Oh my gosh,
Magnetic
Earth has
field.
a magnetic field. You're absolutely right. What can you tell me about the magnetic field of the Earth? Yeah.
It attracts objects.
Ooh, does it attract objects?
Well, like if something is coming here, it like pulls it
That's
towards it.
interesting. I wonder if it would have any sort of pull effect on a large object. I think actually one of the good things about the Earth's magnetic field is it's able to protect us from a lot of the harmful rays from the sun, but it also allows us to navigate. Do you know what I mean by navigate? It allows us to tell what direction is what. And how do we tell what direction is what from the magnetism of the Earth? Do you know? You know how?
Yeah, there's a compass on here.
Oh, should we show the screen now? It's a little bit of a compass. And what's that compass telling us? What does the
North,
compass tell us,
south,
guys?
west.
North, east, south, and west. Never eat shredded wheat. Well, you should eat shredded wheat. Can we say naughty
Good for your
elephant
heart.
squirt water? Naughty
Naughty
elephant
elephant
squirt
squirt
water.
water.
Say it again.
Naughty elephant squirt water.
It's never north, east, south, west. Naughty elephant squirt water. And that allows us to know which way is which, because you're right, at the top, well, there isn't really a top and bottom to Earth, is there, sir? But when we draw a map or we have a picture of a globe, we often have the top being the north and the bottom being the south. Of course, there is no top and bottom to Earth. Am I right?
Which is interesting, isn't it, sir? Because all those space movies, when you see spaceships flying through space, they're always the same way up. I wonder if they agreed on like a international up and down.
Maybe you could do a few more questions with the children, sir.
Okay, I think we can probably carry on the experiment for a little bit, can't
Yeah,
we?
that's
So
even
why
better
don't we
idea.
come back over, children? We're not, and we'll see what our predictions are for the rest of them. While Sir goes and finds year 5. So let's go back over here. Gather round, children, as we delve deeper into the most exciting experiment I think I've done today, which is magnetic or not. I think that we could start a game show. What do you think? Magnetic or not? Yeah? We get everyone on and ask if it's magnetic.
Yeah, we can put on ITV.
Oh, we could put it on ITV or BBC as well, yeah? Absolutely. So if you're listening, BBC or ITV, if you're out there, we've come up with a really good game show, and all these kids are up for it, aren't we? Yeah.
There can be 1,000 people.
Yeah, we could have 1,000 people in the audience, and we could win money for our charity. All right, let's keep going then. So we just saw that washers were magnetic because it is metal, but not all metals are magnetic. So just because they are metal doesn't mean that it is going to be magnetic. So what's the next one? Can you read that one for me? String. What are we predicting then? Yes or no? Is that magnetic?
No.
No. Let's have a look. Here we go. I think I agree. Non-magnetic string is not magnetic. It is not attracted by the magnet. Well, unless that string was made out of a certain type of metal. Okay, what about chalk? Now, chalk is naturally occurring, isn't it? Chalk is actually a type of rock, and we might learn a little bit about that later on the stream. But for now, chalk, what do you think? Because some rocks could be naturally occurring and magnetic. In fact, has anyone ever heard of the lodestone?
Oh, yeah.
Yeah. So you learned about the lodestone. Could you tell me anything about it?
You know, the ancient Chinese found out that lodestone needs magnets.
I did know that originally the lodestone was how we found, or that's what we believe is how we found magnetism, because people, when they were striking the lodestone with something that was metallic, parts of the metal and parts of the nails that were holding their tools together would become stuck or attracted to that lodestone. And we might learn a little bit more about lodestone later, but that's really good knowledge. That's really good, yeah. We were just saying that chalk is naturally occurring. It's a stone. Yeah. Lodestone is naturally occurring.
I'm going to put this on the big screen for a second.
Maybe chalk is magnetic. What do the stream think, sir? Do they think?
Let's have a look at what the stream thinks, because I love that argument. It's from the Earth. Lots of things in the Earth are magnetic. That makes sense. Can I just try and turn this in a way that means that the stream can see it? Can you point out to the chalk, sir?
Right here.
Brilliant. Right, let's have a look at what the stream are saying. The stream are definitely going for non-magnetic. They're saying genius ideas, year 3. Well done, my son, Issa H. Oh, year 3 teachers are doing a fantastic job. We're looking at football players. Wow. And 3T are definitely going for not magnetic.
Okay,
not
here we go,
magnetic.
Then. Get ready. We're going to count us down. Make it 6.
Are we ready?
3, 2.
Is it going to be magnetic?
1.
No. What a disaster.
Oh, disastrous.
We had such a high with those footballers, and this has got even better.
This is getting more exciting. You missed it, sir. You missed it, sir. You missed it, but we've come up with an idea of putting this on whoever comes here first, the BBC or the ITV. Whoever comes first, they can have exclusive rights to this game show.
Do we think that's a good idea?
Yes.
I love it. Right, brilliant. Okay, guys, I'm going to bring you back over here, please.
Okay, year 3.
If that's okay.
Follow, sir.
Come and get yourself back over here. Actually, I'm going to squeeze this back behind you. I'm moving stuff all the time. If you could just go into the front. I'm going to push back. I'm going to squeeze this. Sorry, I've made a right boo-boo here, haven't I? Right, there we go. Let's pop that back over here. Excellent. Right, are you all on at the front? I can't see all of you. You get yourself over here as well. And you get yourself in over here. Brilliant. Right, this has been our amazing year 3 team.
Should we do another total, sir?
Oh my goodness. Are you guys now? Last time I think we had about £200. Is that right? So what do you think might be around the? Are you going to take a guess? How much money do you think we've got?
For 1,000.
You're going for 400. You're going for 1,000.
1,100.
Wait, hold on a second. Did you say 1,108? That's a massive number. So we can't be doing better than 1,108, can we?
Well, I guess we're going to have a little look. So,
right, shall we do a little drum roll?
We are currently at 54% of our 100% target.
Wow.
So we are over halfway, and we have raised £1,625.
Brilliant. Right,
What do people need to do though? What do they need to keep doing? And not just donate, not £1, not £2, not £5, not £12, £100 million each.
Yay! Right, guys, can you make sure you're all on here? Can you all big wave and can you say bye-bye? Thank you so much, year 3. You've been amazing. Year 3, I'm going to ask you to go out that way. Is that okay? You're going to head off in that direction. That's brilliant. And I'm going to take over this screen for a little second whilst we just transition into our next lesson. Now, we have a new lesson going on now. I'm going to put a new screen on. There we go. We've got a new screen. I did. I'm getting really good at these transitions.
I thought that was brilliant.
We are transition masters. Yes,
That's what they call it.
they do call us
Masters
the
of Masters of the Universe. I don't know. something
It was
like
good. It had
Yeah.
something to it. Right. We now have
Transistors,
something very exciting. I've been very excited for this, building up to this for a very long time. This is one of our top, I'm going to say one of the top 10 year groups in our school. They are
There's
one
only
of
6-year groups. Oh, well, we're talking reception.
we're including
and
reception, nursery, and
That would be 8-year groups.
this year group definitely fits into the bracket of top 10 in
Right.
the entire school. And
This is actually the year group that I teach.
no way.
Yeah. So if they can really challenge me on the knowledge here.
Well, they're looking like they're ready now, so I'm going to go and bring them in.
Well, we didn't introduce the year group. What are they? Sir?
Oh, I think potentially they should introduce themselves.
Right, let's do that then. Okay, here they come. Get ready, everyone, for our next guests. Come on in. Hey. Hi.
You're going to come through here to the.
Come on in.
Come to the
Come
front.
on in,
Come to the
come on
front.
in, come
Coming
on
up to
in.
the front. Come
This
this way.
way, no,
This
no,
way.
this way,
This way.
come
This
on.
way.
Come on,
This
be
way.
on
You can hold
camera.
your stuff for a
Come on,
minute.
be on
On the
camera.
camera. Come
Come
over
on, be
here.
on camera.
This is it.
Why
Brilliant.
not? Yeah.
Wowzers. We've got a big group. What we're going to have to do is move this back a little bit because do you know what? This is a very
Oh,
active experiment. Okay. Lots of things going on in this
Have we
experiment.
got? If you've got stairs in this school,
We don't have stairs.
we don't have it upstairs, do we?
But we do stand on tables. That's absolutely
We
fine.
do. That's allowed, is it?
We've got that, but the table's way more fun, isn't it?
Okay.
We can use that to step up.
Guys,
to the
would
table.
you like to introduce everyone on the stream what year group you are? Just shout it out nice and loud. What year are you? Year
Right.
Year 5.
What we're going to go around and do, do you mind holding on to them just for a little bit longer? I'm going to ask you to introduce your names, but can you just say your first name and not your second, third, fourth, fifth surname, just the first one? Yes?
Yeah.
Happy to do that? Okay, good. Who have we got here? This is?
Ahmed,
Say it again.
Ahmed,
Ahmed. We've got
Iman,
Iman, brilliant.
Rana,
Brilliant.
Faisal,
Faiza,
Juwaria,
Jawaria,
Murtaza,
Matsan,
Masood,
Masood,
Aiden.
Aiden. Now,
Whoa.
one thing I would say, guys, it's very distracting to look at this, isn't it? But that's not where the camera is. This is where the camera is. So if you're ever speaking or talking about anything, you need to make sure you're directing at the camera and not that screen, because that screen's got nothing to do with it. But our eyes will naturally go to that screen. So just remember that, okay? Right. Would any of you, just before we start doing this experiment and talking about what's going on, be able to just explain what is it all about? Rana.
So, in year 5, we have been learning about forces.
Oh, 1 second, Rana. I really do apologize. I've got the microphone facing the wrong way. 2 seconds. I'm going to pop that back over here. Could I start again? So, Rana, what have you been learning about?
So, in year 5, we have been learning about forces and important people such as Isaac Newton.
Isaac Newton. Can you pause there a second? Who on earth is Isaac Newton? I tell you what, because you've got all these holding in your hands, it's a little bit uncomfortable for you. Is it worth you putting them down for a second? Don't not just there. If you just walk over there, there's loads of space to gently place them down. Because what we don't want to do is twist up the strings. Do you want to just go and put these things? And then you can talk to us for a minute first, and then we'll come back, get them, we'll do our experiment. Is that all right? I've just realised, and also I'm a bit worried about the rattling of the bags on the microphone. I'm a professional broadcaster, guys. A professional broadcaster. I understand about these things. Right, come back into where we were at. So Rana was just telling us, you come a little bit further, little bit.
It's this professionalism, isn't it, sir? That's why Newsround wanted you to
This
say
is
about
why
it.
Newsround is so desperate to have us. This is why the BBC are definitely coming and filming. I need to keep going over this way a little bit more. I'm really sorry. That way, step. Keep stepping in. That's it. Keep stepping in. So that we've got, right. Isaac Newton. Who can tell me something about Isaac Newton, please? And you've got a picture of him there as well, sir. Is that a photo?
That is a realistic photo
Realistic photo.
of Sir Isaac Newton.
Yes, sir. What can you tell me?
So, Isaac Newton discovered gravity.
Ooh.
Isaac Newton discovered gravity. So I know what that means. Before he discovered gravity, I presume we were all just floating around the place like balloons.
Yes, that's true, because Sir Isaac Newton didn't discover gravity.
No.
He invented gravity.
Is that right? He
That's
invented
correct, right?
gravity.
No.
Invented it?
No.
No, so we weren't all floating around before Isaac Newton?
No.
No, so what really happened, Masood?
So he said when what is explained to be an apple fell on his head,
Yeah, keep going.
he wondered why didn't the apple go sideways even up. This led him to discover that there must have been a force pulling every object down to earth. He called this gravity.
Whoa.
Wow.
What an amazing answer.
That is amazing.
Does anyone want to add anything more to that? Although I think that was a pretty complete...
That was very,
Answer.
very good.
Yeah, anything more? No? That's brilliant. So it wasn't that he invented it because it had always been there. It was just that, as you said, that when the apple fell on his head, apparently, then he realized there must have been a force there. So he was a bit of a thinker then, wasn't he? Yeah, a lot of a bit like all of you. You guys are big thinkers as well, aren't you?
Yeah.
Right. What else can you tell me? So we've got Isaac Newton. We've got the force of gravity. What else can you tell us? Brandon, I've heard you a little bit. I want to just try and get a few more people to talk. What can you tell me, Aiden?
I was love for Isaac Newton.
You love
in.
Isaac Newton. You just love the guy.
Yeah.
Can't get enough of him, right?
That's good.
Brilliant. Yes.
Isaac Newton. Isaac Newton invented a telescope.
Woo!
Whoa.
That's pretty amazing. Now, what's a telescope? Yes.
Something that you have in your room, and then whenever it goes dark, and you go like this to the telescope, and then you can see like stars.
Brilliant. So it allows us to see things far, far, far away that we wouldn't able to otherwise be able to see. Now, that must have enabled us as humans to start to discover a whole load of new things. When we've got the telescope, what new things were we able to see that we weren't able to see properly beforehand? Yes.
Other planets.
Other planets? Do you know any other planets? Yes.
Like Jupiter.
Jupiter? Go on, let's go through a load of these. Jupiter, Pluto. Let's go back to Pluto.
Well,
Let's
Pluto.
pin
We'll talk about
Pin
Pluto a little later. We'll talk
Jupiter,
about Pluto
Pluto.
later.
Saturn.
Saturn,
Mars.
Mars,
Earth.
Earth,
Uranus.
Uranus,
Neptune.
Neptune. I don't know what number we're at now. Has anyone said Mercury?
No. Venus.
Venus? Brilliant. Why did
Sun.
we... The sun is not a planet because it's a big ball of burning gas. The moon, is the moon a planet?
No.
Ah, so there must be a difference between a moon and a planet. Do you know the difference between a moon and a planet? Yeah.
A planet is like a type of place like Earth,
Mm-hmm.
but
It's okay. You're onto a roll. I love it. Do you know what? The best thing is when you try and answer a question and you have a go. I can't stand if you just sit there and think, ugh, no good. Try it. If you're wrong, who cares? That's what science is all about, isn't it, sir? It's about making mistakes. Yes, Joanne.
Pluto isn't a planet because it's classed as it's not big enough to be one.
Ah, interesting. That's why we picked
It's not actually that we will learn about that later, and it's not that it's not big enough. In fact, actually, Pluto meets most of the criteria for being a planet, and that's why it has been a planet for such a long time.
So what is it, sir? Or
It's
do they have to tune
actually-
in later for that?
It's actually something to do with the orbit and something to do with clearing it, but we'll go into that a little bit later on because we are going to have a whole unit for a few hours later tonight on science, and that's the one that I'm looking forward
Oh
to.
my
the
gosh,
most.
I can't wait.
So
That
we
might be
will
one
talk
for-
about
if it's
Pluto.
good. That's
But
Saturday
you're
morning.
absolutely right. It can't be classified as a planet, but it's not to do with size.
So could I just go back to that planet and moon thing? Is there anything more? What might be the difference between a planet and a moon? Anybody to think about it? Or should we do a live demonstration? Should we do a live demonstration? I think we need to do a live demonstration. Okay, look, let's use this space over here. Okay, I'm going to have a few people here. Joaria, you're the perfect sun. Thank you very much. Sun,
Oh,
what does the sun
wonderful.
do? Bam, there she is. She is the sun. Can we just check that it's definitely, we can see what's going on here?
Absolutely. I think we can see.
Yeah, we can
Yes.
see the sun.
just about. I think
I'm
we
gonna,
might just need
can
to
you spin it more so Joaria is
bit
right
more.
central? That would be great. That takes a little
Let's have
minute
a
so
look.
to
Yeah,
come in.
it'll catch
Now,
up. You start getting others in.
I'm going
so.
to move some of you. Some of you move just down there, and I'll bring some of you in at certain different times. Now, here is our sun. I'm going to move, by the way, this later on. You're going to be guessing the name of this fantastic puppy, and there will be a prize for that, which is great.
From one of our sponsors, I believe, as well. So
From
wasn't
one of
that?
our sponsors, yeah, Genie Cleaning. So we've got a planet here. Now let's think. There's the sun, and let's have a think about what this planet is doing. So could you walk all the way around your area? Can you keep walking around your area for me, please? Okay. Now that is a planet. Okay, you're gonna have to keep going for a bit. What is the planet doing? How could we describe what the planet is doing? It is, yes,
It's going around the sun.
going around the sun.
Now there is one word, isn't there, sir? It is going around the sun, but there is one word for
Keep going.
that motion of travelling round and round.
So there's hands up all over the place.
Another spherical body being caught within its gravitational pull, but not pulled into the sun.
What is that called? Yes.
It's I think it's called like I think it's called like orbit.
Oh, well done. Let's give a round of applause for that answer. Absolutely.
Right. So we understand that the planet is orbiting the sun. We're pretty happy with that. Now, I'm going to ask Planet, can you pause here for me, please? Planet gets into its orbit, and here it is. Sun is still going strong. Very good. This is one of the best suns I've had all
Yeah,
my
I've never seen a better sun.
Now, this young lad is not a planet, though. He is a moon. Okay? And what does a moon do? Use that word orbit for me. In fact, I'll let you carry on, Moon, doing a thing. Use that word orbit in a sentence. I'll move the camera onto you. Yes, what does the moon do?
A moon orbits a planet.
So this is going to be very complicated, guys. Do you think these guys are going to be able to do this? It's going to be hard. I believe in them. This is what you're going to do. You are going to carry on orbiting the planet. You are going to carry on orbiting the sun. Do you think we can do this?
Take it slow.
Take it slowly. Off you go.
Slower.
Slower. You're gonna have to go real slow. You're gonna go
Slower.
real slow. You're gonna have to go a bit faster.
Oh,
Oh, look at
wow.
this! This is fantastic. So we can see there are different types of orbits going on. We've got the sun at the very middle, of it, a large ball, a huge amount of gravity, a large amount of mass that is causing these orbits to happen around it. We've got a planet that is orbiting around that massive ball of mass, and the sun is just enormously bigger than any of the planets. So it is creating a huge field of gravity around it. And you can see that moon is steadily going around the Earth. Do we need them to carry on for a little bit longer? Or can we
I
stop
think
them?
at least 5 minutes more.
Do we think 5 more minutes of this, guys?
Yeah.
No, we're good. Let's give them a round of applause then.
That was really good. Well done. So I love that answer. You have told us you did great there, by the way. The hardest job keeping your hands up. So we had that difference, haven't we, between a planet that is orbiting the sun, and then we've got a moon that is orbiting around the planet.
So we've talked a little bit
Thank you.
about gravity then, and the gravity is that force that all objects have. So it's not just the planet, it's not just large bodies within the universe. Everything has gravity. You have gravity, yeah? A pin has gravity, but generally, the larger the object, the more mass, the greater the gravitational pull, which is why.
I was just going to say, do you know, sir, you know how you're talking about how big something is and how big something is? If the sun was like a big ball like this, sir, do you know how small the Earth would be? No, we're talking like this.
And actually, later on, we're going to watch a little video together about the sizes of objects in the universe. And I can assure you, sir, it's fascinating.
Oh, I can't wait for that. You better tune in later for
That
that.
will be later tonight. That will be really
I
fascinating.
interrupted you mid-flow. Keep going, sir.
No, that's fine. So gravity is pulling us, it's anchoring us down to the ground because objects emit this gravity, which is pulling force. And the larger the mass, the greater the gravity. However, there are forces that work against gravity.
Mhm.
And I think one of them is what we are going to be testing today. I've written this word. I wonder if any of our children can tell us a little bit about a force that works against gravity.
Can I just ask you, would you come in a little bit up here because you're a little bit out
Would you like to choose someone, sir?
Yes, sure. I would like you to tell me a little bit about it, please.
Air resistance.
Air
Air resistance. I like that, but I don't know what that is. So, could somebody help me? What is air resistance?
Yes, we're gonna
then?
say more. Can you expand it out?
So
some
maybe if I draw a picture. So there's someone. Let's call him
Josh.
Josh, it's already been decided, sir.
Okay. Let's call him Josh. Now Josh has really nice hair.
Oh my gosh, that's lovely hair.
Look, he's
Mohawk.
got cool.
Wow.
This is Josh, and Josh has really cool hair. Now, Josh, unfortunately, has been caught in the force of gravity,
Uh-oh.
which is bad for Josh because Josh is incredibly high up. So Josh is currently falling
Very high up.
because the Earth's gravitational pull is pulling. Sorry, let's just make it clear.
Oh,
Josh,
that's Josh.
That's Josh.
Right.
Down towards the Earth.
Mm-hmm.
What could we do to help Josh in this situation, please? Yes.
You don't have to do anything because when he's falling,
Mm.
the air resistance will like come up and eventually like equalize.
Ah.
gravity.
So
So
what
Josh
you're
is going to be
saying-
fine.
So what you're saying is there is a force working on Josh, and you're absolutely right. One force is gravity. But as he's falling, air is hitting every part of Josh and slowing him down, which means that he won't keep increasing in speed. He will reach a terminal velocity.
Oh, can we say that word, sir?
Terminal velocity. Let's try it.
Terminal velocity. Again.
Terminal velocity.
He
love
will
that.
reach a terminal velocity where he'll speed up no further because the balance of air resistance and gravity is met and he can only travel at that speed. However, Josh is falling from the sky. He is still falling too fast to be safe. So, what can we do to help Josh?
Go on, man.
Using knowledge of air resistance.
She's going to start you off here.
Go ahead.
Josh needs a parachute
Why?
because if the air won't go on him, if the parachute is big, more air will go. The air resistance will go on.
So, does anybody know what we are widening when we add a parachute? What are we widening?
The amount of air resistance.
We are getting more air resistance, but why are we getting more air resistance? So let me, for example, draw a parachute for Josh.
I'm going to give him a little parachute about as big as his head. That's collecting air. He's going to be fine, right? He's got a tiny little parachute above his head. He's going to be fine.
We're getting a bit of comments
No.
that we can't quite see the board, sir, so I'm just going to move that in.
That's fine. Why not? What does that parachute not have?
It doesn't have a big enough surface area.
Those are
Oh,
the words
yes.
that I were looking for.
Oh, yes.
It does not have a great enough surface area. The larger the surface area, so let's make that parachute bigger. Look at that. Whoa, Josh is getting safer by the second. Whoa. Oh, let's hope gravity doesn't pierce it. But now look, because of the increased surface area, more air can hit that parachute. And if more air can hit that parachute, it can work more against that force of gravity. And it's very similar with water resistance that we're going to learn about later. But the wider the surface area, the greater the air resistance, the slower that Josh falls. And Josh can change his expression because we can see he's absolutely terrified. Look, everyone pull a terrified face at the camera. No, Josh's terrified face. Like that.
That is pretty terrifying.
See, utterly terrified. And we can turn Josh's terrified face into one of absolute happiness.
Oh, and that's what science is all about.
That
isn't
is
it?
what
It's
science
about
is. Making Josh happy.
making Josh happy. Now, sir, I think it's about time that we tested out your theory. Because do you know what? In science, we have these theories, we have these ideas, we have these suggestions. And we say, yeah, I'm pretty sure that's right. But is that it? Is that it?
No.
What do you have to do then?
Just have to test it.
We're going to have to test it. Test it, test it, test
And what
it.
does testing it actually do then? What are we finding? What are we finding?
If it's true or not.
Yeah, we're proving, aren't we? We are finding actual evidence. We don't just stop. If we stop, it's a guess or it's a belief, yeah? And whilst beliefs could be strong, we, with science, want to try and prove it as scientists.
Right, sir. I'm going to ask you guys. And do you know what? Just whilst I'm here, I can smell the lovely sweet smell of...
Oh, wonderful.
of
Is that
the-
what was wafting over?
I think it was.
I noticed that.
Yeah, one of our
if
sponsors.
anybody wants to purchase these, where would they go to?
Class
get these?
O2.
Class O2.
Right, let's bring ourselves over here. Can you guys start walking over in that direction? Would you go and pick up your items that you have brought with you?
Wow, what are these?
Oh. Yeah, yes, this is wow. We've got stuff. I'm gonna hand that to you. And we've got even more stuff. We've got timers. This is great. Wowzers.
Whoa.
Yeah, fine.
We've got learning objectives.
We've got learning objectives.
Somebody's trying to structure us.
Learning objectives.
There we go. Look at
Wow.
this. Learning objectives. Now, actually, at Causeway Green, we use learning intentions, not learning objectives.
That
They're
sounds
very very similar, but instead of LO, we say LI. So, learning
Can you get to-
objective.
I mean,
Of
yeah,
course,
thank
learning
you.
objective. What we are trying to find out is whether or not we can explain what air resistance is, and I think we did that a little bit with Josh, and can plan an investigation about air resistance. There's going to be an independent variable, there's going to be a dependent variable, and then we are going to collect results. Children,
They're gonna have to talk that through, aren't they?
you're going to have to talk that through because I don't know what we mean by an independent variable. So, could you explain to Sir and to I what an independent variable is? Can anyone tell us what the independent variable is?
Yes.
An independent variable.
Actually, Monsieur, sorry, can you come a little bit closer just because you get the microphone? There we go.
An independent variable is something that you change to make sure that you aren't repeating the same thing.
Ah, that's very good. So I don't want to be doing the same thing over and over again. That might confuse and muddy some of our results. Presumably, I need to have something that is, I need to have a constant in this as well. Do I have anything that is there anything else that is like not being changed to make this a fair test?
Well,
Yep.
no.
No, okay.
Everything else is
yeah.
meant to be kept the same.
Right, I got it. So you've got one thing that you're changing and, everything or just one little thing?
One little thing.
Right, one little thing we're changing and everything else is going to be kept the same. I love it. So could someone else tell me what is the things that we're keeping the same? What are the things that we're changing? And I'm going to refocus now. I'm actually listening to you. Yes, Run.
So, the things that we're going to keep different is like the sizes.
Keep different. You're going to change. So things you're going to change, yeah, are the size of the person, the parachute. Okay.
Wonderful. So can I just ask? Sorry to jump in there, sir.
please.
Can I ask then, if we change the size of the parachute, thinking back to Josh over here, what are we actually changing? What is the thing that we're measuring? Yeah, so we're changing the size of the parachute, but in relation to air resistance, and somebody gave me a great exact answer earlier, what are we actually increasing? What is the key scientific language we're increasing? We are increasing the surface area. And if we take my theory from earlier, which was the greater the surface area, the more air resistance, the slower he fall.
Now, can I show something on the screen? So
Absolutely.
one of the things that we said we were going to keep constant to make a fair test was the weight of the thing. And I don't know if you guys know, but I love Pneumacon.
Oh, Pneumacon.
Pneumacon is so great. Now, this Pneumacon, not only does it show, is it 6? 10. Oh, thanks, guys. Not only does it show 10, but that means that all these Pneumacon are going to be the exact same weight. Really good if you're ever using Pneumacon at home, and I would really advise using it. Really good for balancing out additions, subtractions, and different equations, because you can actually use a weighing scale, and you can see that the amount on one side is the same as the amount on the other side. So these are really fantastic. So we've got this that's staying the same. Guys, have you used lots of different types of string? No. So again, we've got another thing that is not being changed. If we change the string, that might completely change the experiment. If you change what is going on in it. Guys, the length of the string is different? Right? So not only is the material that the string is made out of the same, but the length of the string that you're using might be different. Just before we go into the experiment, why would me using different lengths of string or materials make this an unfair test? Who can answer that one? Would you like to have a little go and come a little bit further forward? Why do you think that would suddenly make it an unfair test?
Because then it wouldn't weigh.
So it would be a slightly different weight. And we're testing different things. I can't drop an apple with a parachute one time and then drop a hammer with a parachute a different time. Because of the force of gravity, I presume things are going to fall at a slightly different rate. Okay. What the best thing that we do here is that we're going to start testing these out. Is that okay?
Yeah.
Right. So we've got on here, and this is what we're going to do. I'm going to get some of you. You're going to come and stand up on here. You're then going to drop these down, and we're going to look to see which one works the best. We've got here, guys, just so you can do this along with us at home. And all you need to do something like this, they have just used some simple plastic material, which you can get from a bin bag. You can get that from a shopping bag at home. I bet your dad's in their cleaning up drawer will have some plastic material a little bit like this. And they've just used some basic string. Again, I'm going to put it nearby, and you can see they've just tied that string on. They've cut all of the string to the same length to make sure that it's a fair test. And they've also used the same amount of sticking tape up at the top. If they started using something like blue tack, the blue tack would add such an additional amount of weight that it would suddenly become unfair. So they've got the same amount of sticking tape, they've got the same different materials at the top, and they've got the same weight down at the bottom. Obviously, you may not have a Pneumacon at home, although I do advise that you get some. So you could find any object around the house that has just a little bit of weight. I think a good one always is a spoon. Spoon's always pretty good.
Action figures.
Action figures, if you've got action figures or dolls or anything like that, they work absolutely fantastically. Who's going to be in charge of the timing?
Ooh. Can I just say as well,
Yes, please.
one thing that you can also vary if you want to try is the actual height that you're dropping the parachute from. Now, we've got steps up here, so we're going to try and drop it right from the seat in here today to the floor. That's the highest that we can do it. You can do it higher. We've done it with year 5 before, dropping it from the stairs. But if you are going to be dropping things at height, make sure that you are doing it with adult supervision. And it's probably best if the adult does it with you or for you, and you observe the fall. Okay, who is going to be dropping the parachute first? Is this the smallest surface area?
Yeah, that would be a good idea. Who's got the smallest one?
Who's got the smallest parachute?
You do. So can you?
Let's go with the smallest
So you're going
first.
to start.
Okay, you're going to start that when it's dropped, and you're going to stop it when it's on the floor, aren't you? Okay.
Brilliant. So you can go to the back now. Right. So you just get, and Masood, you've even actually measured it. That is how many centimeters? 10 centimeters. You're going to be okay. Can you, everyone get them off the table? That would be really kind, just so that we're not slipping on anything.
Now, what we're going to need to do, sir, to keep the variable of the height the same,
Mhm.
is we're going to have to try and get them to drop it from exactly the same point.
Okay, I love that. Is it best, so you know that, is it best to hold the parachute or best to hold the thing?
I think it's best to open the parachute out.
Give it as much opportunity as possible.
Give it as much
Would you come a little bit
opportunity.
closer to the front? I'm going to keep going until you stop there. That's it. Perfect. Right.
And then when we say
3, 2, 1.
Don't you?
When we say drop, you drop, and when we say drop, you start, and stop it when it hits that floor. I don't think this will take very long. Okay, so get ready.
I'm just going to make it fair, so make sure it's tied up in just the same way. If you give me 2 seconds, I can do that. There we go. Right, fair tests. Joaria, are you ready? Could Joaria do the 3, 2, 1 so she knows when to stop?
Yes.
3, 2, 1, go.
Okay, Joaria, could you show the what is? It was barely even a second.
It was just below a
It
second.
was just below a second. I'm
Just
sorry, I accidentally
below
pressed
a second. It was
Less than a second.
0.927.
clear.
So it's
Can we write that down?
0.927. That was the first drop, right?
Point
First drop
Right, you
was
can come down.
0.927.
That's it. Brilliant. Right, who's
But
up
we're
next?
going to, because we're going to do 3 drops, sir, to measure the time. So
Yeah, you have
to make it fair and to make sure we got the right result, can we drop the same parachute 2 more times and just measure
course.
that we've got the same
Oh, we're just
amount?
going to do 3 then. That's
We're just going to do 3 parachutes. I think.
3 recorded, but everyone can have a go.
Yeah, everyone can have a go, but we'll do 3 recorded, which is what you said exactly, and I've just repeated.
No,
yours.
I think it's best to repeat things.
It
to
is.
Understand,
Yeah,
consolidate.
absolutely.
you know,
Consolidate.
very important.
Very important.
Thank you.
Okay,
Right,
same
same
height.
amount.
So you had your arms higher, higher. Okay, get ready. Joaria, you're going to ask him to drop it again, and we're going to measure the time. All right?
3, 2, 1, drop.
Okay, 0.859 that time. We're going to do it one more time and average it.
Can I check one thing as well? Are you starting it on drop or starting it on 1?
Drop.
Right, so wait until she says drop to drop. Okay?
Okay.
So 3, 2, 1,
Here
drop.
we go
hit
one
drop,
more
that's when we
time.
stop.
We ready?
Oh gosh, this is exciting.
It is exciting.
3, 2, 1, drop.
I would say that again is 1.149. I think we've got 0.8, 0.9, 1.1.
Brilliant.
I think we average out at 0.95, I would say. Just below a second.
Could we not have 20 now? What's the largest size? 60. So have we got a 30 or a 40?
Let's do 40,
Right,
I think.
come on up. We'll do all of them, don't worry. But we're going to just do a sort of smallest, a middle, and a big on our sheet.
Yeah.
And then we'll have a go with all the rest.
Okay.
Yeah,
Right,
clear it?
So this is such good organisation from whoever. They've labelled exactly what the size of each of these are.
Yeah, massive, well done. Preparation. Okay, do you want to carefully come to the end here?
Right.
There we are.
Almost as good as my footballers from earlier. Not quite.
Not quite.
Right, here we go.
High as we
Right,
can.
going a bit further
And
forward.
then
There we go. You stop there.
careful.
Love it. So we're going to go on the drop. So when you
Where
hit
we
drop,
go
that's where
again.
we're going to go.
3, 2, 1, drop.
Okay. Now on that one,
Great second, sir.
we got a 1.3.
It was
So-
amazing because I saw that didn't just drop straight
Yeah.
down. And gravity would pull something directly downwards, which must mean there was another force acting on it that actually took it in a slightly different direction. I'd be curious to know what that is.
Water resistance.
Is it what? Do we think it's water resistance?
No.
Oh, wow.
Oh.
Air resistance.
Oh, yes, of course, because we're not in water, we're in air.
You sure?
Yeah.
Are we ready?
Mhm. Oh.
Okay.
3, 2, 1, drop.
Okay, that one was slightly faster, I think, because the parachute wasn't opened out when it
But
was
that's what
dropped.
it's all about.
But that's what it's all about. That was 1.2, still more than the smaller parachute. So still, at the moment, proving our thesis. We're going to go one more time, try and open it right out this time, and we'll see how we do.
3, 2, 1, drop.
Nice. Okay, and that one, 1.4. So we are going to average that out at 1.3. Well done. So we've got 0.95, 1.3.
Could we have the largest one, please? Just for our experiment. All of you can have a go in a minute, don't worry. Right now, Aidan, could you tell me how big is this? Okay.
I believe we have visitors outside, so that may be here a little bit early. Right. Just come and step to the end for me. Just not too close, just there. All right. Then open it out, hold it up as high as you can hold it up. And don't drop it until we say drop.
Oh.
Okay. Higher. Okay. And then give him the 3, 2, 1 drop. Yeah.
3, 2, 1, drop.
Okay, so I would try and drop that from a little bit higher, but that was still 1.5.
What we'll do is we can both maybe hold a little bit of it, and you could hold. You get one. Yeah, if you hold this corner maybe like that, and I'll hold that, and we're going to get really close to the edge if you don't mind. Gosh, it is a wobbly table that I put you all on. Right, you do your 3, 2, 1 again.
3, 2, 1, drop.
Oh,
Oh,
hit the table.
okay. Let's try again.
3, 2, 1, drop.
Okay, 1.6. And we'll go for one final drop.
One final drop.
3, 2, 1, drop.
And that 1.1, which skews the data slightly.
Should I try just dropping it a little
Yeah,
bit?
maybe just try from the very top.
You're going to come down. I'm just giving you a hand in case you want it. Right, if we just try one and get it right up the top, because I don't want to skew the data. If the data is skewed, the data is skewed. That doesn't really matter. Try one more time with this. That's okay, sir. You ready?
3, 2, 1, drop.
Okay, that is
2.4.
2.4. So average that out.
1.8.
About 1.9. So that
Can I
means.
show the data to the screen, please?
Sure.
So this is what we've got. So can you explain what's going on here, please?
So what's happened here? We can clearly see
Oh,
the
we need to
one.
put in the sizes, don't we?
Yeah, the one with the. Yeah, we need to put it in the sizes. So how big was the first one? 10 centimeters squared, was it?
First one was 10, sir.
10 centimeters squared.
Second one was 40.
40 centimeters squared.
And the last one, I'm going to say
60.
60 centimeters squared. Okay, so what we're seeing from the data then is that as the size or the surface area rather increases, so does the amount of time it takes to fall. And as we were saying before, if we look back at Josh over here, what we were saying was the greater the surface area of the parachute, the more air that pushes up against the gravitational pull that is pulling Josh down. Therefore, the greater the surface area, the greater the air resistance, and the slower that parachute will fall. Let's watch our last few falling parachutes.
Falling parachutes. We've got a little bit of time for this, sir, so we don't have to. Excellent. Right, let's go.
3, 2, 1, drop.
Wow. Do you know what I like? I don't think it's a problem. Sometimes it hits this, but that's interesting because what can we learn from that? Come on, you're scientists. If something keeps going wrong a little bit, what can we learn from it? Come forward if you're going to answer it, just so we can get it into the microphone. What can you learn from that? Yeah.
We can learn that. We can learn from what we can learn. So if we're saying the table, we know we can learn that we need to put it further out so that the same mistake doesn't happen twice.
I love that. Did you hear that? So he saw that something went wrong, that it kept hitting into the table. He identified that there was a problem. So he came up with a suggestion as to how we could solve that problem. And the suggestion for solving that problem was let's put it out a little bit further. Now, just because of safety reasons, that might not be possible here. I was trying to think, is there another way? Because I think yours is the best answer. We could have put it out further. Could anyone come up with another solution to stop it from hitting a surface right below us? Yeah?
You should
Get it over the way.
That's true. I was imagine if we had the table much higher up, and then he could sort of lay on the table and just drop it off the bottom so there wasn't anything in the way.
And this is all part of science, and
Yeah.
this is what is wonderful, because actually what you should do after you've done every test is to evaluate it. And you should always be thinking, how can I make this test fairer? How can I make these results more sound? Yeah?
Yep.
And that's what we're doing together.
Perfect. Right, 2 from each person from now on. That's great. Last one.
Here we go. Nice.
3, 2, 1, drop.
Wow, look at that. Julia, what's the time?
1.6.
1.6.
Brilliant, right, you
Nice,
come down,
well
we're gonna
done.
make first note.
You
Who
low.
has not?
Who's not
yet?
giving it a go? Bring it up.
Do you know how big yours is? I'm going to take this because yours has been perfectly labelled. Look at that, 50
Wow.
centimetres. Now we know what that is.
Wow, wow, wow.
Here we go. Right. This is amazing. Right. Let's hold it up. Hold it to the sky. This is quick. Ready when you're ready.
3, 2, 1, drop.
Oh, that was much faster. Do you see that, sir?
Yeah, I was
1.4.
surprised. I
Oh, but
suddenly
it still says 1.4. I thought that was much faster.
I think part of the problem being a scientist might be that a hand kind of held onto it a little second after you said
Right.
stop. Would you just make sure you pinch it just at the very edges so that your hand doesn't get stuck in? Maybe you could, if you get one pinch on this side and maybe one pinch on this side. There. Right. Whenever you're ready.
3, 2, 1, drop.
Very
Okay,
fast.
certainly went quicker, didn't it? Right, come down. Brilliant.
0.94, which was very similar to the first ones that we measured,
Who's
wasn't
coming
it?
up next?
Mary?
You been up? Let's go. Do you know how long this one is? That's okay. Doesn't matter. Let's see. Do we think that this is? I think this is a larger surface area than the last one. Now, this is an interesting shape, sir, because this they've actually changed one of the variables a little bit in this one.
Yeah, they have.
Because
It's
most
3.
of them have been using well, there's two things. One, most of them have been using square parachutes, and a square is quite a good shape because of the fact that it has all equal sides. But this one is actually using a rectangle shape.
Wow.
And year 4, I think at the moment, who are learning all about quadrilaterals, will be able to tell me something about rectangles. But seeing as we've got year 5, what can you tell me about rectangles? Year 5, come on, you can tell me something. So will you pick somebody for me?
You.
So rectangles are a quadrilateral,
Mm-hmm.
and they all have 4 sides, and only the sides are all not equal. 2 of them have the same.
Did you know? And I'll tell you this. In terms of
Getting down on
maths,
one knee for this.
getting
So
down
we
on
all
one
get
knee,
down on
'cause
one
this
knee.
is a
It's
fact.
quite-
This is a
quite
fact.
important,
And
right?
this is a mathematical
Wow,
fact. So I
gosh.
apologise on our science stream, but this is important. Did you know that the rectangle is a description and not a shape name? There is no shape that is called a rectangle. That's because a square is also a rectangle. Having 4 right angles makes it a rectangle. So that shape that people always call a rectangle with 2 sides longer than the other 2, its real name is an oblong.
What a lovely word as well. Can everyone say oblong?
Oblong.
I love
So
that.
now, whenever an adult, your teacher says, look at this rectangle, what I want you to do is put your hand up and say, sir or miss, that's an oblong.
Sorry, I should still get my knee for this. Right, ready?
Yeah.
Right, let's get up our knees.
Oh.
My goodness, I love these learning moments. That was crazy. And I think that's science anyway, isn't it?
Yeah, probably.
Yeah, we're learning science. Right, we've got a different shape. Just want to remind, can I just let go for 1 second? We've got is it a rectangle? What is it?
Oblong.
We've got an
Oblong.
oblong
I was
shape.
going to say yes. I mean, it is.
It's a
Descriptive,
rectangle.
it is a rectangle.
But officially, oblong.
Its name, oblong.
Oblong. Right, are you ready?
3, 2, 1, drop.
I really think that shape helped. I don't know about you.
It
1.5.
reminds me of a certain shape.
1.5.
Like a paraglider, isn't it?
No, oblong.
Yeah. All right, you ready?
3, 2, 1, drop.
I did a little twirl that time.
That was really good.
That
Do you want to
was
come
nice.
down? You up your hand?
One.
You're going to be all right. You're going to be all right. Who's
Good,
coming up
right.
next? Brilliant.
Hey, there we go. 1.4.
Yeah,
Okay,
shape.
good, nice. Interesting how that shape affected it. I did like the twirl. It was
I
very
thought it
good.
was fascinating.
Careful getting up, it wobbles.
It is very wobbly. It's the wrong table, really. That
Careful,
shows you. Yeah. And you're going to stop just when you hit my feet. Come a bit further forward. When I say feet, I mean hand, obviously. But what are hands other than just, special feet? Right. Hold them really high up.
I mean, they both have phalanges.
They absolutely. Right. Here we go. Are you ready for this?
3, 2, 1, drop.
Whoa, that was swift.
Straight down.
Swift.
Straight down.
To the
would
point.
not- one more, just in case, because you can never be sure
Yeah.
from one.
Oh,
Never be sure from one.
1.3. Seemed a lot longer, a lot quicker than the
Quicker than
last one,
1.3,
even though
yeah.
the other one was 1.4.
Surprised by the result.
3, 2, 1, drop.
That actually caught some air there. Yeah.
Right, come on down.
1.2.
Who we got left? Or has everyone done it?
Is that everyone?
Yeah.
Whoa, round of applause then for our year 5 guests. And should we all gather back over here and see if you can explain to me what has happened with our experiment? Let's come back round.
Okay.
Yeah, you can bring your parachutes along now. In fact,
Actually,
let's leave them
just 'cause of
the sound. Yeah,
Yeah.
but we can get them in a minute. So gather round, go round, move around a little bit so everyone else can get back in. How are we looking, sir? Where should they start?
We're gonna have to
Keep
give me a
going,
minute
keep
to.
going, keep going, keep going.
I'm gonna move this back.
Do you want to come on in? Come on in,
Uh,
come on in.
uh,
How are we looking?
We're all in.
Fabulous. Right. Could anybody succinctly and clearly then tell me what we've just proven. What have we just proven? Now, I say proven, there were certain variables that weren't always the same. So that wasn't completely a fair test because we raised our hands at different levels, we dropped them at different speeds, and we probably started the timer at different times. So it's not a perfect test, but we tried the best that we could to prove something. Can anyone tell me what we proved, please? Go ahead.
We have proven that the bigger the surface area of the parachute, the longer it takes to fall to the ground.
And why is that? So that's a really great starting statement. The greater the surface area of the parachute, the longer it takes to fall. Why? Can anyone add on? Go on.
To add to what Masood said, if the surface area is bigger, that will cause it to go slower because when something is going down, like say if you have a big parachute, then the air would push against it to make it go slower. But since bigger, it would cause it to go slower.
Yeah, because there's more of that air resistance.
I love the way you use
Wonderful.
that sentence as well, saying to add on from the suit. That was really
No,
good.
I loved it as well. That's very, very well communicated. Very, very well. Is there anything that anybody else wants to add about that test? Anything that you might change about it next time? Anything you think we could do better?
Rana, tell me, what can we do better?
Next time, when we do a test, to make it better, you have to make like all the sides equal the same. I know what's the length of each side. Because some of the shapes, they didn't know like the centimeters of the sides.
Okay, so the surface area might not have been perfect and it might not be exactly what we measured. All right, that's good. So we can make sure that it's more accurately cut our parachutes. What else could we do in future?
I think what we can change is that to make sure that the same person does the experiment.
Yeah, that's a really good idea. If the same person is releasing, then they're more likely to drop it from the same height. We could also do something to measure, couldn't we? We could probably do with maybe a couple of meter sticks or something so we know we're dropping it from exactly the same height. Is there anything else that we could do to improve this experiment, do you think? Go ahead.
We should all have the same amount of area that they're taken.
Well, that was we changed the area. That was the variable. So that's the one thing that we will change.
But maybe the shape of the surface.
Oh,
area.
yes,
Yeah.
the shape of the
Yeah,
surface
yeah.
area is definitely a good point. Right, year 3, we are coming into our, year 5, sorry, we are
Five.
coming into our last few minutes. So this is the point where we ask each year
Yes,
group.
we get behind the camera so that
Absolutely.
you're going to be talking to the camera. Can we just make sure, is everybody in there?
I don't think so.
Hello.
Do you want to just move in a little bit? Thank you.
Oh, yeah, it's your
There we go.
Right. So remember, you're talking into the camera, and it's question time now,
Question
guys.
time.
You get an opportunity to ask us anything. You can either
Anything
test
you
us,
want.
or it doesn't even have to be on this. It could be on
And it'll
anything
come
to do with
straight
science.
from our brains, not from our computer.
Definitely not from the computer. Right,
Mr. Keeling doesn't have
Juaria, what do you got?
What is air resistance?
What a great question, sir. I think you are perfectly qualified to answer this, seeing as you do year 5.
I think I am. So basically, in its simplest form, all forces, and we've talked about this a little bit, are pushes and pulls. Yeah. So what is happening when something is falling is gravity is pulling that object down towards the Earth. To explain air resistance, it is working against the gravity. It is the air that's all around us. Waft your hand in front of you. You can feel
you
it.
can feel it. It's there.
It's that. It's every particle that makes
Can
up
you all
the
feel
air.
Yeah.
Good.
And the more surface area there is, the more of that air can hit that surface and push against gravity.
Just to be clear, sir, air is like just nothing, though, isn't it? Because I can see right through it. So there is nothing there, yeah?
No, I'm pretty sure air is the liquid because you can drink air. Is
That's
that
right.
true?
It's gas.
It's gas,
So
right?
hold on
so,
one second.
Okay.
I know it's question the teacher's time, but I've got some questions for you.
Mm.
If air is a gas, are we saying air is just one gas?
No.
So who can tell me a little bit about air?
Mm.
Yeah.
Air is made up of oxygen.
Oh.
It is also made up of other gases.
Now,
Right, so you said that air is made up twice there, so that means that it's not real,
Oh.
right? It's made up.
made up like pretend. Is that what
It's
you're saying?
pretend, yeah.
Made up as in it's all that there's lots of things that add together to create oxygen.
Oh, it's
I love
composition. Yes,
So
right.
if this is all of air, and I'm going to do it right, this is all of air.
Whoa, look at all
Now,
that air.
I know that oxygen is that's O2. You know O2 is oxygen, right?
Mhm.
O2 makes up around.
Can we all say silly Mr. Jordan, please?
Silly Mr. Jordan.
O2 is a phone network.
Is he right?
Yeah.
Wait, but is O2 oxygen as well?
Yeah.
Can we all say silly Mr. Keeling?
Silly Mr. Keeling.
Oh, the energy. Right, sorry, what percentage is oxygen in the air?
20%.
Yeah, it's around 20% of it. So now, there looks like a lot of room left over there. So who can tell me another, I'm not taking you for this one, who can take me another major gas that we might find in air? Because if that is all of air, I've only got a small chunk of it being taken up by oxygen. So what can you tell me? Do you know what else? Can you think of another gas? Oh, gosh, I'm not asking you. Sorry. When you're too keen like that, because I want people thinking, and I want the chat thinking too. Maybe the chat also would be able to tell me what other gases they can think of. Come on, guys. I know you can think of some gases. Shall I give you tiny clues?
Yep.
I bet there's a gas inside those balloons.
Oh.
Yes. Okay, helium. Helium is taking, so can verify the exact percentage, but I think it's 0 point something. So you'll have a look for me.
I absolutely can't.
I'm going to say 0 point something. I might be wrong. It might be around 1 or something, but it's tiny. I'm going to say 0 point something. It's tiny. You can barely even see helium on there. It's minuscule. In fact, helium is hard to get, quite expensive. So yeah, there's not a lot of it about. No.
0.001% in the air.
0.001. Right, that's barely anything, is it? Right, I want some more gases. I know one. One that kind of. What do you get inside? You know what some of these lamps are sometimes called? You see it outside, like in Las Vegas and stuff, and lights that light up. They're called something lights. Neon. Yeah.
Neon lights.
Neon. Have you heard of neon?
Yeah.
Neon, sir. Would you be able to find out what percentage neon? Because neon is a gas.
Okay, neon.
These are not neon lights.
Uh, 0.0018%.
Okay, right. We're not really making up the numbers here. Hold on a second.
The big gases. What are the big
I know
gases?
another one. Hold on. Now, inside a light bulb, there is another gas that is non-reactive, and its name is R. Have you ever heard of argon? Argon?
Oh, I've heard of argon.
Argon,
Yeah.
sorry, it must be massive. Give me the percentage. Right, this surely is going to fill all of it, right?
Okay,
No.
so
Surely. Argon is.
I can click and collect from argon.
He's talking about Argos, isn't he?
Argos.
Say silly Mr. Keeling.
Silly Mr. Keeling.
Oh, I'm sorry.
Argos.
I'll look at the gas, shall I?
Yeah, please.
Okay.
Argon is, drum roll, guys. It's going to be big.
0.94%.
Oh, wow, it's a little bit bigger than the other ones, but it is still only that much. Okay, come on, guys. Now let's get to the big one. Surely we breathe out something, and I know the plants like it. What is it?
Carbon dioxide.
Carbon dioxide. Sir, this has got to be the killer one. This has got to be huge.
Okay,
It must be
okay,
enormous.
I'm ready.
Yeah,
Here we
go on.
go. Carbon dioxide
Ooh, you're right.
in
What do you think?
the
90%, 80%? What are we talking about here? Come on, could it be massive?
air
Right? Could it be massive?
0.20.
is
Oh, I love it.
0.00.
We're fact checking live.
0.26.
Fact checking live. I can see the chat is going absolutely wild for this. This is top quality entertainment.
whoa. This is high.
Wow.
Get ready.
Yep. Here we go, sir. This is gonna surely eat up the rest of the pie, right?
Yeah. 0.04%.
What? Yeah. Uh-oh. So it's not even there. It's literally another of these tiny little slices. Sir, I thought it was all about oxygen and carbon dioxide. Surely that fills up like all of the gas.
Apparently not.
There must be something else that is taking up this huge mega chunk, around 70%. There must be. I know
What's
there's
that one
also.
that's at the center of the sun?
Ooh, that. Well,
So
yeah.
I know one.
Maybe you could say that one. It's in a bomb as well, right? That's the one we're
Yeah,
talking
that
about.
must be everywhere.
The something bomb. You heard of a something bomb? Something that the sun's made up of. It's made of. Go on.
Oxygen.
Oxygen. We've already got that. So too.
Hydrogen.
Oh,
So
let's-
hydrogen, surely.
I'm
Come on.
feeling
This
good
has got
about
to
this
be
one.
the one, right?
Yes.
I mean, I've heard of hydrogen in the sun, and the sun's massive. I've heard of a hydrogen bomb, and that's a massive bomb. Surely we're now at the one. So come on, drum roll, guys, drum roll. This is the biggie.
0.
Oh, what?
0.00005.
Right, so that's
Percent.
actually the smallest amount. Guys, I thought that was it. There's got to be something. And look, it's taking up pretty much all of this air. We must be breathing it in constantly and breathing it out constantly. It must be all around us. It's one remaining gas. I'm giving a second to anybody else to think of anything. It might be another oxygen.
Oxygen.
Another oxygen. Well, we've had hydrogen. oxygen. So we've got another Jun. Go on, Masood.
Nitrogen.
Nitrogen, sir.
Right, let's have a look.
Is this the one? Is this the
No.
one that is
Don't
all
know.
around us,
No.
filling in absolutely everything, sir?
So in the Earth's atmosphere, there's approximately 78% nitrogen.
Pretty much all of everything around you is actually nitrogen, and you don't even know that it exists, and yet you are constantly surrounded by it. It's all around you. Nitrogen, nitrogen, nitrogen. Right now, I am touching nitrogen constantly here, and yet we never knew about it. Yes.
Isn't this still like 1.5% of something more?
There are all sorts of other small inert gases, are they known as?
Yes, yes.
There are a collection of them. But look, guys, I think this is the point, because Ms. Keeling and I are going to have a little 5 minutes before our next group comes.
I think the next group are coming.
Oh, they're here anyway. Fine, so we're not going to get that. But could you just turn to the camera? So will you just check that everybody's in shot for us for our nice little...
absolutely.
Could you come over here,
We
please?
are. Yes.
Yeah,
big
everybody's in
smiles.
shot. Right, look, guys, you have been amazing. The science we have learned today here has been incredible.
Should we do a check-in with how much we've raised as
Oh
well
my
at the
goodness,
moment?
guys,
Yeah.
you ready for this? Do you know what? Last time, I think it was around, was it £300?
Something like.
£300. Well, can we have some guesses? Do you think we've gone up a little bit, maybe? What do you think? Like?
£1,000.
No, I won't believe it's £1,000. What do you think?
250.
350. I think that's more reasonable. I think about 350. I agree with that. Go on.
450.
450. Pushing it.
750.
No, 750. Yeah.
650.
650. And last one.
500.
So come on, we're around the 500.
We are at 1,000.
What?
600
What?
and 65 pounds.
Everyone say yay!
And if we could keep donating, keep up those donations, it will be wonderful throughout
Can
the
everyone go,
day.
Please, please,
Please,
please.
please, please.
More donations, please, please, please. Right,
Give me
everyone,
money.
can you say a huge goodbye? Brilliant team, would you mind going and getting all of your stuff that you brought with you? That would be really nice. And then you're going to go and line up with Miss. She's going to take you out. It's been absolutely lovely. Wow, what an amazing adventure we have just had there. We've been learning all about gravity. We've been learning all about air pressure, air resistance, all of these things, and all of the amazing forces that work in us. And can you believe that that gas that nobody here even knew? Well, okay, I'm suing you about it. But that gas that nobody here even had a clue about, the gas that fills 78% of everything around us, that is actually nitrogen. Okay, nitrogen. You're breathing it in, you're breathing it out. It's not making any major effect on your body. It's just a gas that is around us all the time. And I think nitrogen's pretty cool, so I don't know about you. Big fan?
Love it.
Yeah, nitrogen is a great person to be
Just
with.
a quick message
Ooh.
out there, sir. Just
Whoa,
one of our
hold on a
sponsors
second.
we'll go to in a second. But
Yeah.
before that, if there are any people working in IT at the moment
Mm.
on our channel, I've just noticed
Yeah.
that our link on our Just Giving for the video at the top doesn't seem to work anymore.
Right.
So I think directly you can go to the Anglesey YouTube channel to view us,
Mhm.
but the actual Just Giving link doesn't lead to the video.
We'd
at
have
the
to give
moment
those
at the
people on
top.
ICT. Maybe I could have a little go at doing that in a second.
Okay.
Or we could at least get, maybe the people from ICT would help us just so we could give them a password username and see if we can make that work. That'd be really good, wouldn't it?
That would be really,
I
really
can't
good.
remember what the password username is. Do you?
I
think I texted it to you at one
can't.
point,
You did,
maybe?
but I can't remember.
We-
Just want to mention as well,
One of our
while we're
major
here,
sponsors
one of
for
our
today.
sponsors for today.
This is amazing, beautiful wax. They smell amazing. And this was Class 02.
Class 02.
Fantastic.
Found on
waxing.
Vinted, I think.
Now, more importantly, actually, just before year two do come in, and they are going to come in at 5:30, so I'm just going to wait for 1 second, is I do want to thank some of our sponsors.
Okay.
Right, because I think that's
Fabulous.
really important.
Absolutely.
We've had lots of people who've given a lot to us. So would you be able to just get up the Just Giving page somewhere? How would we do this?
Sure, I can
got it
get
on
that
there.
up over here.
If
yeah,
you,
one
Sir's going
second.
to just get up the Just Giving page, I'm going to fluff for a little minute whilst we do that. Now, I know one of the sponsors because they're right here. I want to have a massive thank you. They brought us these balloons and everything to Genie Cleaning. And Genie Cleaning have not only have they donated a Guess the Puppy game that you're all going to be playing later, but they've got this wonderful prize that you guys can win. So later on, after school, if you want to come and do a sort of guess the name, you can come and guess what you think this little fella's name is, I reckon it's got to be
Elon.
Elon. Probably Elon.
Elon Musk.
Elon Musk. If you do want
Speaking
to
of,
donate,
tweet at
tweet at
Elon Musk. Tell him about this
Yeah.
event and say, we could do with a
share
couple of
our
billion
live
pounds.
link.
Yeah.
He has just been paid something like 50 billion.
He's been paid a lot.
So
we could
if
do
you
with a
could
bit
donate
of
a bit
that.
to us, that'd be really nice.
Like
Elon Musk, please tweet Elon Musk
5% of that is all we
Just
need.
at him and then put our link and say please donate.
Can we
Right.
say thank you to 3S Associates?
How
Can
much
we,
have they given?
donated £50.
Brilliant.
Fantastic.
Oh,
And
that's amazing.
Tame Grounds Maintenance,
Yep.
£50 for the
Fantastic.
cause. To SDS Limited, who's given us Specialist Development Contracts Limited, have given us £200. £200. Amazing. Can we also say a big thank you? You've already mentioned Genie Cleaning Services, but they've given us £200 as well.
I think there was one near SDS. That one.
Oh, of course, we've got another 200, which is from Pure Leasing Limited. Thank you so much. I'm just going to check, is there anybody else?
I mean, we've got loads and loads of donations.
I mean, we've got
And we
wonderful,
will be going
wonderful.
through
We'll
it,
thank
thank you,
everyone
in a bit.
closer to the end.
Brilliant.
But thank you so much. Please keep donating. Please keep sharing this with everybody that's watching. If you know somebody that hasn't donated, say, all right, come on, let's donate. Let's buy some
Especially if it's Elon
computers. Especially if you know Elon Musk, because frankly, the radio silence is a little bit worrying.
Yeah, we've been tweeting Elon Musk for a long time. He's not got back to us, and we do think that Elon Musk should donate to us now.
Let's welcome the two.
How exciting! This is it. Well, we have been. That's so good.
Lovely
Maybe you could come over
greeting,
here and
everyone.
re-greet us. Come over here and re-greet us. I want to be greeted again, please. Wait, hold on. Let me hold on to this. Come over here to the camera area, please. And I would like a full professional re-greeting. Can you do the camera as well?
Is this section?
We are timed in for. We've got 45 minutes of potential time.
Oh, okay, I'll leave you here.
But
Come back. Bye.
wait, hold on a second. Who's going to be taking
Bye.
it back?
Back down.
At what point? Not in 45 minutes, surely.
Half an hour?
Something like that. Well, whatever. We'll do what we can. Do you know what?
We'll see
We'll
you
be
in about half an
watching. We'll watch.
They're going to be
Watch
watching.
along.
Everyone say bye, miss.
Bye.
Guys, and more importantly, I'd like that welcome again, please, for the camera, please, as well. Can you give us a nice big welcome? Are you ready? 1, 2, 3.
Good afternoon, Mr. Jordan. Good afternoon, Mr. Keeling.
Can anybody
my
tell me,
goodness.
and you've got it absolutely right, because it is the afternoon. We've made it to the afternoon, sir. Let's do a cheer for the afternoon. We have been going for 3.5 solid hours.
That's it.
Out of the full 26, we still have 22.5 hours left to go. But we have made it to the afternoon. We are still here. We are still teaching live science on YouTunes. And
It's YouTunes, right?
You know.
oh,
Everyone
YouTube.
say silly Mr.
Ah.
Silly Mr. Keeling.
I'm going to be hearing that in my, well, not sleep, because I'm not doing that tonight, am I? So, could you explain to me, does anybody know why it's called the afternoon? Why is it called the
Good
afternoon?
science. Good science.
Go on.
Because it's telling you when it's.
It is.
Oh.
It is absolutely, and that's a beautiful answer. It's telling us exactly when. Oh, what is that? That's the science bell. Time for a science fact. Does anybody know a interesting science fact that they would like to share with the camera? Anything about science? Go ahead.
Something about science is mini beasts
Mm-hmm.
can have different habitats.
I love it. You're going to talk so
Wow,
much about
that
in a
is
minute.
wonderful. So there we go. The science bell rang, and you got a science fact.
That's how it
The
works.
more you know. Right. Anyway,
3.5 hours. That's it.
3.5 hours. We are. Don't worry, sir. I've got lots and lots of content coming up. It'll be great. It'll be great. It'll be great.
Right.
It'll be great.
Can't
It'll be
wait.
great.
Can't wait.
What were we saying?
We were.
Oh, why is it called the
Why is it
afternoon?
called the
Why is it
afternoon?
called the
What's that all
afternoon?
about?
Yeah, go
Yes,
ahead.
yes.
It's because they tell a time when you can like do something.
I think that's a really good idea.
Yeah, some very good
Now,
ideas.
So I know one thing. Sometimes they call midnight.
Yeah.
Right. Sometimes they call lunchtime 12 o'clock. Do you know what they sometimes call it? They sometimes call it noon.
So why would they call
After
it afternoon?
Noon is 12 o'clock at lunchtime.
Noon
Yes?
is 12 o'clock.
Because it says after.
Ah, so it's all the time after noon. Is that right? Yeah?
It's after the morning.
It's so after. It's after 12 o'clock. That's so good. Oh my gosh, you guys have got such amazing information for me. Now look, you're actually, because we've got 45 minutes of you, you're probably going to be telling us all sorts of science.
Whoa.
All sorts of things, and I absolutely can't wait for it. I think at one point we're even going to go into the garden and dig into the soil and see what we can find.
Oh, I hope it's very,
Slay.
very dull and not bright out there, sir.
Well, here's the thing,
What?
though, sir.
I'm just saying for my
It's digging in the soil. What are we learning about, guys? Yes,
Science.
it's science.
Science!
You love that. And what else? Have a look at the camera because that's where we need to be looking. Very good. Yes? Habitats and millibees. Guys, would you mind saying? Yeah, do you want to answer it just in case? Would you mind?
Stopped.
Oh dear. Would you mind saying? Do you want to call it back, or I can go and call it back? I tell you what.
You call it back and I'll
Yeah,
take
you're
over
gonna
and,
take
and
over
learn
there.
a little bit for a second.
Keep going.
Okay. So could you tell me what you were telling Mr. Jordan? We're learning about what? So we said science and then we got very excited. What else?
We're looking at mini beasts and stuff that can be like some stuff that are,
Does that make me a mini beast?
no.
Mammal. What are the mammals? Do you know? You look like you're gonna burst. Go on.
The other animals are
Yeah, tigers, warm-blooded animals with fur. Mammal.
a wolf,
Wolf, warm-blooded animal with fur. Lovely. Yeah, warm-blooded animals with fur. So lots of mammals that we know. Out insects. I'm going to add that up there as well. So we've got mammals and we've got insects because we're going to refer back to mini beasts. But can you tell me another animal group that we know of? Go on. Well, ants would probably come under this section here. So that I'm not asking what insects there are just yet. We'll come back to that. I'm asking what group. So we've got mammals, we've got insects, we've got amphibians, haven't we?
So how much should be a minute?
We've got amphibians. All right. So we've got mammals, we've got insects, we've got amphibians. What else do we have? Oh, what are those things? Let me describe. Put your hand down for a second. Let me describe them. So this type of animal can fly. Don't do it yet. It can fly. They usually have a beak. And instead of fur, they have feathers. Can anybody tell me what type of animal that might be? Go on. Birds. Wonderful. Right, now there's another group of animals. Now, this group of animals, I'll describe again. This group of animals, they tend to have scaly skin. And nearly all of these are cold-blooded. So they're not warm-blooded animals. They can't make their own heat. They're usually so if you keep these as pets, you need to have a tank that has a warm light in.
fish.
That's not the ones that I was talking about, but fish is one of our groups. So there are fish, but there is one more that we're missing. Can anyone tell me what it is? Go ahead.
Spiders.
Oh, so we could add arachnids. Yeah, we could branch off from insects, but I'm talking about the main groups at the moment. And I want to know what the last main groups are. Does anybody know? The one that I described, the cold-blooded creatures with scaly skin. You might find a lizard is one of these. A snake is one of these. Anybody? No? What if I do that? How about now?
Reptiles.
Hey, there we go. Reptiles. Okay. So we said in the mammal group here, we have animals like tigers, wolves, foxes, humans, warm-blooded animals usually with fur. Okay, can anybody tell me any birds that you know or are aware of? Birds. Go on, we'll start with you.
Seagull.
Seagull, lovely. That's okay.
The robin.
Yeah, oh, I love robins. Robins are so beautiful with their red chests, aren't they? Yeah, I love robins. I love them in winter as well. Yeah, lovely against the snow to see a robin with a red chest. Yeah.
A sparrow.
Sparrow, yeah, Sparrow. Now that's a pretty cool name as well. Sparrow, I like that. Sparrow.
Is it called like a tick? A tick.
Yes, like a blue tit. Yeah, fabulous. What's the one that repeats?
Blackbird.
Blackbird, yes. That's not the one that repeats sometimes. Crow, yeah, crow.
Parrot.
Parrot, wonderful. I wonder if we know any types of fish. Do we know any type of fish? Fish, any type of fish?
Clownfish.
Clownfish. Do we know? Tell the camera. Do we know any special clownfish that there might be a movie about?
Nemo.
Nemo. Finding Nemo. Lovely. Any other types of fish that you know?
Goldfish.
Goldfish. Absolutely. And that's a pet, isn't it? That's a pet that we keep at home. Any other fish that we know?
The one that what's its name? It's the one that chomps fast and chomps.
The one that chomps fast. Do you know a fish that chomps fast, sir?
There's a parrotfish.
Killer
Are you talking
whale.
about that one? Oh,
That's-
killer whale.
that's
is not
a
actually
whale.
fish, you know.
No,
That's
it's
a
a
whale.
mammal. It's a mammal. But interesting. isn't it?
Piranha.
Piranha. Oh, the scary chompy chomps. Yeah. The scary chompy chomps. How about reptiles? Do we know any reptiles? Can we add in any reptiles? Go on, quick. No,
Fish is an amphibian.
not sure.
Snake.
Snake. Absolutely. Any others? Not sure.
Lizard.
Lizard.
Gecko.
Gecko. Wonderful. And let's do quickly amphibians. Any amphibians? I'll give you a clue. Rabbit.
Frog.
Frog and the bigger ones. The
Toad.
toads. And then finally, we're on to our mini bees. So, sir, would you just like to collect a few mini bees? Because I see that you're eager to get outside.
I'm eager for us to go. Are you okay if we go outside? Because I've got a strict schedule. I now actually need to keep to it.
Now, actually.
now actually need to keep to it. So, guys, are you ready to go on a little exploration outside with us?
Whoa!
We're looking for mini bees. So we're looking for vertebrates.
What?
Things with backbones, isn't
Are
that?
you looking for vertebrates, things with backbones like mammals and fish and that?
Yeah, mammals. We want to dig up. We want to dig up and find the foxes because they live. Well, they
Yeah.
do live underground. I think.
We're actually, guys, we're actually looking for invertebrates. Can you say invertebrate?
Invertebrate.
Fantastic. Don't turn to the camera and say invertebrate.
Invertebrate.
Now say outside, please.
Outside, please.
Let's go. Right, guys, are you ready? Yeah, that would be good. Do you want one child to hold a microphone?
Where's the
This
hotspot?
needs to go in your pocket. This one here. If you pop that in your pocket.
Sure.
Now, I just want to warn the stream, when we go outside and it gets bright, we do get very, very white. So we'll do our best to try and keep...
Is there anything I don't need plugged
You
into this?
do not... No, you do need all of that.
Right.
So, so just bear with us whilst the camera goes a little bit funny. Do you want child to hold that or are you going to hold that?
It's best just to.
Right.
build
So,
together.
guys, can you come and follow me, please? Wow, how exciting. Are you all excited? I'm excited.
I'm excited.
Yes.
Miss Coleman said you're spelling bad.
Yes, she's probably got a point. I would say spelling is
I
not
agree with that.
one of
Yeah.
my strong
I told
points.
you, you're writing with nonsense.
Yeah. Well, do you know what? We all have things to work on in our life.
Absolutely.
Spelling and handwriting is one of mine.
That's right.
Mr. Keeling, you're still working on...
I'm pretty good at things.
Tell you what, as we go along, let's see if we can find something Mr. Keeling needs
Miss
to work
Coleman
on.
said that we have to be a bit cheeky with you.
Oh, did she?
Right, here we go. We're going on a bear hunt. We're gonna get a big one. What a beautiful day. I'm not scared.
Which bit do I repeat? I'm not scared.
I'm not scared.
Say, I'm not scared.
Oh no, a door. A big closed door. We can't go over it. We can't go under it. Oh no.
Sir, do this one properly. Give us a second. We can't go over it.
We can't go over it.
We can't go under it.
We can't go under it.
We'll have to go.
Through it. Oh, we're going on a bug hunt. We're gonna catch a big one.
We're gonna find a big one.
We're gonna find a big one. What a beautiful day. Oh no, grass. Green. Beautiful grass. Onions.
Onions.
Oh no.
Onions. You grew these onions.
Yeah.
Well, guys, I would love to see the onions, but can you see anything on the screen, sir?
Barely
Let's
anything.
get
So
somewhere darker. Let's get somewhere darker. Come on, guys, we're gonna go this way. We get somewhere darker. So you can see it on the screen.
apologies again if you're watching on the live stream. When we're outside in the light, the camera is not very good with the sun. So we'll try our best to describe what's happening to you as we go along. And we'll try and get into the shade where you can see a little bit better. No, we just saw a bug. There we go.
What I'm going to try and dig up some soil, and maybe we could just talk about the pond.
It's done. There's no water.
I'm going to get hold of this. I'll tell you what I'm going to do.
I think, sir, what we should do is we should go to the beds and we should dig and we should just fill the tray to take it back into the classroom.
So you've got such a good brain.
So we're going to go to the beds and we're going to try and find bugs in there because we can't really see out here very well. And we're going to take the bugs inside with us. How about that? We all excited to find some mini beasts? Okay, I don't think you can see us very well on the live stream. I'm going to try and get something on this camera, but it's not very strong. So
It's very sunny.
yes, it is very sunny. You're right, and because it's very sunny, it can't see us very well. In fact, it's incredibly bright. But the children, right now, we're around a bed, and in the bed, there's lots and lots of soil. And Mr. Jordan is currently just fetching trowels for the children because we're going to fill up a tray. And in that tray, we're going to put all of our mini beasts that we find. What? So, year 2, what do you think we're going to find out here?
I think we're going to find.
Okay, what do you think we're going to find outside? And what do you think we're going to find outside?
I'm going to go with flies.
Yeah, what do you think we're going to find?
There's an ant. Ant.
You think ants? What do you think?
Beetles.
Beetles and
No,
slugs.
actually an ant.
An ant, okay.
Find some mini beasts.
Worms.
Slugs. Don't touch it. Slugs.
Slugs, maybe, in a damp space.
Sorry, I've actually got a mini beast. I want to make sure I keep him. Don't scream there. Whoa, we got one at least.
Oh, wow, we've captured one. Now, you can't see this at home, but believe me, it is the most amazing thing.
What have I got here?
Oh, that is gross.
Whoa.
Ew. Honestly, you are missing the best content we've streamed all day.
It's incredible.
That thing is disgusting. No, a worm. A beetle.
I'm not flicked up too much. That little beetle in the corner, we're going to keep that one there. We've got that slug. Well, you were the perfect person.
Yeah, perfect choice for a book.
Mini beast
What's
exploration.
a gold ant? It's because
A gold ant. We've got a slug. We've got a beetle over there. So I'm just going to have a quick little run and see if I can find any more things on the inside, yeah?
Rose plants here.
Yeah, he is. Wonderful. What have we found so far? What can you see?
I'm going to bring this over here because I've got an idea of a place where we might find some good stuff.
Okay, follow on then, children. Follow on, year 2. We are moving. We are looking for more mini beasts. And a spot where the people at home can see us. Which isn't very likely, I've got to say. So apologies, just my voice for now.
Right, underneath this, I reckon we're going to find something. So I'm going to move this out of the way. And,
Oh, wow.
let me see if I can grab any of these things that are under here.
Can we see anything under there?
Let's put a load of these ants inside here.
Oh, lots of ants. Oh, we've got a snail,
Loads of
a
ants.
slug,
Loads of ants, popping all the ants in here.
slugs and snails.
Love some wood lice. If I can find, here we go, wood lice.
Wood lice, wood lice. Let's all say wood lice.
Yeah, we'll hold them all when we get inside.
Ladybird.
Loads of wood lice.
All right, so I think so that we don't lose people on the stream, we should go back in.
Right, let's go.
Let's go.
Ladybird's going to fly away. I'm not going to take that one.
Okay, guys, we're going to go back inside and look at what we caught.
Let me pick this up. Let's go.
Follow Mr. Jordan.
We're going to find some rose swans. I'm not scared. A snail. A slimy snail. What we gonna do? it with our tongue.
We can't make it with our tongue.
We're all upside down at the minute.
We're all upside down a bit.
Miss, for safeguarding, can we close that door, please? Fabulous. We'll let you know, Miss.
Right, we're going to get all set up. Can you take these over to the investigation table, which is over there?
Oh, I would love an investigation stable.
I'm going to change this to HDMI 2. Can you come around over to this table over here? This is the new table. You see that? The moving table. That's it. Very good. Very good. Whoa! Now look at this. Look at this.
I think we are visible again. We are visible again.
Amazing.
Guys,
Amazing.
look at what you missed while we were outside. Look at this.
That is amazing.
Ah.
About skate.
So, if we have a look at what we can see in here, we can see things crawling around on the surface. What can we see here? We can see an ant. Oh, we can see another ant here. Can anyone tell me? There's 3 parts to a mini beast, isn't there? There's the the Can anyone remember this part of the body? The head, thorax. Can we all say that? Thorax, and then the lower part is the abdomen. So we've got head, thorax, and abdomen. Absolutely. Can we see anything else wriggling on? Ooh, what's this up here? Snail. So we've got a snail. We've got a snail shell. Certainly, we'll have to see if there's a snail in there.
Wow.
I think
unfortunately,
got a couple of interesting things as well. Like this one here, Sir was very excited about. Can anyone tell what this one is? Right, no, it's not a slug.
We've got somebody who's on the run.
Oh no!
Look at this.
We've got an escape. Someone's escaping.
Escaping. Gonna put these ants back in as well. So, can you see it on the big screen? Sir?
Yeah, we can see you, Sir. If you want to talk about it with the children over there.
We have got ants absolutely everywhere. Now we can see this slug is going. Now, do you know what these little things at the end of the slug are? Yeah, so these are where its little eyes are. And you see when I touch that, I don't know if it's showing on the screen. You'll see, yeah, it is. It's going to react to it. Okay, slug hasn't got a brain quite like us. It is an invertebrate. It doesn't have a backbone though. Absolutely amazing. I'm getting all itchy because I've got these spiders crawling all over me. Now, if we look, this guy is, wow, look at the beautiful stripes, the patterns on it. Doesn't it look great? Do you know? Do you think he's a girl or a boy? What would you think? Put your hands up if you think he's a boy. Put your hands up if you think he's a girl. Well, guess what? You will both be right because it's both a boy and a girl. Yeah, they're slightly different.
If that goes on the floor, I'm going to scream.
I'm going to just pop him up.
I'm not using that one.
Push him into the ground. There we go. Now, I've got all sorts of other things. And you can see running all around here, we've got loads and loads of little creepy crawly.
Whoa.
Ants.
Yeah.
That is another slug that's just coming out for a little investigation. Yeah? No, listen, I actually probably picked up too many ants because they're going absolutely everywhere. They are. Now, I'll tell you, ants are quite amazing because ants come all, ants all come from one ant known as the queen ant. So ants have queens, a little bit like we used to have a queen, except
they get a baby.
It is. Unlike the Queen of Britain, who passed away, unfortunately, the ants are all born from the Queen. It'd be pretty good if you came from the Queen, wouldn't it? Oh, we've got the microphone coming a little bit. So will you just leave a little bit of space so we can get the microphone over here? Right, I've got something over here, and I'm a big fan of these. These are known as isopods, and this little thing.
Do you want to put one in the magnifier?
Is a wood light. So that would be amazing. Could you do that? That'd be incredible. I'm going to pop this little guy into a magnifying glass.
I'm going to try and keep him
What
safe.
is that?
So it's going to go and put that. I
Is
think.
escaping again.
Yeah, he certainly is.
I think
Let me see if we can get a close-up for our video.
The slug doesn't like this, please.
No, he's trying to get
The
up.
ants
So it's going to show the
I think at the moment the wood lice is quite defensive, and what it's done, it's a little bit worried about where it is, so it's rolled up into a ball. It's just opening up. We can see its legs inside. It's holding on to a stick. I think it's a little uncomfortable in here, so I'm not going to keep it very long. I'm going to go and put it back into the mud where it'll feel a bit safer. But there we can see a close-up of the underside of the wood louse. There we are.
Absolutely amazing, Sarah. And I love what you were telling me about how they've got defensive. So we can see this little wood lice is going around, and you see that he's got that shell on the outside. Now, when he's disturbed, If he's disturbed enough, I'm going to irritate him a little bit here. He's a pretty confident woodlouse, this guy here. He's running all over the place. But normally when they're disturbed enough, I've got ants falling on me, they'll fall into a little ball. Would anyone like to hold on this little woodlouse? Right, you put your hand down here at the front. Yeah, I'm going to pop him first onto your hand. There you go. So there he is, crawling around. I'm going to get another one. Who's got their hand out? It's okay, it'll be fine. If you're going to hold, keep it under there. I'm going to pop that now. It's in its defensive position now. There it is, crawling all around you there. Would somebody else like to have a little carry of something? Who would be brave and carry the slug? Would you be brave and carry a slug?
Yeah.
I feel that if you've washed your hands recently, the soap on your hands might not be great for that slug, but I will put this little fella in there.
If you want to, you can put the slug in there.
That would be really nice. Would you be able to do that, sir? You didn't wash your hands. Well, that's good to know. So there you got your slug. So Sir's going to go and take that slug, and he's going to put it near the screen. So you can see, if we keep that underneath here so people can see that. Now you'll see
Have a little look here as well. We can see inside. Being very still at the moment, but I show you he's fine at the moment. The slug, we can see. Look, actually, we can see there its antennae. There you go. Have a very nice close view of the slug there we collected. There we go. Look at that. Actually, very sensitive creatures, as Sir says. If you wash yourself with soap, that can irritate the snail, but also salt can make the snail dissolve, and it's actually used as a pesticide for slugs. There we go. Look at that. Fascinating.
Really good. So I'm glad that we're now being a little bit quiet. Don't worry about your lunch. You'll get your lunch.
No.
Right, sir, it's nearly 5 to 1. Do we want to gather the children back together?
Yeah, it might be
So we
nice
can
if
do
we
some
can
questions
chuck
with
this
them.
back outside.
I can take it outside so it's all safe
happy
very
with that?
quickly while you get the children ready for some questions.
Right, guys, I absolutely love this investigation that you've done with us into. Oh, so can you go and get? So we've got another one over here, woodlouse. You've dropped it on the floor, have you? Do you want to go and pick that woodlouse up?
Well, this is all about working and closely observing, isn't it,
Yeah.
sir? Because that's a scientific skill, one of our 6 scientific skills that we're actually going to look at a little bit later on as well.
Right, guys, you want to come over here? I'm going to just change the background into input. We'll go back onto this one. And I'm going to pop this back over here. Now, we didn't find a worm, and I was really excited if we would be able to find a worm. It doesn't really matter. But I noticed something. Did all those animals, do you want to turn yourself around so you can look at the camera? I might just move the camera back a tiny little bit so I know that we're all in shot. There we go. I can see all of you there. Brilliant. Right. I noticed that those animals were not quite like us, were they? What were some of the differences between us as mammals and those insects? Do you think we can identify some of the key differences? Yes.
We are big and we have arms, but some of the mini bees has a little and they have lots of arms.
So in general, a lot of those mini bees, those invertebrates that we saw, were a lot smaller than us. And in fact, I can't think of a vertebrate at the top of my head that is bigger than me, although there is a possibility that there are some. Actually, now I think about it, there might be some jellyfish that are a lot bigger than me, and they are also invertebrates. But yeah, you're absolutely right. So what did you say about the arms? What have we got? How many limbs have we got? How many limbs? Do you know the difference between a limb and an arm? How many limbs have we got? 4, right. We've got 4 limbs. And actually, do all mammals that you can think of have 4 limbs? Should we go through a few mammals?
No.
Which mammal does not have 4 limbs? Does a giraffe have 4 limbs?
Yeah.
Does an elephant have 4 limbs?
Yeah.
Does a monkey have 4 limbs?
Yes.
Yes, although in some ways, some monkeys, they would say that their tail acted as a 5th limb.
Whoa.
So that's a little bit of a tricky one. Does a cow have 4 limbs?
Yeah.
Does
Stomachs, right?
Yeah.
True, sir. So that is one thing that seems to separate us mammals out a little bit more than insects. Now, some of those insects, did they all have loads of limbs?
No.
Turn yourself around and tell that camera. Did they all have loads of limbs?
No.
No. Which of those animals did not have many or any limbs? Yes.
Slug.
Right. Mr. and Mrs. Slug, and a bit of both, really, aren't they? They did not have them. There's their little back bit, and they've got these lovely little antennae coming off here. And he had lovely patterns on them, didn't they? There were one big limb. It sort of slides along, a big muscle at the bottom and moves it along. Yes.
Worm.
The worm, no limbs to that, but it's still an invertebrate, isn't it? Yeah.
Snail.
Snail, absolutely, really good. There's my little drawing of a snail here popping out. Look at the back, and he's got some
Little eyes popping out here. He's got
It's
a
an
big,
excellent drawing,
big
sir.
smile as well. Looking
That
at
you really
really
captured
enjoying-
how they smile.
Yeah, I think they have the most beautiful smile. Thank you so much.
How do you know if a snail is smiling?
Well, because it's my friend and it knows me.
No, it doesn't. What if
Should
it
we
does-
see if the year 2 staff as well are coming for the children now?
Yes, if the year 2 staff come to the children, that's
If
great.
they're
Obviously,
watching,
we've got
or-
something to do at 1:15 that we need to make sure we do properly.
Absolutely.
Yeah, but that doesn't mean that you need
No, no, no.
just yet, because there's loads more things that we want to discover. Hey guys, I know you've been looking at mini beasts, but you've been looking at some other things in science too, haven't you? Yes, what have you been looking at?
We've been looking at different flowers.
Whoa, different flowers. Come around, turn over here. Let's have a look over here. Right, guys, can you all turn around again? Because you keep looking at me, and obviously, you don't want to be looking at me. You want to be looking over there. What different flowers do you know? Because you identified some outside. Yeah, what do you know? Yes.
Rose.
Roses. Very good. Yes.
Bluebells.
Bluebells. I love bluebells. One of my favorites. Yes, tell the camera.
Buttercups.
Buttercups. My goodness, you guys are good at this. Yes, tell the camera.
Roses.
Roses. Very good. Yes. Oh, the flower.
No,
I love the
Sunflower.
Sunflower. Yes.
Daisy.
Daisies. Nice one.
Dandelion.
Dandelions. My goodness, you guys have got a book.
Now, earlier, the children were saying something about habitats, sir, and how mini beasts live in different habitats. Could we name some habitats and then talk about the habitats we might find mini beasts? So, just habitats to start with, not mini beast specific, but what habitats exist?
I love this. Can we list them? So let's think. Our first habitat. Yes.
So some animals can live on trees.
Right, you're absolutely right. Trees can be an entire habitat for an animal. If you were a big animal, just hang on a second. If you were a big animal, like let's say a monkey or a human or something, a tree wouldn't be an entire habitat. Do you think before you tell me some more habitats? Before you tell me some more habitats, and I love how keen you are, what defines a habitat? What is a habitat? How does something become a habitat? Yes.
If an animal just adapts to the place and just lives there and
That's
it
good.
has to adapt to the place.
Right, it's a place the animal's adapted to. It's a place the animal lives. I want one other little thing about it. Yes.
That some animals might not stay like in the.
Well, that's true. Yeah. Anything else you can think? What do you know about a habitat? So it's a place where the animals live. Anything else about it?
What does a habitat need? What does it need in a habitat for those animals to exist? Go on.
Food.
It needs to have a food
So,
supply.
sir.
Yes,
Right.
sir.
My house is my habitat because I live there, I sleep there, I eat there.
True.
Are we happy with that?
Yeah.
Wait a second. Can I always eat from my house? Does my house produce food?
No.
Wait a second. It does though, because I open the fridge and there's food in there.
No.
Yes.
My house makes food, doesn't it, sir?
Yes.
You
Yeah.
you can get some ingredients and make.
But I get that from the cupboard, right? That's where they come from.
Yeah,
Yes.
the shop.
Yeah?
Yes.
The shop?
Cupboard.
From the shop.
Oh.
Yeah,
Oh.
shop.
Oh,
You
so-
Does the shop
You-
make the food?
No. You get it from different animals sometimes.
Ah, right.
So we have to go wider then for your habitat.
So my
sir.
house is not my
It's
habitat.
not that.
No.
Because you-
So my
Oh.
street is my habitat.
Street
You
is
are
Street.
habitat.
Is my street my habitat?
No.
Wait, but I live there. I eat there.
You don't eat on the street.
Oh, that's true.
And you don't
Yes.
sleep on the So you could like sometimes some people that don't have a house can make one.
That's very true. Now tell me something. Can we get everything we need to survive
No.
from inside our city? Can we get everything we need to survive from Birmingham? Well, let's just think. Just you and me, can we? Do you think we would be able to survive from the things that we can get in Birmingham? I reckon we might just.
Let's do a check.
Yeah.
Would we be able? Is Birmingham a big enough area that we could grow some food?
Yeah.
Okay, so we can get food. We need food in our habitat.
Okay, that's one tip.
Do we have
Can I
enough
write these down?
resources?
Yeah,
absolutely.
food, and we're going to give that a tick.
Do we have enough resources in Birmingham? So can we get wood? Can we get plants? Can we
Yeah.
build ourselves a home if we absolutely had to?
Yeah.
Yeah, it's a
gonna
big
give that a
area.
tick.
We could get those kind of things. There's trees around. There's all sorts of things
Yeah.
that we could build out of. Okay, what about if I wanted to eat? Oh wait, no, I've done food. Sorry. If I wanted to drink, is there water in
Yeah.
Birmingham?
Yeah.
Yeah. What do we have? Because there's a fact, isn't there? And this fact is kind of put around quite a lot that Birmingham has as many of these as Venice. Do you know what Birmingham has lots of?
I know, so it's spaghetti.
No.
Are you sure?
Yeah. He doesn't have that much spaghetti.
No, we've only got like 2 spaghetti.
No. So you can
We've
get-
got Spaghetti Junction.
Yeah, we got spaghetti, but we don't have loads of spaghetti. But you do have some.
Yes.
Okay, fair
And
enough, fair
you
enough.
have you have different kind of food.
But what do we have lots of? Does anybody know the waterways that we have in Birmingham that these special narrow boats go up and down? Not tubes,
Water
Drains.
tubes.
not drains,
Water drains.
See?
not the sea.
We do have a lot of drains, sir.
We do have
I don't think
drains.
You're wrong. We've got a lot of them, probably more than Venice.
Yes.
Yes.
But the waterways are called
Canal.
canals. We have miles and
And
miles of
Canals.
canals. So would we have water for drinking?
Yes.
So
One
we've
plus
got
one
food, resources, and water.
Center.
Oh.
Well, that's what we were talking about for resources.
Oh, was that your
sir.
resources
Yes,
one?
we
Stuff
talked
to
about
go
shelter.
Fine. Tick it off then. Right, guys. So, what we call this environment is the urban environment. Oh my gosh! Did you know that if I do it this way, it's blue, and if I do it this way, it's black?
That is amazing.
How exciting is that, guys?
That's science.
That's science. What? It's exciting.
That's
Right,
big
guys.
thing.
I don't think we got very far through these, but I can see that your teachers are here, and me and Mr. Keeling need a little bit of time to prepare for quite a large extravaganza that's going to happen soon.
Fabulous.
So, guys, I need you to face the camera. And
Face the camera.
3 things we have to do, unfortunately, before we go. One is the question time for a second. Just
Absolutely.
before that. So, guys, whilst I'm behind the camera, have you got any questions for us? Yes.
Are you guys like a science teacher?
Yeah, for today.
Certainly for today.
Today with science. In fact, actually, who's been the real science teacher?
So far.
One of us.
It's you,
The
isn't
children,
it?
yeah.
You've taught us so many things about habitats, about mini beasts, about invertebrates. It's amazing.
Habitats.
Any more? And habitats as well. Don't
Mini
forget
beasts.
Mini beasts. What about, have you got another question? One more, maybe. It's the same person. Somebody else got a little bit of a question. Have you got a question for us? Put the microphone here for you. Have you got a question?
Silence.
Oh, do you know what? Sometimes
Silence is the answer.
answer.
Absolutely.
Right, guys. So 2 things now we have to do. I've forgotten. I know one of
We
them.
need to do our checking how much.
Checking
we've
how much.
raised.
Now, guys, earlier on, we had around 300.
Now it has slowed down a bit, sir, at the
It has
moment.
slowed
So
down a bit.
what I'm hoping is that the people watching at the minute can take a moment just to pause, to look at our QR code there, to scan it, and
Or click the link. in
or
the
to click the link in the
Might be
description
easier.
and just give a few pounds to the stream
Yep.
for all of these wonderful children that have helped us today. But we will do a
Guesses,
reveal.
Guesses.
Here we go. How
400?
much?
How much do you think it might be?
5,000.
No way.
5,000.
Well, that's ridiculous. 500?
10,000. 500.
500? Around 500? What would be a number near 500? 2, 3, that would be quite high. Yeah?
3,000.
Okay, well, we got some big ones, sir. Can you...
We got some big ones. I'm afraid it's not going to meet
Everyone,
those
let's
big
do a
ones,
bit of a
but
drum
it's going to be
Drum roll, drum roll.
1,675 pounds. Yay! Well done.
What we need to
Two.
do now is to
Yeah.
say
Two.
goodbye.
Goodbye.
Thank you so much, guys, for being here. I'm going to let you start walking out back to your amazing teachers. And Miss, they told me what they told you to do, what they told to do. To be extra cheeky, Miss. We know about it. We know. We know.
They told us. That's what they said. Bye, year 2.
Bye, you two. Right, guys. Wow, how lovely. We've learned all sorts of things about invertebrates. I think that's absolutely fantastic.
Absolutely.
Oh, now, have we dropped down a little bit?
A little
back up. Now, sir, I think you and I are going to need a sort of wind down and calm me down. So I might do a little story. Potentially, shall I read that whilst you get defuse, or do you want to? How do you want to do?
Oh, yeah, I don't mind doing a story. I brought a few
You can
facts,
do the
so I'll
story.
do a story.
Brilliant.
So let me go and select that.
Yeah, I'm gonna stay in
You
front of the
stay in
screen.
front of the screen.
Now, one of the
I'll
things
do a
we've
little
decided
sketch.
to do throughout this live stream is to read books, because we think that books are really important, obviously. But also, it helps us to understand science. It helps us to understand scientists. Okay, a lot of doing is experiments. There's a lot of talking, but you can learn so much about science just from reading. Okay, reading your stories, reading your books at home. And wow, this is a really good book because it's about someone who is very, very important. Someone who has done something very special. Would we say very special? Sir?
Very special, yeah.
Very special indeed.
his theories basically define how we see the universe at the minute. So everything that we understand about the universe was developed in a theory by this person. And we're going to read a story about him. And what you can do throughout the day, I will be talking about different scientists. And I've got a lesson about different scientists where I'll give you lots of facts later as well. And what we're going to do is you're going to write along. And if you've come to this after it's live, that's fine. Or if you come to it later in the day, you can just pick this up wherever you want. But we're going to put together a fact file of famous people, of famous scientists. And we're going to collect as much information as we can. So at the end of this, we'll just see what we've learned about this man here, Albert Einstein. So I'll read the blurb first. This is part of the Little People, Big Dreams series, and it has lots of really lovely children's books about key people from the past and key people that are currently around. So Little People, Big Dreams, Albert Einstein. Discover the lives of outstanding people, from designers to artists to scientists, and scientists are what we are interested in today. I'm very excited for the next one. Not that I'm not excited for Albert Einstein. I also have a book on Nikola Tesla, and I've visited Belgrade, where the Nikola Tesla Museum is, and they have some really, really fascinating stuff that we can talk about a little later on. But now we're focusing on Albert Einstein. So all of them achieved incredible things, yet each began life as a child with a dream. Little Albert was a child with few words, but many ideas. At first, he didn't quite fit in at school, but soon he fell in love with physics and maths and wrote his first scientific paper while he was still a teen. Now, there's a myth about Albert Einstein, and I believe the myth says that he failed a GCSE maths style paper. That's not actually true. Einstein was a genius, and in fact, nearly all the tests that he took, he passed. There was one test, I think it was an entrance exam to university or college or something like that, that he failed. But the only reason he failed it was because it was in French and he didn't speak French. Albert devoted his life to explaining the relationship between space and time. And there are so many fascinating things in the universe that still to this day we don't know the answers to. So many questions. And laid the foundations for much of the technology and invention of the 21st century. This story of the legendary scientist's life features a facts and photo section at the back. So let's have a look through. Little People, Big Dreams, Albert Einstein. I love the pictures in these books as well. There we go. Once upon a time, there was a little Jewish boy born in Germany who took 4 years to say his first word. His name was Albert. 4 years, that's quite old to say your first word. And for some time, his little sister, Maya, was his only friend. No one else had enough patience to wait for him to talk. It's real sad. Albert was 5 when his father gave him a pocket compass, which instantly became his favorite toy. There was something magical in the magnetic needle. It always pointed north. We'll learn a bit about how magnets affect compasses later. He wanted to learn how it worked. So from an early age, he was fascinated by how things worked. If you're writing the fact file, some bullet points or some notes you could take right now is he was 4 when he said his first word. He was born in Germany, and his father gave him this compass when he was 5 years old. Look, lots of his notations that he's pinned up all over the walls of the house. School was a bit of a nightmare for Albert, but back home, he loved diving into piles of physics and maths books, trying to prove theories on his own. By the time he was a teenager, he had published his first scientific paper. Now, when you go to university, you'll write papers and you'll do research, and some, if you're lucky and they're really good, might be published so that other people who research use your work going forward and refer to you in their own papers. But Albert Einstein was so studious, and worked so hard that he got his first paper published in his teens. And that's amazing. After studying maths and physics in Switzerland, Albert got a job at a patent office. That's where people who are inventing things, they put in a patent to say that other people to say that other people can't copy their design, because it's their original idea. In this place, amazing new inventions were recorded, but none were as groundbreaking as the idea he was working on at home. And I think we can see it here in the light. One of his the thing that he's most famous for is his most famous theory, his most famous notation: E equals mc squared. Albert was a bit organized, but inside that brain, his thoughts were in perfect order. He came up with a formula that said anything we can see and can be turned into energy. It became the most famous formula in the world. His curiosity led him to explore space and time by mixing two original ideas. And he turned physics upside down with his theory of relativity. When he was proven right on an experiment, every university in the world wanted to meet scruffy physicist. So, not always true of great artists or philosophers or scientists. Not always true that they are famous within their own lifetime. Let's have a look at Vincent van Gogh, for example, who was relatively unknown, and he used to try and buy food by using his paintings to pay for them, and he was rejected. Of course, now, if not the one of the most famous artists in the world, whose artworks are absolutely priceless, and some of my favorite artworks as well. But he never knew in his own lifetime that he would become this amazing, famous artist. He sadly died before he had any recognition for his work. But Albert Einstein wasn't like that. Albert Einstein was recognized in his time. It was actually of a celebrity. Albert was awarded a Nobel Prize for discovering photons, the tiny particles that light is made of. Still, he didn't attend the ceremony. He was busy traveling from place to place, sharing his knowledge with other scientists and thinkers. Was the call important earlier, sir?
The call was important.
Fabulous.
That's a good news. And also
Good news. Is news we can share?
We're going to have to delay this just a little bit further. I would be skeptical in sharing any news.
Okay, well, we'll see then. So here we can see pictures of Albert Einstein. And as I say, Albert Einstein was a celebrity. And he was meeting lots of famous people and traveling all over the world. So he was really enjoying his fame. Every country in the world received Albert with honor. But back home, a very different welcome awaited him. The Nazis had taken control of Germany. They planned to get rid of anyone who was not like them, especially Jewish people. It was not just Albert who was in danger, but also many of his colleagues. Before moving to America with his family, convinced governments and universities to hire Jewish scientists. Thanks to him, they could leave Germany too. So a really unsafe place, unfortunately, at that time, to be Jewish like Albert Einstein was. When the war broke out in Europe, Albert feared that the Nazis could use his discoveries to create the most terrible weapon in the world, a nuclear bomb. He sent a letter warning the President of the United States. So there was a race at the time to create these weapons of mass destruction to end the war, not necessarily by firing the weapon or by hurting that many people, but by having that amount of power, and that amount of power to scare people. And what Albert Einstein didn't want was he didn't want to be a part of creating that weapon for Germany and for the Nazis. He always regretted signing that letter. It led to the United States making their own nuclear bomb. Albert had always stood for peace and the thought that science should only be used to do good. That's why he refused to be involved in the creation of such a weapon. And actually, the creator of the nuclear bomb, Oppenheimer, often was known as he stated that he was the destroyer of worlds, and regretted the fact that that power could be used on such a massive scale. He became an American citizen and loved his new home. Still, he felt terrible about how the country treated his black fellow citizens. Whenever he could, he wrote against racism and used his fame to speak out about it. And that's something amazing, isn't it? It's taking a platform and it's taking all of that fame that he's been blessed with and using it for something good, for a good moral message, and passing that message on to others. And by always questioning everything, little Albert became one of the most original minds of the 20th century, a genius who proved to the world that curiosity and imagination are more important than knowledge. Let's hope so for the rest of this Teach-A-Thon, eh, sir?
Yes, let's hope so.
Let's hope so.
Yeah.
Yeah. So that's the end of the story, but I'm just going to talk a little bit more about a timeline of Albert's life and just some facts, starting from 1888 and moving up 1944. So he was born in 1879 and he died in 1955. Albert Einstein arrived to parents Hermann and Pauline on March 14. In Ulm, Germany, brother to Mayer, Albert grew up in a non-religious Jewish family. His father, Hermann, was a salesman, an engineer, and his mother, Pauline, ran the family household. As a young child, he had what was considered to be speech difficulties and turned to classical music. I hope if you're working along with this at the moment, you're still taking those notes down and you're writing anything that you think is key information, whether live or afterwards.
It's nice if we did a little quiz maybe on it afterwards.
Yeah, it might be nice to do a little quiz on Albert. I might put that in later because we are going to look at some famous people tonight. Albert felt alienated at his school. So that's when you kind of don't feel like you're part of the group, that you're with everybody else. A bit lonely. Struggling with the school's rigid style. Soon, his family moved to Italy and Albert continued his education in Switzerland. In 1896, he entered the Swiss Federal Polytechnic School in Zurich to be a teacher in physics and mathematics. Unable to find a teaching post on graduating, he went instead to work at the patent office, and that's where he saw lots of brilliant ideas. And it probably gave him lots of thinking time. So him doing that would have given him more time to come up with the theory of relativity. In his spare time, he read and wrote, and in 1905, how long ago is that, sir? 1905?
1905. I think I just do the quick calculations on it. I think it's quite a long time ago.
119 years.
That's exactly what I was going to say.
119 years. Wow. So in 1905, Einstein's miracle year, as it's known, he penned a series of papers that changed our view of the universe forever. So imagine that. You've got the whole universe in your mind, how it exists, what it is, completely changes because of one person. How amazing is that? In the theory of relativity and beyond, Albert always appeared to have a clear view of the problems of physics and was determined to solve them. In 1921, he won a Nobel Prize in physics. Now, Nobel Prize is amazing anyway, not many people get it, but it's even more impressive when you know you get $1 million for winning the Nobel Prize.
Whoa, $1 million?
Million,
That's
yeah.
a lot of dollars.
It's exactly how much Elon Musk needs to donate to.
If
this.
Elon Musk is watching this live
Yeah.
stream, I really do hope that everybody watching can tweet him. It would be really nice because this is all about science. Elon Musk is all about science.
Yeah.
This is investing in children and the future. Really
We might even teach about him if he donates $1 million.
If he donates $1 million,
$1 million,
Minimum.
we'll do
Then
a lesson.
we'll do a
on it.
whole lesson on Elon Musk. It'll be here, it'll be live stream. It'll be massive.
I think if we get it trending on Twitter, anybody who's watching now, if we get it trending on Twitter, if you're with your classes, with your teachers, if you're watching in the hall in school, or if you're watching at home, hashtag Elon Musk donate $1 million. Hashtag Elon Musk.
At him to start.
Yeah, at Elon Musk. Tell him what's going on. Tell him we heard and we're celebrating his pay rise.
Yeah,
We are very,
very.
very impressed with his pay rise. And just asking for a small sliver of that, £1 million pounds.
$1 million will do.
$1 million will do. If you can give more, which you can, then please do. As the Nazi Party rose to power in Germany, Albert migrated to America in 1933. So it was quite a long time before the war started, which was 1939, 6 years before the war started, and never returned to his home country. There he used his platform to advocate for social justice, especially for Black Americans. Today he continues to inspire generations of great thinkers across the world, and is one of the greatest physicists in the history of humankind. What a wonderful, wonderful story about a wonderful, wonderful man that made some wonderful, wonderful changes to our world. We will learn about other people throughout the stream. I've got a story about, a longer story, in fact, about Isaac Newton, and we might dip in and out of that because it's quite a long story. I've got Nikola Tesla, and then I've got some subject-based books. So as we go through our lessons, which will be incoming, we will look at some other topic-related books too. But thank you for sharing in that moment with me. I really enjoyed reading that too, and I hope you enjoyed the story of Albert Einstein's life.
I really enjoyed the story about Albert Einstein's life, and I think science isn't all about just test. It's about understanding science, where it's come from, who these people are, and he was quite an inspirational character. And do you know what I like about the story about Albert Einstein is that even though he came up with all these theories and he was, the greatest person on earth, and everyone thought that was, but a lot of it got disproved, didn't it? A lot of it, and do you know what? I don't for one second think that he would be upset or worried or concerned by that, because that's what science is. Yeah. It's about coming up with these ideas, it's about trying something, having a go. And hey, if you're wrong, that's science, because you now know that that's not the case. And actually, in science, knowing something's not the case is almost as good as knowing something is the case, because we're ruling out things.
And it's something that we stress as teachers. It's something that we stress a lot as teachers, that it is absolutely fine to make a mistake. And actually, no, it's not fine. It's more than that.
It's more fun.
It is exciting to make a mistake, because if you make a mistake, we can learn from it. If we know everything, there's nothing to learn. But life is a learning journey, and not everything that we know now is true. No. So we're all making mistakes. We just don't know it yet. So let's have a look about what is upcoming. So I believe, sir, we're going to have an extravaganza soon, aren't we? We're going to be having an extravaganza coming. We are also having year sixes, I believe, still need to visit us. And that's the one that's going to gross me out a little bit, I think. I don't know if I'm going to be able to do that. I'm going to try it, but I don't know if I'm going to manage it.
I'm very much relying on the year sixes for that, because I've sort of forgotten all the bits of the heart. So let's hope they
Right. Well, maybe we have a diagram up.
We can have a diagram up to help us with all of that. I know that there are different chambers and bits and bobs, but year six are going to really
What's coming up now, sir?
Well, I think we're going to have our basic extravaganza. It's a bit of a shame, because we did have something else that was just squeeze in, but that's not happened. One of the things with doing these things live is, and I keep looking up stuff. One of the things when you do these things live, you have these little plans, you have these little schedules. It doesn't always quite go to plan. No. So what we'll do is we're going to shift things about a little bit, and maybe we might end up hearing this twice, potentially, if something else changes this time.
Okay, sure.
I know that I just want to thank also the BBC, who have been sharing our Teach-A-Thon link amongst all the BBC staff.
Oh, wow.
Which has been really nice. I know that they took that and they internally shared that just recently.
Wonderful.
So that was really, really nice of them. And so thank you to that. And I also want to thank you. There's a growing number of people pledging support. So not just individuals, but companies and suppliers and all of that.
Wow.
We will, at a later date, we'll start shouting out individuals, people who have contributed all of that. And we'll have time to thank all those people who have made such a big
to the children at our school, and it is such a big difference, isn't
It is a massive difference. You know, these are key areas where the children just need that support and need this kind of key technology to access, you know, the kind of core learning that we want them to. So every penny, every single donation is so much appreciated because it's making a difference to children's lives.
I'm going to move this table back a little bit so we've got a little bit of space, because I know now we're getting something rather special.
Wonderful.
Rather
And is this well, what is this that's coming in, sir?
This is known as the speech and language based extravaganza.
The speech and language based
Extravaganza. And I'm going to move that. I'm sorry if that's all wobbling. I'll take a little spin around.
We need a new. Do we need something up for them on the board?
They're going to put something up on the other board. Maybe we just give a nice clean screen for them in case they want to do something. So I think it might be something to do with the solar system. So we can potentially put a
Solar system, wonderful.
You are a big fan of the solar system.
I love the solar system.
One thing I know about you, sir, is you love the solar system.
That is the one thing you know.
Yeah, that is the one thing I know.
That is the one thing you know.
So I'm going to write down here speech and language based. I'm not actually going to write that. I'll change my mind.
Should we just invite them in and see what they've got?
Yeah, I'm hoping. I'm just putting time. Is she ready?
Yeah, let's
She looks at it. Right, well, let's do it. Right, brilliant.
Fabulous.
Hello.
Whoa, hey.
Welcome.
What a treat. Right, I'm going to come and check that we're all in shot. So do you want to come in front of the camera? That'd be really great. Who we got here? I'll get all your names in a second, which would be really, really nice. And you might have to do so. Oh, can I say something else whilst we're on here? I just had a message back from the BBC. It says they've done their research and checked, and there is currently no world record for the longest science lesson.
Oh, wow. Okay.
So we are still in it. They actually contacted Guinness themselves.
Oh, fabulous.
Yeah.
Right. Well, there we go. So we
we're
can
still in with the shot.
We're still doing it.
Right. Let's go. Let's get a few more people in, please.
Come on
Can we
in.
get in line.
Come on in. Come on in. Don't be shy. Come on in.
These are all you're telling us all about Smarties today, aren't you? That's what these all are.
Oh, delicious Smarties. Yeah.
Mr. Keeling and I love Smarties.
Oh, there's the science bell, sir. Whoa. We need a fact. Does anybody have a fact? The science bell has just gone. Anybody know a fact? A scientific fact. Go ahead.
Mercury has no moons.
Mercury has no moons. Thank you, Science Bell.
The science bell has rung. Brilliant.
Wonderful.
Right, we're going to keep getting you in a little bit more, man. If you can get yourself over here, Miss, can you tell him when to stop? You look at that little screen down there. You'll know when.
Yeah, he's all
Right,
right.
yeah.
Start.
So keep coming in. Keep coming in. That's it. Keep coming in.
I don't
Brilliant.
think
Keep
so.
coming
We need
in.
to move over a little bit.
That's it.
Bit more.
not
Bit more.
turn
Bit more.
around.
Bit more. Bit more.
Can the man go any further?
I think we're all in, sir.
What I would like, we've all been given permission, I presume, and all that's been
Yes,
that's
yes, yes.
fantastic.
Wonderful.
So what I'd like is your first names and not your last name. Remember, just your first name. You okay to do that? I'm going to go through, introduce yourself to everybody. So I'm going to start from over here. So, Numan, what is your name?
Numan.
Excellent.
Numan.
What? Thank you for spelling it as well. But don't worry, guys, you don't all have to spell it. That's great.
Amateurs.
Amateurs.
Diver.
Max.
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 Marcelo.
Marcelo.
Ika Alma.
Excellent.
Lucia Lewis.
Fantastic.
And
Amina.
Mahida.
Excellent. The Eternal Sunshine.
Katarina.
Yes.
Habibali.
Wow, Zed. This is absolutely fantastic. And Miss, do you want to?
Yeah. Do you want to introduce what's going on?
That'd be really nice.
Okay, well, where am I in shot?
Well, that's the important bit.
You're right in the centre, Miss.
Miss, just the perfect.
Okay, so we are the Anglesey, amazing speech and language base, are we not? We're SL1. Show your planet if you're in SL1. SL1. And we're also SL2. Show your planet if you're in SL2.
Yay!
And we love science. In fact, we also made stomachs earlier this week, didn't we? Who wants to say anything about the stomachs we made? What did we put in there? Marcelo?
What was it? Crackers.
Yeah.
Water and orange juice.
Yep. And then what did we do with them?
We smashed it.
Yeah. And then what did we use as the intestine?
Tights.
So.
Oh,
Yes.
wow. This is so exciting. So it's about the planets, about the solar system. And guys, you're not going to feel too annoyed if you sing this song twice, are you?
No, at a certain point, I might call you back to do this again.
Oh, I'd love that.
Oh,
Do you know what I love hearing more than hearing a song once?
Science.
Yeah,
Of science,
that's
yeah.
it.
That's
You got it.
You got it!
Science!
Woo! What science?
Brilliant. Right. So we're learning about the solar system. I can't wait for this. We've got all, and these are all massive Smarties, and I love Smarties. Yes. Smarties. These are Smarties, aren't they?
No.
They're not
Here he is.
Smarties.
Here he
What
is.
are they? Oh,
So,
fantastic. Good timing. Well, just hang on one
Actually,
second. Hang on
as
one
it
second.
happens,
1 second, because we
Let me-
have a second special guest. If Mr. Keeling wants to come on 1 second, I'm going to bring you back in a second. I'm going to bring you back in 1 second.
Yeah.
Sir, I have a series of surprises for you today that I haven't been telling you.
Oh, right, okay.
Okay, and your next surprise is coming in right now. And this is just perfect timing, sir. If you want to come in, would you guys, everyone say, hello, Kahlid! Hi! So are you okay to come in here? So Kahlid Mahmood, guys, if you'll come in a little bit
Come on
further,
in,
sir, if you
yeah.
can come and stand just here at the minute. Kahlid Mahmood is our local MP.
Whoa!
And
Give somebody to.
give it a little photo or something. Is that all right?
Well, technically at the moment I'm not your MP.
You're not MP or candidate, okay?
Yeah.
And of
Oh,
course,
yes. Time,
all
time.
parties are an option.
Absolutely.
But Kahlid Mahmood said it was really important as someone who represents our area and someone from our area that he wants to be a part of it. We're going to take a little
Yeah, a
smiley
little group
shot.
photo, everyone.
Everyone smile. Brilliant. That's very nice. Thank you so much. So, sir, we have this is the speech and language base, and they prepared a little something they'd like to share with you. Is
Yeah,
that okay?
they've got a song, I believe.
They
isn't it,
do.
sir?
Yeah.
So we're going to step out because this is their moment.
Nick, do
This.
you want to explain anything else before we start the song?
Yeah, so
just that the children really love learning all about our part of the universe, which is called, what do we call it? Our solar system. Are we the only solar system in the universe or even in our galaxy?
No.
Yeah, so we're going to perform our song and a few facts about our solar system.
Step into Wix Studio, the platform for agencies and enterprises.
So we're really looking forward to this, and these children have overcome lots of obstacles to learn our song. Are we ready? Let's give it our best. Okay, ready? Don't worry.
I am the sun. I'm ready for the fire. I'm ready to believe. I am the sun. I am Mercury. I'm a star that light to the sun. I'm all alive. I have no roots. I am Mercury. I am Venus. I'm a star but I speed of the rain. I'm much more slowly. I have no water. I'm Venus. I am the earth. The place where we all live. Round us the sea and the blue. I am the moon. I am the earth. I am Mars. I'm a rocky planet. Mountains are the highest in the solar system. I have two moons. I am Mars. I am Jupiter. I'm a last giant. I'm the biggest. And I spin the fastest. I'm the biggest moon.
I am Saturn. I'm a gas giant. My days are made of ice. Saturn is my biggest moon. I am Saturn. I am Uranus. I'm a nice big gas giant. Solar system. I have been made of dust. I'm Uranus. I'm Saturn. I'm an ice gas giant. And that is planet from the sun. I have many stones. And Neptune. Right, everyone have that really nice. We are the solar system. We are the solar system.
Oh, that was
Isn't that
absolutely
lovely?
fantastic.
Wonderful.
So, just on a little bit of a limit, is there any chance? So, would you mind just coming in and maybe we could ask if just so we got a little shot with Mr. Mahmood, and maybe could you ask? We could ask a couple of questions, maybe.
Yeah, of course. Yeah.
So, do you know much about the planets?
A little bit.
Go on then.
Anyone maybe?
I'm a Star Trek fan.
Star Trek!
Tell by the eyebrows, sir.
Fantastic. Guys, would anyone like to just tell Mr. Mahmood, Kahlid Mahmood, the candidate, if anything about any of the planets? Would you like to give me one fact? Could you, Numan, could you tell me one thing about the sun?
The sun is big. It shines so bright. It gives us warmth and a lot of light.
It does. Wonderful. Fact. What a fact.
Mercury is small and quickly zooming around. It does the trick.
Well done.
Lovely.
Venus is a glowing star. Who is really a planet, not so far.
Excellent.
Earth is a leaf. The earth is where we laugh and play. It's over home night and day. Mars is where we dot around.
Mars is red with dusty ground. Rovers roam and
Lovely. Well done. That was beautiful.
Jupiter is the giant with the stormy spot. It's the biggest planet we all got.
Wow.
Well done.
Saturn was
rings.
rings at
That's
girls and love made of ice and can rock you know.
Well done. Thank you.
On the side, titles that give the correct advice.
good.
Yes.
Last one, big one.
Saturn is deep and deep in
Stormy
stormy if
winds.
winds are blowing too.
What lovely.
And we have to say that all of our children are with us because sometimes they're not very confident about their speaking, or there might be different things about reading and speaking that we find challenging. So to come and to be able to perform in front of you,
Thank
Mr.
you.
Mahmood, is a real honour
Yes, very,
and
very
so brilliant for the
confident.
children.
Brilliant.
So well
Yeah,
done,
yeah,
children.
Right, am I okay to get the kids out for a second? And I know I've got to get something.
Certainly. Good luck on
guys,
July
you've done
4th,
fantastic.
sir.
We're going to go this
Thank
way.
you so much,
Just
guys.
quickly.
I can't wait to hear that song again if we do later
Yeah.
on. That would be
Okay.
wonderful.
Thank you.
So and we're not going to keep you in this room because I know you're very kindly. I will keep you 1 second. You're very kindly going to go and speak to some of the kids in the school,
course.
aren't you? Which we're really grateful for.
Wonderful.
We're going to go and speak with year 6.
Yeah.
But science is an important thing
It
for
is, yeah,
children to learn.
absolutely.
Isn't
Yes, absolutely. Brilliant. Yeah.
it? And I know that education is something.
Absolutely.
Key
I
to
think
your
it's
heart.
really, really key. I think Something that I'm doing at the moment, which they're working with the DWP, Job Centre Plus, and the Combined Authority, is young people who are not able to get qualifications at school.
Yep.
Is provide additional training for level 3, so we can get them in deployment.
Oh, well, that is
That's so
I mean,
important.
it's a lifelong thing, but unfortunately, sometimes we fail young people.
Yeah, that's really good. Thank you so much.
That's-
I've got a very clammy hand, but I'm still
No,
going to
that's
shake
fine.
it. Sorry, I'm shaking a lot of hands.
Thank you so much for coming.
So,
It's really great
can
to
I ask
see you.
Miss, are you all right to, so it's going to go and talk in the hall? Have you got a second to take so down? And if we just let the year 6 and 5 know, and then they're going to come in and join in. Is that all right?
Okay.
Is that okay, sir?
Thank you, Rich.
Thank you very much. Are you okay talking with people? I'm
Yeah,
going to put you on the spot.
Yeah,
Of course you are. Brilliant.
Thank you.
Brilliant.
Thank you
so
so
much
We'll
for
see you
coming in
again
and joining
soon.
with our live stream. So, like I told you, I have a series of surprises.
Right, what's the next surprise
Yeah,
then?
I'm not telling you.
No. When is the next surprise?
4 o'clock.
4 o'clock?
Yeah.
Okay.
Well, you've got a little one at 2 as well.
Got another one at 2?
Yeah, a little surprise at 2.
Wow.
Right. So,
So what's next?
bit of my nerves was just making sure that happened when we came on time because we, tight schedules.
Tight schedules.
So, what's going to happen next? In a bit, I'm very excited for this. We are going to have year 6. We're going to come in and do some heart dissections. Now, I don't know a lot about heart dissections, and really,
I don't know too much, and I'm a little bit worried about that because
it's almost the worst time, really, for us to have done that experiment that I don't know much about and you're scary about.
Yeah.
Because we might be having the BBC coming in and filming that.
the heart dissection.
Yeah,
that we don't know much about.
That's your next surprise.
And that I'm grossed out by.
That's what's going to happen, yeah. So probably the BBC is going to be here to film that, and
Okay.
That'll be part of the experience of the day. And then, hey, we might be on the news later on, which would be amazing.
It would be amazing if that happens.
I did tell Mr. Keeling there's quite a few little surprises for him through the day. I want to keep you on your toes, okay?
Yeah. Well, that's needed. That is
You've
needed.
met the counsellor. You've met
Yes,
MP.
I've met people.
Who else are you
That
gonna
is
meet?
true.
Ask the question.
All right. So, do you want me to introduce my PowerPoint and then start working through it for now, or is something going to be happening relatively soon?
Something
Because
is.
I'm realizing that we're doing a lot of filler at the moment. So
Yeah. So
Yeah.
what's going to happen is something very soon. So
Yeah.
I'll tell you what, I might have to just rush down to the office.
Okay.
Check that thing's going to happen properly.
Sure.
You're going to use a little bit of filler time. And one of my favorite things about this 26-hour Teach-A-Thon are the filler moments. They are
Let's keep it science, sir. Have we got any science facts? We need to be teaching science constantly.
now filling something, a hole, that is about filling an empty space. Now, believe it or not, in space, there is nothing. Now, I know the children were coming in earlier on and they were saying, there's nothing in front of me, there's nothing here. But actually, all of this empty space is not really empty space. It's absolutely jam-packed. Now, for those of you keen listeners who have been following along with our science, who can tell me, can you put it onto the live chat, what is this space in front of us filled up with? And I will not take the answer air. I'm not allowing it, okay?
Yes.
I'm not allowing it.
Actually,
So-
you should have percentages too, because we
if
did
we could have
all that up.
percentages too. So if we could have some people coming into the live chat. We've got one comment down here that says, Mr. K, love your haircut.
Again,
That's really good. You've got quite a lot of
I've got
comments
quite
about your
comments
haircut.
on my haircut. I
It's
didn't
really,
realize
really
it was a
nice.
new
It's very
haircut.
good. We've got the
Okay.
next one says here, it says, Mr. Keeling, where's your jumper gone?
I'll put that on actually when I teach this
Yeah,
next bit.
I think that'd be good. That will add a little bit to it. We've got a few more comments in the live chat down here. This one says, well then guys, really enjoying the magnet experiment.
I enjoyed that one,
I
actually.
enjoyed
That's
that.
probably one of my favorites.
Yeah.
Right, so we're going to have a little look. I'm going to actually start my PowerPoint because I've got 300 slides. I made these in preparation for today, but I turned up and Serge just surprised me with lots of other stuff that we were doing. So
I'm going to go and try and organize one of those right now.
onto my slides a little bit. So
I'd love to stop this immediately.
yes,
But I'm not going.
okay. So the first topic that I was going to look at with you all, and I've got about 42 slides on this because I've gone through all of the curriculum from year 1 up to where it ends in year 5, actually, where we teach. And that's about plants. So I did ask some questions. What do you think this topic may be about? So you might want to add them into the chat if you're doing quizzes or writing along at home. What kind of things might be covered in this topic? Remember, we are starting quite early on. So some of the knowledge might seem a little bit easy to start with. Might not. You might not know that much about plants, but the knowledge may start off pretty straightforward and simple, and it may build up as we go along. So what do you think we might be talking about in the topic of plants? What areas do you think we will cover? What do you already know? And I would love if we look through the chat a little bit later and can find out what you already know about plants. And if you're in year 1, you should know some things about plants already. Right up to year 6, you should know a lot about plants. So we're going to go into year 1 learning first. And the key knowledge really is to name and describe a variety of common, wild and garden plants. And if you are along with us right now, I wonder if you can tell me what the difference is between wild plants and garden plants. Is there a difference between wild and garden? Well, there is, because we've separated them. We've classified them with the common and wild. So there will be a difference. And I'm wondering if you know what that is. Let's have a look. Any answers on the live stream at the moment? Not popping in, but if you are watching live, do you know anything that might be different about wildflowers and garden flowers? I think it's quite obvious the first difference that you might want to add in there. But if you do, just pop it into the chat and I'll check back with the chat in a moment. But we are going to be naming and describing common, wild, and garden plants, and that's really what we'll focus on. We'll also have a little look at the different parts of the plant. But before we do even that, we are going to do an experiment. If it comes up, we are going to do an experiment, and we are going to write up that experiment. Let me just check that we can see that board there. Wonderful, we can. We are going to write up an experiment. Now, we started with the Mentos and the Coca-Cola experiment earlier, which we will finish off later today. But this is an experiment all about, you guessed it, space. No, this is an experiment all about plants. So what you will need for this experiment is any type of seed you have at home. Now, the seeds need to be the same type of seed. So you can't have cress seeds and sunflower seeds and apple seeds and other types of seeds. They need to be the same seeds. And you are going to need 4 different types of seeds. Now, we're not going to do this here. You're going to do this at home. This is one to do at home. You need 4 seeds. And you don't need to do this live at the minute. You don't have to have these seeds ready. You can always go out and purchase these seeds if you want to try this experiment. But it's a fast little fun experiment that you can try at home. The best type of seed to get for this experiment is cress seeds. If you can't find cress seeds, any kind of fast-growing flower plant will do. But really, I recommend doing it with cress seeds because they're the seeds that you'll get almost the quickest results with. And what this experiment is going to explore is it's going to explore what a plant needs to grow. Now, do we know, people who are watching the stream, what kind of things a plant needs to grow? I think we've talked about it on the stream a little bit before. Can anyone pop into the chat what a plant might need to grow? If you're on the chat, pop it in. What does a plant need to grow? Well, one thing is sunlight. We mentioned earlier with the children that the core place that we gather energy and the core place that plants gather energy, in fact, the place where everything on Earth gathers its energy is from the sun. So one thing that plants need to grow is sunlight. What else do plants need to grow? Well, generally, we need to plant those plants, so they'll need some nutrient-rich soil. Sunlight, nutrient-rich soil. What else do we need? Hi, you okay? How are you doing?
Yeah, good.
We also need water.
See, BBC.
BBC, lovely to see you. How are you doing?
Sure, one of the marathon teachers.
One of the teachers that is currently teaching live. I'm not sure where the other teacher has run off to at the moment.
Oh, he's gone to the hall to do an assembly.
Right.
With a group of children, so he'll be back as soon as he can.
Fabulous. That's great news. Wonderful. Brilliant. Okay. So what we're doing at the moment is we are looking at the kind of things that would make a seed grow. So we would have water. Now, if it's a garden plant or if it's a plant at home, what you may need to do is you may need to give it the water yourself. So you may use a watering can, or you may use a hose pipe if it's out in the garden. Either way, it needs a source of water. If you put that in the chat, we'll see if anybody's answered. Oh, Ms. Keeling, what does it smell like? Ooh, I'm guessing vinegar. Oh, lots and lots of chats coming in. That's really, really nice. Keep that up. It's really good to have your company on the stream. Keep it up. those are the three main things. And wildflowers, the difference, I didn't see it in the chat, so I'm just going to explain it. The difference between wildflowers and garden flowers are that we plant garden flowers ourselves, and wildflowers just grow naturally in the natural environment. Now, a lot of wildflowers can actually be weeds, flowers that people don't want. Whereas other flowers, the ones that we plant in the garden, are generally the ones that we want. However, depends on your garden. Sometimes it can be overrun by plants you don't want. The three things that a plant needs, their basic needs, are sunlight, soil, and water. And this experiment tests which of these are the most important. And that is why you need 4 seeds. Because what you are going to do is you are going to control what those seeds get. So, seed number 1. We're going to take away everything from seed number 1 in this experiment. It is not going to get any water, it is not going to get any sunlight, and it is not going to get any soil. In fact, all we're going to do with seed number 1 is put it in a very dark place with nothing. Seed number 2 is only going to get water. It's going to go onto a cotton ball, so you'll need a cotton bud or a cotton ball for this experiment. The cotton ball is going to be damp, and the seed is going to rest on that. So the second seed is going to have just water. The third seed. The third seed is going to have sunlight. So we are going to provide it sunlight. It will sit on a cotton bud, just like the others, cotton bud, and it will be placed into the sunlight, but there will be no water. So it will not be damp, like this one here. The final seed, we are going to provide it with soil. Now, the soil may be damp, so you might be providing it with water and with soil, but try and get some really dry soil if you can. So you're just providing it with that. And plant that seed into the soil. So we have one seed that has soil. We have one seed that has sunlight. We have one seed that has water. And we have one seed that has nothing. Now, if you want to be adventurous and if you want to plant even more seeds, I recognize some of you. Some children who've just turned up that I know. If you want to be more adventurous and you want to do more than the 4 seeds that I've done, you could do some combinations of things to see if they grow too. So you could do a 5th seed. And you could give that seed soil and water. So a damp soil to grow in. So that one would be soil and water. You could do another seed which has sunlight and water. You could do another seed that has soil and sunlight. And you could do a final seed that has sunlight, soil, and water. And here's what you are measuring. You are measuring which seed germinates first. And by germinate, what I mean is the plant starts to exit the seed and begins to grow. So we should see a little green shoot coming out of that seed as that plant germinates. Which one of these will germinate first? That might surprise you, actually. Especially in the soil, you might need to dig into that to have a look at it. And it might surprise you. It might not be the seed that has everything. Once you've measured which germinates first, leave the seeds for about 3 or 4 days. And then check on them and observe, because observing is part of science, observe and record the difference between the seeds. I don't think this one here will be particularly shocking what you find. But you might find some things happen, and I certainly have when I've done this experiment before. You might find that some things happen that you don't expect. Right, that is the experiment, and this is really, really terrible at rubbing out what's on the board. That is the experiment. I'll use this one then instead. And this is the write-up. So we start our experiment by writing an hypothesis. And since I have some children here with me, which is great, I'll ask them directly. A hypothesis is a prediction, right? You're saying what is going to happen. What's the theory, yeah? I have put these seeds and I've rubbed them out, which is probably not a good thing to do since now I'm asking you about it. But I've given these seeds different things. So one I've given them nothing. The other I've given water, one sunlight, one soil and water, one sunlight and water, sunlight and soil, and then one everything. So the three things a plant needs: water, sunlight, and soil to grow. So if you were going to make a prediction about these plants, and you know that to sustain a plant, it needs the nutrients from the soil, it needs the sunlight for the energy, and it needs, on top of that, the water to drink, yeah? So all things that live need water. Which, out of all of these, do you predict will be the strongest plant and why? What do you think? Hands up. Anyone? Yeah, go ahead.
Sunlight and soil.
You think?
Sunlight and soil.
The sunlight and soil. So you don't think it needs water. So what you would say there, this would be your hypothesis, and it's absolutely fine to use that as your hypothesis if that's what you believe. Your hypothesis would be, I predict that the plant with sunlight and soil will grow the strongest. Does anyone have a different prediction that they would like to make? Go ahead. Yeah?
The one with sunlight, soil, and water.
Why do you think that?
Because it probably grow the most because it also has water.
Okay, so what does it have then if it has water, sunlight, and soil? It has... Can anyone give me the justification for that? So we've got, which is great, but now we just need to justify it, yeah? You're almost there. Go ahead.
Has the correct nutrients?
It does. It absolutely has that from there. But what does it have in total?
It has everything.
It has everything it needs to grow, doesn't it? Yeah. So you believe, and you predict rather than believe. I predict, so we're going to test. It's not about belief. I predict the seed with soil, sunlight, and water will grow the strongest. I predict that because, and there's the justification element that goes into our hypothesis, otherwise it is just a guess. I predict that it will require sunlight, water, and soil because those are the three things I know a plant needs to grow and to be sustained. Wonderful. That would be our hypothesis done. Right, you guys help me. I'm writing up a scientific report, yeah? I've done my hypothesis. What do I add next? What comes next after the hypothesis? Come on, Harris.
The observation.
Maybe, but how would I do that? If I'm drawing something, what would I call it?
Oh.
We did it on here anyway.
A diagram.
Lovely. So the next part after the hypothesis is a diagram. And the diagram will be affected based on how you do this experiment at home. If you've used 4 seeds, you would draw those 4 seeds. Now, it doesn't have to be artistic. It doesn't have to be pretty, but it just needs to be clear. Squares with a little circle in the middle and then labeled what the seed is and what the seed has. So like the first one here, you would draw it. You would say it's a cress seed and you would say that it has nothing. The second one, you would say that it has water. The third one, you would say it has sunlight. The fourth one, you would say it has soil. You draw each element of the diagram like so, and you label it. Cress seed, no sun, soil, or water. Okay, guys, we've got our hypothesis. We've got an incomplete diagram, but we've got a diagram started, and the people at home who are writing along with this can start writing their diagram too. Thank you for helping so far. So we've got hypothesis, we've got diagram. What comes after our diagram then? The next bit, the person who's picking up your scientific report, because this is your scientific report, what's the next person got to have so that they can repeat what you've done? What do they need? Go on.
Instructions.
They do, but it's got a special scientific name when we write those instructions in a scientific report. Can anybody tell me? It's the same name that you would give to a recipe. And later on, if you're watching on the stream, we're going to be cooking. We're going to be cooking, and I'm going to be eating because I like to eat. So, does anybody know what it would be? It's not instructions. I'll give you a clue. It begins with
Method.
Hey, we got it. There we go. Well done. So the next one would be method. And methods have to be very, very clear. It doesn't have to use really amazing language. It has to use scientific language, but it doesn't have to use, your typical descriptive language like you'd put in a really good story, for example. What it does need is imperative verbs. Come on, year 3 level that is. Who can tell me what an imperative verb is? Yes.
It's a commanding word.
It's a commanding word. So what is a commanding word? What do you mean?
Like.
Oh, yeah, come on, finish off your idea.
This.
Huh? Like do this, it tells you what to do,
You
yeah?
have these people on. These are all allowed to be videoed if you want. Look at that. We can see this audience that we've got.
Oh, there we go, yeah. In fact, we haven't even introduced them yet because I wasn't aware that we would. So maybe we do introduce. So do you want to, we'll just go across and we'll say each of your names, yeah, to the camera. Just your first name. First name, not second. So off we go. Yusuf.
Mohammed. Samuel. Haris. Darren.
Ahmed. Atik.
Right, and I know that some of you had a really good teacher in year 2, didn't you?
Yeah.
Yeah.
That's you.
Better one in year 3.
No. I mean, it was downhill, wasn't it? Because honestly, you had a really good education up to year 2, then you had year 3, and then after that it got good again. That's about right, isn't it? Yeah. Okay. There we go, Mr. Jordan. That's that. Anyway.
Having 3 and 4. So.
Oh right, sorry. I'm really sorry to hear that. But year 1 and 2 was good, right?
Yeah.
Year 5 and 6 was pretty good.
Yeah.
About 3 and 4.
Best. The most.
Best.
The worst job of all time.
There we are. I'm afraid, Mr.
No, I
Jordan.
say year 5.
Do you want me to just finish this up because I'm very close to finishing off?
You're close to finishing.
I'm close to finishing. Yeah.
It'd be good if you finish that up then.
All right.
Maybe I'll just have a little word with these guys just outside for a second.
Oh, sure. I can finish off myself. Yeah.
You finish off yourself. I'll just talk to these guys.
Fabulous. Say bye, everyone.
You're coming back in.
Say hi again when you come back in.
Okay.
Back to me. All right. So we got help from the year 6s. Well done to the year 6s. And they told us that what we need is imperative language. We need imperative verbs. So we do need imperative verbs for our method. And we usually use numbers or bullet points when we list these instructions. So method is the steps it takes to get this ready. Now, I did forget, there is one other thing that you could list on here that we didn't actually put in, and that's the equipment list. So you might want to add the equipment that you need. And for this, you need, as I say, 4 cress seeds. You need at least 4 cress seeds. You need cotton wool, and then you need water, sunlight, and soil. And a dark place to put the seed. But you can't really get a dark place. You have to take it to a dark place. So you might not put a dark place on your equipment list. Anyway, equipment list generally is bullet pointed or as a list after a colon. But method is usually numbered or bullet pointed and includes imperative language. Now, I'm not going to write the full method for this because that's something for you to do at home. You're going to write a method for how to do this experiment, but it would be along the lines of get 4 cress seeds. Very clear, yeah? Imperative language at the start, get that bossy verb at the beginning. Place, number 2, place 1 of the cress seeds in a dark place and do not give it any sunlight, any water, and do not plant it in soil. That's number 2. 3, take another cress seed, place it on a damp piece of cotton wool, and place it also in the dark place. So that is not getting sunlight because it's in that dark place. It's not getting soil. And then you would repeat that for every cress seed that you do. And once you've done the cress seeds, you would talk about what to do
when to check it, how to measure it at the end.
Hi.
Hi, you're back.
It's always
Fabulous.
so high. Right, I'm just going to set everybody up.
So that would be the method. You explain exactly what you do and how you check what you do. Once you've done your hypothesis, your equipment list, your diagram, and your method, you would move on from that point and you would do your results. So here, you have to wait. So you check to see which one is germinated first. It might take 24 to 48 hours, but you would look and you would check them regularly. I would say every 1 to 2 hours, check if those seeds have germinated. Are you getting ready to start slicing up a heart?
Getting ready, sir, to start slicing hearts. That is exactly what we're doing. We're not interrupting your lesson too much.
No, absolutely not. I'm just preparing myself for what is to come.
Now, Mr. Keeling, I am sure you are all aware, because he's been very scared about this all day. You don't
like the hearts.
With a man with such a massive heart as yourself, I'm surprised that it's such a concern.
It is interesting.
So what we're going to do is, sir, if you can help me as well with this. So because this is the heart dissection, we're going to need some real nice close-ups of the hearts. The children are going to be leading this as much as possible, because Mr. Keeling is absolutely terrified of hearts, and I have a limited.
No. I'm not terrified of hearts.
You're scared of hearts.
I'm terrified of fainting at the sight of a heart.
Right. So we're going to move that one into the front of it, so we can both have the thing. I'll help you. Help me just do this now, sir.
Absolutely.
We're going to move this over here. The opportunity. So I'm going to get the opportunity to get the camera on, and I'm going to move these. It should. Oh, really? That's annoying. Hello, miss.
So anyway, as I was saying, back to the results for now. When you have left the seeds for 24 to 48 hours, checking on those seeds for about every 1 to 2 hours, you should be able to tell me which one has germinated first. Once the seeds are germinated, you can record your first result and you can say which seed out of the ones that we have planned have germinated. At that point, you can keep checking on those seeds every 1 to 2 hours for the next few days. However, the end result, you don't need to be quite as observant with, because you can leave it for 4 days after those initial days and those initial germinations where you've recorded those initial results, and you can then go and just look at the difference between the seeds after about 4 days, 5 days, a week. Now, I'm not going to tell you exactly what happens, because that's part of the surprise. That's part of doing it, isn't it? So go to those seeds and check the results at the end. That is where you record them in the results section. Finally, the last thing that I want you to do after you've done your hypothesis, which is, boys, a prediction. And what does a prediction need?
A justification.
A justification, because if not, it's just a guess, isn't it? Once you've done your hypothesis, once you have done your diagram, which is, what's the diagram? Harris?
A labeled photo of what you're going to write.
Yeah, it's a picture, isn't it? And it's clear and it's labeled. It doesn't need to be art, but it clearly shows what has happened in your experiment. Then, my method, what was that again? Method? Remind me?
Instructions.
Lovely. A list of instructions, bullet pointed or numbered. Equipment list. Can you remind me what that is, please? Equipment list.
It tells you what you need.
Absolutely. Well done, Harris. You're doing really well at this. So it tells you exactly what you need, the equipment that you need to do. And then results is where we record what has happened. The final thing then, once you've done all of that in your write-up, and I hope you're getting this at home because I'd love to see some of these after the event as well. Once you've done all of this, you need to do an evaluation. Boys, do you know what an evaluation is? What do you do in an evaluation, in a science evaluation? Go on, Ahmed.
You see the results and look at your prediction.
So you see the results, you look at your prediction, and you say there whether you were right or wrong. That's the first point. That's the first thing that we do. So we look at them, and I said, for example, here I said, oh, the seed that doesn't have water, sunlight, and soil will be the one that doesn't germinate and doesn't grow. And I believe that because it doesn't have any of the requirements for germination or for life. And then once I've done that, I would explain why I was right or why I was wrong. Good. That's the evaluation part. But it's broken into two sections, because then what I need to do is I have to evaluate the test that I did. So the final thing you do is you look at how you can change that test to make sure you've covered fairness and validity. Now, the problem with my test is that I've only used cress seeds. And there might be some seeds out there that don't require as much sunlight. There might be some seeds out there that don't require as much water. There might be some seeds out there that don't require anything to germinate. I don't know if that's strictly true, so I don't want to misinform you, but there may be seeds out there. I can't say that with 100% certainty, and the reason that I can't say that is because I haven't tested. And remember, science is all about testing. It doesn't matter if you're right or wrong in the end. It's whether or not you have proven it. And just be honest. In your evaluation, if you're still sure and you can't tell a difference, that is also a result. As long as somebody else can pick up your experiment, take it, do that experiment, and either replicate your results or get a new set of results using your original test, then that is fine. So give it a go, write out your results, and I would love to see what has happened. And if you have got cress seeds at home right now, on the off chance you've got cress seeds, try it right now. And before the end of our experiment today, our Teach-A-Thon today, could you get in touch with us and tell us if any of them have germinated? Because I would really, really love to write up those results and that evaluation live.
Right, so you have been doing an absolutely fantastic job. We've got Kahlid Mahmood, who's still over in the school.
Wonderful.
Talking with the children, which is really kind of him.
That is very kind.
So,
there's a bag of hearts over there.
There is a bag of hearts over there. Now, as you can see, there is a whole bag of halal lamb hearts over here, which, to be honest, the year 6 are going to be the ones who tell us a little bit about it. So, guys, would you mind coming around this way? I'm going to get you to come and introduce. Now, I'm going to first of all get you to come and say your first name, not second name, if that's all right. You're going to move yourself just a bit over here. That's really good. So will you just check that they're all in the right spot?
So, mate. It's incredible. I haven't seen some of these children since year 2. I taught some of these in year 2.
Oh, amazing.
It's amazing to see them.
Right. Can I
They've
take
grown
your first
so
name?
much.
What's your name?
Ahmed.
Ahmed. Mahayman. Atik.
Harris.
Harris.
Samuel.
Yusuf. Brilliant. And they are going to be our scientists who are going to be leading this experiment today. Now, before we start this science experiment, I noticed you've got some pretty trendy gear on.
Whoa.
You all coming in like fancy dress today, or what's going on? What is this? Who would like to tell me what you're wearing? Yeah, Samuel.
We're wearing football kits because today is the start of the Euros.
Well, that's true. Number 1, we're wearing football kits. Everyone say, "Come on, England!"
Come on,
Come on, England!
Excellent. Number 2, you've got these beautiful little things as well. And what might be the purpose of wearing something like this? Yes, Atin.
Hygiene, because when we dissect the hearts, we don't want blood all over our
I
clothes.
love that. Hygiene is so important in this. So we are wearing both these rubber gloves. They're going to keep our hands protected from everything. And you've also got, my hands are incredibly sweaty at the moment, so I'm struggling to get through those. And also, you've got these lovely aprons, which are going to keep protected. Now, guys, you've been learning a bit about the heart. Before we get the hearts out, what's the heart exactly? That's like a feeling, isn't it?
Yes, it's an emotion.
It is an emotion. I've sent it on my mobile phone.
It's
before.
love.
Yeah.
Heart means love.
Is that right?
No.
Who would like to chip in a little bit on that? Yes. It's an organ.
Oh, like big piano with pipes.
No.
No?
Like just kind of. No, like your inside.
Oh, organs that are like inside your body. So like your stomach, your liver, your kidneys.
Mahayman, you want to tell us a little bit on the Mahayman, are you going to tell us a little bit about organs? What can you tell me?
Organs are crucial for your body and they help do stuff for your body as well.
Fantastic. So
Can I have that answer again, please?
Yes,
Yes, certainly. Nice and loud for me. What do organs do for us?
Well, so who answered that? Put your hand up.
Hello.
Was it you? Oh, jolly good. So don't look at me.
Just looking at the camera over there. Hey, so
Or if you look at the teacher.
look at the teacher. Hey, so what are organs?
they can do so many things. Like the heart does. The heart's job is to pump blood around the body.
That's fantastic. Do you know any other organs, guys? Because I know I'm an organism. I'm a collection of organs. And when all my organs are working properly, I as an organism can function. So what other organs do we have in our body? Yes, Darryl.
Your liver.
My liver, fantastic. What else have we got, Samuel?
Your brain.
Your brain is, wow, that's pretty much who you are, isn't it? Yes,
Your
Harris.
stomach.
Your stomach. Do you know what? Earlier on this morning, we were doing all about digestion. weren't
We were, so
And
we've
got
been
whole
through the
digestion
body once already, I believe, haven't we?
system. And the gallbladder also.
Gallbladder.
Right, guys, so
Small
just,
intestines.
would you tell us a little bit specifically then about the heart? What do you know about the heart? What can you tell us? Yes,
The
Harry.
heart is split into 4 chambers: the left atrium, the right atrium, the left ventricle, and the right ventricle.
Wow, that is amazing, Harris. Great answer.
So, are there any more questions, things that we can find out about the
What
heart?
else do we know about the
Sorry,
heart?
could I have that answer again?
Yeah, absolutely. Harris, do you want to
Hang
give
on,
that
hang
answer?
on. Let me. Don't look at me. Don't look at the camera. So if you look at the teacher over there. Hang on. Okay. Don't look at me.
What are the 4 parts of the heart, Harris?
So tell your teacher what. So what do you know about the heart? Tell your
The
teacher.
heart is split into 4 chambers: the left ventricle, the right ventricle, the right atrium, and the left atrium.
And if Sir can just be here and say that's amazing, very well done.
Wow, that's an amazing
Hang on,
piece of
I've got to be ready. I don't work that quickly. Okay,
Wow, that's an amazing piece of information. Thank you.
a bit more enthusiasm.
That is an amazing piece of information. Thank you so much for that. You know so much about the heart. I'm so impressed. Right, now I have lost a glove in the process of doing this, but what we have got inside here, these are our hearts, and we can see some up on the live stream. So guys, I think what would be nice, so if you can angle it, you're going to help me a little bit.
I'm going to get closer to the hearts, am I?
Darren, if you can come over here, just can you go on this side, please? Go around.
I don't know if you noticed, I've been keeping my distance.
Perfect.
Uh,
One there.
What's that, sorry?
If Samuel.
No
you can
fame.
come down.
Thanks, boys.
Thank you, Harris. Can you come
Thank
to the end over there?
Good advice
Great.
from the children
You
there.
guys are in here. So I'm going to place. We've got some different lovely halal lamb hearts that we've got over
Oh
here.
my goodness.
So I'm going to place these down here. Now, guys, maybe just before, and I don't mind if you touch them because you know exactly what to do with them. What can you tell me, or Sarah, about these hearts, just whilst I'm going and getting some scalpels for you? What kind of things can you tell me about the hearts, guys?
This one has the trachea on.
That's the trachea.
What is the trachea? Can you tell us that?
This one. It's called the windpipe.
Right, and what does it do?
It supplies oxygen to the lungs.
Oh wow, fantastic. Can anybody tell me anything else about the heart? Why is
I knew
this?
this
Why
was
is this
mine.
part darker and this
There
part lighter? Do you know that?
This has more muscle on it.
Ah, the
Oh,
muscle.
fabulous! So muscle around the heart. So what's the other part then, if not muscle?
That's just fat.
Fat. So we do have fat buildup around our heart. We have the muscle. And what you said earlier that the heart pumps. So what kind of motion does that be making, and what does it do when it does pump?
This is the left ventricle.
Okay.
So it needs more muscle because it needs to squeeze out towards the body.
Fantastic. Anybody else know any facts about hearts while we're holding them? Yeah.
This is
The reason why the heart is red is because of the hemoglobin.
And what's hemoglobin?
It's
chemical.
It's a chemical.
Okay. What kind of chemical is it?
Oh, fantastic. Do you know what, sir? We were talking about hemoglobin
Yeah,
this
I think
morning,
we
weren't
were.
we?
Really?
Because we were talking about the carbon dioxide and carbon monoxide, and we were talking about why carbon monoxide is such a dangerous gas. Were there any reasons why carbon monoxide is so? Well, it interferes with that hemoglobin, and it stops the oxygen from transferring around our bodies properly. Now, guys, over here, I have scalpels. Absolutely very exciting, very dangerous scalpels. Now, if very carefully you would like to take yourself, now remember, not holding the blade, I'm going to hand these around. There you go, there's your scalpel over there. Take your scalpels over here, here's your scalpel, lovely. I'm going to keep handing these around.
Yes,
Is it okay? Is it okay if blood goes on?
Yeah, it's fine.
Yeah,
If it goes on, I
absolutely.
think
You
it's
get
gonna
these as
go
messy
on
as
both
possible.
ends
We're not
anyway,
going to
isn't
save
it?
these afterwards anyway, don't worry about that. Okay,
These are
lovely.
one-time use.
These are one-time use scalpels, which I know is not very good for the environment. We're all about protecting the environment, aren't we, Atik?
Yes.
But hey, what can you do? Sometimes science is more important. Okay.
So what are we going to be doing with these scalpels? So?
Well, I think because so one thing I would just say, just so we can get the vision on the live bit, we just need to make sure maybe you're on the other side, and then we've got that. Bit
Okay.
Right.
Oh, yeah, 'cause they can
So,
see
guys,
it,
would you like to show me? You've done this before. So we're going to cut into the heart so that we can have a little look. And what I want to be seeing inside, you were talking about those different chambers inside the heart. So
do you think we can make an incision, a small cut into the heart, and we can try and find where those different chambers are? That's one of the first things that we're going to be doing. It's really good. Well, I'm not quite sure. I'll have a little look. Because you guys were the ones who did this before, so maybe you can tell me.
You're doing an amazing job, guys. You're so
careful,
good, careful, and you've been so brave. Not squeamish at all. You're not.
Mr. Keeling, you're getting a little bit scared over there, right?
I'm not. I'm doing okay, sir. I'm having a look.
Now,
I'm interested to see what's
wow.
inside the heart once it's been
So you're going to have to
opened.
cut in a little bit harder into the heart. Now, I've got one that's been opened up. We can maybe show that onto the
Oh wow,
screen.
yeah.
You can see inside that heart, you can see the different chambers. Now, I know that the blood, it pumps into the heart, doesn't it? Is it the oxygenated blood or the deoxygenated blood, or is it both that's going into the heart? Both. It is both, isn't it? So deoxygenated blood is being pumped back into the lungs as well. What's happening in the lungs, Harris?
The reason that the lungs is so important for our body is because it oxygenates our blood.
Absolutely. So as the blood gets pumped into our lungs, you're totally right. The oxygen is so important for our body. The hemoglobin is picking up on that oxygen, isn't it?
Yeah.
And then what happens after the lungs? Can anyone else tell me? So it's being pumped into the heart, the lungs. Sorry. Can anyone else tell me what happens after that?
It collects oxygen.
So it's collecting oxygen into the lungs, and then is it ready to go?
Yeah.
Is it, or does it go back into the heart?
It goes back into the heart.
Brilliant. So this is just one massive muscle that is constantly working, constantly pumping. Now, should we show a little bit of this, maybe on the screen behind? And look, we can see inside, a little bit tricky to see, but we can see there is a way in. If we look on that, there it is. So we can see this is one of the places where the blood is going to come in, and it gets taken into one of these chambers, just over here. And then what will happen is that as it squeezes again, can you feel my fingers coming through here? Can you see that? So it's going to squeeze its way in, and look what happens with my finger. Whoop, I pop into that little area here. And then as it squeezes again, it's going to whoop, pop out through this at the top. Can you see that? Guys, what are these big holes at the top called? Attic, what are these big holes at the top called?
The aorta.
The aorta, brilliant. Now, Attic, this is really interesting. What have you found here? What's this?
Well, I think it's muscle covered in blood.
It looks like it could be. It looks like, if I get that onto the screen,
I've never seen so.
it looks like a little bit of congealed blood there.
Yeah, it looks like it's clotted. So sometimes when you have a wound, to stem the blood or to stop the blood will clot so that you don't lose any more. That looks to me like that blood's clotted.
Yeah.
So that is just a piece of blood there.
Oh, wow. Well, what on earth would blood be doing in the heart? How blood in the heart?
Going up and down.
Going up and down, that's the place for it. Look at that. You're totally involved in the conversation. That's really good.
So what would happen if the heart stops pumping, guys? Why?
Because there's no blood.
So would it be that there would be no blood in your body, or would it be something within the blood that's not getting around to your
It's
organs?
not getting around.
So you wouldn't have that oxygen that's traveling through your blood to the other major organs, really. Would
Now,
you?
tell me something about the heart, because I know this is one thick muscle here, and I know that it's squeezing because I can see as my finger goes in, it's going to form into here, it's going to push out, and once again, you can see there's another hole that goes in. And actually, if you can feel, I see my hand's got this. Can you show that on the camera? So if you put your finger back into there, you've got. He's showing the route that the blood is going to take. His finger goes straight in. Can you see if I put it over there? That is where the blood would go out. There is one chamber here. If you can hold that open, there's a second chamber here where the blood is going to go into. And if you see again, it's going to come out down there. Now, Mr. Keeling and I, later on, we're going to be doing some exercises.
Yes, we are.
Now, the heart is pretty steady. It beats at a constant rate. Am I correct?
Yeah.
Constant rate all the time. Or is there a time when the heart might start to increase its rate?
There is a time when it will increase.
Attic, would you like to talk to me about what might cause my heart to get a little bit excited?
Well, the more we move, the more blood we need to get pumped around.
That's true.
Because we're
You okay?
breathing in more air.
That's okay. That's a really good thing to do. It happens. Love this. This is science in action. Can you see yourself down? Good lad. Well done. Good. You're just like Mr. Keeling's doing there, which is absolutely no problem whatsoever.
Like I said.
So keep telling me. I get a little bit excited. I love that. One man down. You know this is going to be a good experiment if that happens. Whoa! Look at that big lump of blood that you've got coming out of there. That's amazing. Can you get that under here on the screen so maybe the people on the live stream can see that? Look at that. That looks like a big sort of plot. Can you pull that out as well? Is that any way of removing it?
Maybe the lamb died because of it.
You reckon?
If the blood was too big, it
Just some cups there.
can stop blood.
Just getting a cup of water.
Don't rip it.
Have we got a first aider on site?
It's cool.
Who's the closest first aider? Me, really. You're a first aider. Have you got any other first aiders on site?
It's
quite hot in here.
Oh, it's a lot. That one is like a big. I think it's just squeeze it out. I think a whole chamber just has I think this is one of the chambers. I think this is one of the chambers. One of the chambers is coming.
So again, there's here larger blood clots in there as well. So that again, just like we saw before, is just a large piece of congealed blood that's solidified. We can see quite large. Do you want to collect that to the side so we can keep the congealed blood that we found within the heart? Is there anything else that you can tell me about what goes on with the other organs? What organs require that oxygen that it passes it around to?
Do you think this is the reason why the lamp died? Is there too much clot to let?
Well, actually, that's a really important point. Perhaps the fact that there has been a clot and that we found a clot in the heart could have blocked the heart, because that just happened, doesn't it? Blood just clot, and that can cause the heart to stop through the blockage of the clot. That's a really good idea. What organs does it feed oxygen to, though, the heart? What's our major organs that need that oxygen? Everything. So could you go through them? Anything that needs oxygen in our body to function? Our eyes, yeah, our brain. What else? Liver, stomach, kidney. Fabulous. Arms, legs, limbs. And I'm seeing that actually the heart, they're inside, the colour of the heart is very similar to the kind of muscly outside or the outer layer that we saw. Is that because the heart is mainly muscle then? Well, that's probably because of the blood that's been pumping through and the congealed blood that's inside. But if we have a look inside, it does have this kind of darker tinge to the walls. And I think that's because it being a pump, the key function of it is that it keeps pumping. And to do that, it needs to be strong and it needs to be a muscle, doesn't it? Yeah. So I think what we're seeing here, a lot of it, is muscles, the tissue inside. How would you describe it? What does it feel like? What is it? Like jelly. So the congealed blood looks like jelly. So what about the heart itself? What does that feel like? Hard. How hard was it to cut through? Was it tough? Was it easy?
Some parts are tough. Some parts are.
Which parts were harder, do you think? So you think the fatty white bits on the outside were the harder bits to cut? And so what, the muscle was easier to tear into, was it? Wow. That is absolutely great, guys. So you told me about the 4 different areas, 4 different chambers of the body. Do you know what they're for?
The 4 chambers. They all have a different key role.
Okay, so could you tell me a couple of the key roles for them, please? How you feeling? I want you to say, just sit down for now. Okay, we'll just keep them up. Yeah? Just rest and stay by the air, right? What are the 4 key areas then, boys? Okay, so valves, that's pumping blood in and out of the heart. But what about the 4 chambers? Do you know their key roles?
All 4 parts of the heart. And they all have a different role. One part,
Yeah.
I'm pretty sure, has an area for the oxygen to go through. So it's called.
Fabulous. Well, boys, should we put the hearts to one side for now? I think we've had a real good look at inside the inner workings of the hearts there. So if we could put them all into one tray for now, and we all gather just carefully picking up the congealed blood, the blood clots, and put those into there as well. And then if you could very carefully just pick up the knives without the blade, let's put those into the box as well over here, please. Absolutely fantastic. Okay, boys, leave the gloves on for now because we don't want to get the blood all over your hands. And we're going to just come and stand back over here. Thank you. And we're going to just talk about what we found, how it felt like, and what it was like to look inside those hearts and be a part of this. So, when you did this with your class, because you've done this in the classes before, haven't you?
Yeah.
Turning this way. Thank you so much for that. Oh, to me. So, children, what were you looking for when you did this in class the first time? Because obviously we've just had a little look around and that was really good. And you've told me lots of stuff that I didn't know about the heart. But when you were doing it as part of your class, as part of your lesson, what were you looking for? Why did you do this initially? Give me some answers. Harris, what do you think?
We were looking to see the main part of the shape.
You were trying to see what it actually looked like inside the heart. Anything else that you were looking for?
We wanted to find the chambers.
You wanted to see the chambers for yourself, yeah. Because sometimes observing and looking is part of science, which is a wonderful thing. One thing I do want to know, and this is really important, why is it important, do you think, to actually do this? Not to learn the theory, not to see a picture on the board, because I'll be honest with you, when I was a child, I didn't do this at school. I never got the chance to do it. Why do you think it's important to have these real experiences? What do you think? Yeah, go ahead.
If we ever have a career like being a doctor, we could have a little more experience to give us a head start.
Absolutely, that's a really good idea. Anything else?
Do you think there might be somebody who's like just thinking, oh, I don't know what I want to do in my life, and I'm not that interested, and then suddenly a moment like this can spark some kind of curiosity? Because this could lead to all sorts of things. Does this just mean you're going to be a doctor if you know about this kind of science?
No.
So what kind of things could this lead to? I think you could do all sorts of things. You could be a scientist. You could be
Biologist.
you sure could. A biologist, all sorts of things, chemistry, science. So actually having that hands-on opportunity makes the world a difference, doesn't it?
Even if it is a little bit gross and a little bit scary.
Even if it is. And so you did really well.
I did very well. I think I was very brave. I think, what do you think? A round of applause for me?
Yeah. Well done. Oh, let's just spray that blood everywhere. That's brilliant. Really
Gross.
Right.
Okay,
what I'd like
guys.
to do, guys, can you take your gloves off into that sink? Can you just leave them in the sink for me over there, please? So don't take them off until you get over
And
to that
I
sink.
think so. While you're getting them ready on the live stream, I'm just going to go into another story about another scientist for our fact find. Okay. Right, guys. If you're watching live on the stream and you've been watching along, well done for making it through that section where we saw those hearts being dissected. Now we are going to learn a little bit more about a scientist again. The scientist that we learned about before was Albert Einstein. But we're going to learn a little bit more about a man named Alan Turing now. So I'm going to read this book. It's again another one of our little people, big dream story. And again, it's a wonderful book with beautiful illustrations telling us about really important things from the past. So I'm going to read the blurb and then I'm going to get into the main story. If earlier you were doing your piece of work around a fact file and you were collecting all those facts about Albert Einstein, now is the time to write a new subheading, Alan Turing, underline it and get ready to collect some more notes. We'll pause throughout and we'll talk about what we learn. But I want you bullet pointing, collecting this in your own words. We'll start with the blurb. Discover the lives of outstanding people, from designers to artists to scientists. All of them achieved incredible things, yet each began life as a child with a dream. As a young boy, Alan fell in love with science. In everyday life, at school, he went on to conduct his own chemistry experiments. And by the time he was at university, Alan began to invent ways to change the world with human-built machines that could outwit people. So making machines that were smarter than human beings. Sounds amazing, right? I think today, we've modern day version of that is actually we've got AI, haven't we? We just started to dream up things that we can't even think of anymore. This inspiring story of the mathematician, code breaker, and scientist features, thank you so much, a facts and photos section at the back of the book.
story, shall we? Little People, Big Dreams, Alan Turing. Here we are. Platform 1. So I think we're at a train station. Little Alan was a boy from London who went to boarding school when he was very young. He was shy and nobody expected much from him. But often, the quietest people achieve the most extraordinary things. At school, Alan spent so much time alone that he learned to read by himself. He could also solve mathematical problems in his head before his teachers taught him how. Fantastic. So not only has he taught himself how to read, he also can do really complicated maths equations before even learning them. That'll be important later. This is reminiscent, actually, this tree here, of the tree with Sir Isaac Newton and the apples. Everything changed when Alan met Christopher. They both shared a passion for maths and science and planned to study at Cambridge University together. Alan just couldn't imagine life without his friend. He had fallen in love. He was ready to move to Cambridge when he got some terrible news. Christopher had died suddenly. Alan, who had always been lonely, felt more alone than ever. So, key facts there about Alan Turing's life so far. Alan Turing taught himself how to read. How incredible was that? He taught himself how to do rudimentary maths and built on that himself. He made a connection with a child named Christopher in school, who sadly passed away, leaving Alan lonely. University couldn't cure his broken heart, but it kept his brain busy. Soon, Alan was working on a crazy idea, a machine that could calculate any sum. Alan's design was the ancestor of the computers. So modern day computing, Alan Turing was one of the first pioneering people that designed not modern day computers, but the earliest form, the fathers or the ancestors of computers that we use today. But he didn't have the chance to build it. Half of Europe had been invaded by Germany. Now that links, doesn't it? Because when we were learning about Albert Einstein, we found out that part of his life fell within World War II. It's the same for Alan Turing. So a big, major changing point in their life was World War II. And Alan's destiny was about to change forever. When Britain joined the war against Germany, Alan and other brilliant minds were hired to break the code used by the Germans to send secret messages to their soldiers. And that code was called the Enigma code. So let's just pause there a second again and have a chat about what else we've learned. So we learned that Alan was trying to create a machine that could calculate any sum. I wonder what we would call that now. A calculator, perhaps. Then his idea was paused and his work was paused because of the war with Germany. Alan joined the war and worked with other scientists to try and break the Enigma code. Mathematicians, chess players, engineers, they all failed to crack Enigma, the code-making machine built by the Nazis.
But Alan knew that another machine, not a human mind, was the only thing to beat it. So his initial idea was a calculator. But now he's thinking about how he could use maths and how he could use a machine to crack the Enigma code. Nobody believed in Alan's idea. So he wrote to the Prime Minister, asking for help to build his device. Once he got permission, it was just a matter of time before his machine solved the first of many riddles. And I think we're just going to pause that one there because I want to say,
something because I'm going to have to stay with these. We've got the children doing all sorts of amazing science interviews, so which is really exciting. They're out there talking to the BBC, interviewing. So one of us just needs to be available for that.
Yeah, I'm going to pause the book now because I want to save some of this work about different scientists for later, and I want to build up the fact file with Isaac Newton as well. But what I will do is I'll keep going through my PowerPoints that we have on the board.
Oh my gosh, I'm so excited for the
I am
PowerPoints.
going to go back into a lesson. We're going to go back to plants. So
brilliant.
we just move this.
Yep.
And once we've done that, we can go straight back into the next science lesson. So let's get that up. So we do a quick check of the chat just before you go.
Check in the chat. That'd be really good. Well, look, guys.
Okay. Thank you.
How exciting has this been?
I
We've
know,
been
right?
building up and up and up. We do have, excitingly, we've got some other. I think we've got some other children or something. I'm not quite sure what those are, but I'm really excited for whoever might be coming next. Later on, we've got another special guest who's going to be joining us. We've got another big experiment that we're going to be doing. We're going to be looking at teeth and enamel and all sorts of things like that, which I am super excited about. And I know, Mr. Keeling, you are incredibly excited about.
Always excited about it. So.
I mean, that was so exciting, wasn't it? We just had the BBC in here filming us doing things. I know it must have looked a little bit odd on the live stream because you've got us being filmed and then them filming them. But hey, that's great. That's what it's all about. Mr. Keeling's just going to feedback a little bit from the chat. What's it been saying?
It's mainly heart surgeons in the making. Well done to the children. Wonderful things going on.
Yeah. Oh, Mrs. Penn.
Mrs. Penn,
There we go. We've got
to hear.
Lovely Mrs.
from
Penn.
You.
Previous art teacher, maths teacher. One of the best. Thank you, Mrs. Penn. It's lovely to see
I
you.
can't seem to get this board clean, sir, when I've used it. It seems really, really difficult to get any of the things off. Which is, lots of lovely technical things that are going wrong.
Do you know what,
today.
sir? That's science, isn't it?
That is science. Science doesn't always go right, does it?
Sometimes science goes well, sometimes science doesn't go well. That's what it's all about. And that's really exciting. Okay.
But what I'm going to do is I'm going to talk through some more of my slides.
Brilliant.
And then, sir, you'll be back to take over and do a lesson soon, won't you?
Can't wait.
Fabulous. Okay, here we go. So, what we talked about first was creating an experiment. That's really the exciting part about plants. Now we're going to go in and we're going to talk a little bit more about the different parts of a plant, the year one knowledge, the seeds, and all of those kind of things too. So, starting off, seeds. What is a seed? A seed is basically, or a seed contains everything that a plant needs to grow. So a seed can start very, very small, but can actually grow very large. The saying from little acorns, mighty oaks grow, or something
How
like that.
large can a seed be, though, sir?
Oh, seeds can come in all shapes and sizes. They can be very, very small, from
Yeah.
a tiny little speck on your hand, and they can be as big as a coconut. Yeah.
Is a
Seeds-
coconut? I thought that was a nut.
I think a coconut a nut.
Is it a
Wow,
nut?
I don't know. Is it a legume?
Is it a legume, or is it just a seed?
Probably a seed because it washes down water, doesn't it? It's transported via water.
That is so
I believe.
true. Is that
So
why?
I believe it is a seed. Yeah.
Is that why you find coconuts like all over the world?
Probably. Yeah.
I'm always amazed by how it doesn't matter where you go, there's always a coconut.
Yeah. Everywhere.
I wonder what that's all about.
Well, you need them to make bounties.
That is a very good point. Bounties are one of my favourite chocolate bars. So.
I don't like them at all.
Did you know that bounties have coconut in them?
Great. How are seeds dispersed? So this is another idea about seeds. So the seeds move, and this is kind of what Mr. Jordan was just talking about there. Seeds move around the world in different ways. If a seed stayed where it was, well, that wouldn't be very good for the seed because if it fell where there were other plants, it wouldn't be able to grow. So it's very important that seeds can move around. The problem with seeds, obviously, though, is that seeds don't have legs. So if a seed fell from a plant, it's not like it could walk somewhere, find a lovely bit of soil or find some nice water, relax, and then start to grow. Seeds need certain conditions to move around. Now, One way that seeds might move is via the wind. So the wind blows, it might transport seeds to different places. And I'm not going to go into every way that a seed is dispersed because I'll talk about that a little bit later on. But one of my favorite ways that seeds are dispersed, and one of my favorite facts about how seeds are dispersed are, if we look inside a piece of fruit, the seeds are there in the middle. And when animals eat the fruit, because fruit is delicious, it's full of sugar, when animals eat the fruit, they will eat the seeds, and birds will eat seeds too. And the birds will fly off, and the animals will wander off too. And then, based on the digestive system, what goes in must come out. So the animals basically poop the seeds back out, and when they do poop those seeds back out, they are dispersed, they are in different places, they go into the ground, and then they can germinate, they can grow again. So what do seeds need to grow and become plants? Well, that was part of our experiment too. So the 3 things, can you remember? If you can, write it into the live chat now. I'm going to give you 5, 4, 3, 2, 1. What do seeds need to grow? Well, they need sunlight, they need water, and they need soil, or nutrients at least, from the soil. What is a plant? Well, let's have a look. Thumbs up, you can do this at home. Thumbs up if you think these are plants. Trees, what do you think? Yes or no? You can type yes or no into the chat, or you can just do a thumbs up or a thumbs down at home. Grass. Is grass a plant? What do you think? Thumbs up, thumbs down at home, or a yes or a no in the chat. Weeds. Are they a plant? Yes or no? Thumbs up, thumbs down in the chat. Mr. Keeling, am I a plant? Yes or no in the chat. Thumbs up, down at home. Well, let's check. Trees are plants. Well done if you agreed with that statement. Grass is a plant. One of the most resilient plants, actually. Grass is a very, very resilient plant because when you cut grass back, or if there was a fire, for example, grass will regrow in its place. Grass is one of the best surviving plants. That's why it's everywhere. That's why it covers our fields, because grass is a very tough, very resilient plant. And actually, when you cut grass, it even gives off a chemical signal to the rest of the grass around it, which indicates that it is being cut. So in a way, grass can send out a distress signal. Weeds, although weeds are unwanted, they are still a type of plant. The seeds are dispersed like the seeds of a dandelion. When the dandelion dies, the seeds are there on the outside. They're blown away in the wind. They're dispersed. They grow into new dandelions. And although dandelion is a weed, it is still a plant. Now, if we take dandelion, which is a weed, we know that dandelions have a flower. We know that daisies have a flower. We know that fruits have flowers. So can a plant have a flower? Well, the answer to that question is yes, absolutely, plants can have a flower. All right, moving on then to the different parts of a plant. Here we have a plant, and we have different parts to it. So year 1, here we have the flower, we have the stem, we have the leaf, and we have the roots. I'm going to say those more time for you at home. 4 parts of a plant that we learn in lower key stage 2, year 1 are the flower, the stem, the leaf, and the roots. Okay, I'm going to put the slide back one now, and I'm just going to give you a couple of minutes. Have a go with people at home. Have a go in the chat if you want to. Can you name for me the 4 parts of a plant? Off you go. You've got 30 seconds. Can you name the 4 parts of a
a plant.
So I'm going to keep an eye on the chat, making sure that people are contributing to this.
Fabulous, sir.
I'm having a look. So I've got the first comment that's come through, and it says you've got a really nice haircut.
Oh, that's wonderful. That's
Yeah.
really good to know.
That's really nice.
Lovely. I think that's the third time today.
That's the third
isn't it?
time today.
It's
Someone's
nice that
mentioned
they're
about it.
noticing that I've got the same nice
It is
hair.
really nice. We've got a message from do you know what? We've had 2 ex-Anglesey members of staff on the chat. So we've had
That's
Mr.
really
Kay.
lovely.
Mr. Singh has just got onto the chat
Mr.
as
Singh
well.
is on the chat
So I
as
know
well.
many of you at school will remember that. Mr. Singh is over in Hong Kong at the moment.
Wow.
Training in literacy. So that is absolutely fantastic. He's having a whale of a time. He's just got in the chat and he said he's got a question for you.
Sure.
Are you a plant?
Well, that was actually my question. So I said, am I a plant? And actually, you're right, Mr. Singh. I didn't clarify. I just assumed, and that's wrong, isn't it? I shouldn't just assume, because I said that a tree was a plant, grass was a plant, and that weeds were a plant. But then I didn't clarify if I was a plant. Now, as mentioned earlier, when we were talking about plants and animals, I am an animal. In fact, classified, I am a mammal. So although I do share commonalities with plants, because everything that is alive has certain commonalities, although I do share certain commonalities with plants, I am not a plant. I am an animal. And we'll look at the difference between living things and plants and animals a little bit later on. Now, did you know the 4 parts of the plant? Can we remember them? Let's see if I can too. We had the roots, we had the stem, we had the flower, and what was the last one? Oh yes, we had the leaves. 4 parts of the plant. Now, why do they have these parts? Well, let's work our way up from the bottom. We'll start down here with the roots. So here we can see that the seed has germinated, or maybe it's a bulb, or the bulb has germinated and created the plant. And from the initial seed, the initial starting point that's germinated, we can see that the roots have travelled out into the soil. What do you think those roots are searching for? Well, these roots are searching for water and nutrients that can be found in the soil. They're basically little straws sucking up everything that is good for a plant. Because we have a really interesting scientific fact for you. Here we go. I love this fact. Did you know that some trees, if you listen to them through a stethoscope, you can hear the trees sucking up water? That is absolutely right. You can hear trees drinking. How amazing is that? Also, as Sir was alluding to earlier, sometimes plants poison other plants for space. There's a whole political system between plants. It's truly fascinating. But the root's job is to search out through the soil, looking for nutrients and looking for water to keep that plant healthy. It also anchors that plant in place. So it holds it there in the soil.
So yeah, we're trying to get this out.
Next part.
Thanks to you guys.
I'm not going to go for the leaves next because the leaves have a very, very important job that I want to discuss later. I want to talk about the stem. So the stem is this long green part that runs up the middle of the plant. The stem holds the flower off of the ground, and we'll talk about why that flower needs to be held up in a moment. But it does. The job of the stem is to hold the flower off of the ground. The stem also passes water around the plant. So it takes the water that the root has taken up from the soil and passes it to other parts of the plant. So 2 important jobs for the stem. And I will test you on these at the end to see if we can remember the jobs. I'll go over them quickly one more time once I've tested you. So, roots, stem,
We've encouraged the children as much as possible.
leaves. Leaves are very interesting because we won't go into it here because this is year 1 learning, so we won't talk about the how, but leaves make food for the plant. Basically, water is transported to leaves, and leaves also collect sunlight. With these, the nutrients and the water and the sunlight inside of the leaves, there is a process that happens called, photosynthesis. And through photosynthesis is how the plants make their food. So leaves
have a vital job. And the problem is making that food in the leaves through the process of photosynthesis, it loses water. Water evaporates out of the leaves. And because it's constantly losing water, it needs to take in water again. So we've done our roots, we've done our leaves, we've done our stem. Flower. The flower's job is actually to reproduce, to make other flowers. How does it do that?
That's a really good question, sir. I'd love to know. How does it do that?
Oh, hello, sir.
Oh, hello, sir. We're going to teach you for a little bit.
Oh, fabulous. Yes. Well, why don't you explain? Because what I was just doing, I was going to give them a little mini test at the end there. But I've just explained to them that the roots go out, and this is year 1, year 2 learning. So we're not going thoroughly into the photosynthesis.
I can't wait to
yet.
do that later on, though.
No, that will be exciting, but we're not going there just yet. Right now, we're just talking year 1, year 2 level, and we're talking about how the roots search for nutrients and water, which we've explained. We've talked a little bit about how we've also talked about how the roots anchor the plant. We've talked about the stem and how the stem holds the flower off of the ground, which you're going to explain the importance of the flower in a moment. The stem holds the flower off of the ground, and it also transports water. And we've got some little discussion points about the transportation of water a little later too. But it transports water to the leaves and it transports water to the flower. Then I spoke a little bit about leaves, and we talked about how leaves collect the sunlight and collect the water to help in a process called photosynthesis.
Wow, what a complicated word.
It is a complicated
photosynthesis.
Photosynthesis, and actually, photo is on a lot of words like photograph because it relates to light. Photons.
That's really good.
in light.
I've heard of synthesis before as well.
Yeah, where have you heard that?
Well, I've heard that when things synthesize, that something comes together to produce something else.
Wow.
So would that have any link?
So light and producing something else, water, light coming together, producing something else, food. I think that word actually suits its purpose, don't you?
Oh my goodness, how
Wonderful.
interesting.
So that's the job of the leaves. And then I was just about to go on to the job of the flower. But would you like to talk to the audience and tell them what the job of the flower is before we ask them again what the jobs
we're
are?
gonna stay together just for a second
We are.
until you go off.
Sure.
So, yes, I would love to talk a little bit about that. Maybe we can talk about that
Why are we
together.
dancing?
Yeah, well, it's just a good
Why,
way of
okay,
talking.
of course.
So, yeah, the flower is amazing. Now, I know a lot about the flower.
Right.
The flower is really beautiful. It's really bright. So do you think that's just for Valentine's Day?
Yes.
Well, Mr. Keeling,
No. And I know this because when you go to shops on Valentine's Day, tell me if I'm wrong, when you go into shops on Valentine's Day, there are flowers there. Lots of flowers.
Okay, now Mr. Keeling's got a very good point.
Supermarkets.
Now, flowers are beautiful.
Beautiful.
We do link them to beauty. And that's
Fabulous.
part of the reason why we give them at Valentine's Day. But you know what? They're not just beautiful.
Right.
This is not the first.
Did you know that?
No, I didn't.
Yeah, it's not just us who find those flowers, those colours, those patterns really fascinating. There are other creatures who find these beautiful.
Okay.
So, for example, have you ever heard of invertebrates?
Yes, you mentioned those earlier. So you said that invertebrates do not have a spine, don't backbone.
That is true. They don't have backbone.
Okay.
I remember rightly. Was it year 2 who came in here?
I think it was on the mini beast hunt, wasn't it? Who were talking about it? Oh, that was
This is
good.
not the first time the school
Teachers'
was trying
contribution. They
something.
were really, really good. It's a shame about the teachers, but the kids were next level.
Phenomenal.
Next level. So, one of the things I know about these flowers is the bright colours attract something we call pollinators.
Oh, okay. This is related a little bit to kind of seeds and seed dispersal, isn't it, in a way?
Right, because there are lots of different ways seed can disperse, and maybe we can talk about
We will talk about that
We're going to
later.
talk about that later. I can't wait to find out.
This is not the first time in school.
So, these bright colours, not only do they attract humans, but they also attract these pollinators.
Okay.
Little buzzing bees, little insects, little creatures, they come and they're attracted by the flower. Now, sir, do you think it's just the colours of the flower that they're interested in?
No, I think there must be something in it for these insects because obviously, if an insect has travelled into these beautiful coloured things before these flowers, and there was nothing in there, they would probably learn just not to be interested in those kind of types of plants or colours.
Right, that's a very, very good point, sir. So we need something else that's encouraging them. So what I like to think of, sir, I like to think of the flower as a bit of a landing pad.
Right.
Have you ever seen in a hospital, there's that big
The H for hospital.
for hospital, but actually it doesn't. Well, it might stand for, but I don't think it does. I think it stands for helicopter. And so the
Helipad, yeah.
helipad, yeah. So that is like a big advertisement.
What's it?
both of you doing the first?
We both did the first one together, yeah.
Yeah.
We did that, yeah. So that is like a big advert for the flying helicopter that comes down.
Right.
It sees
So it knows where to land.
It knows where to land. It's
Yeah.
interested. It's got something there. These flowers, these colours, are a little bit like that helipad thing.
Okay.
They're like an advertisement for the fly, and it says, "Come here," and they're like, "Oh, I know. There's something really exciting down there." That exciting thing, sir, is honey.
Nectar.
Ah, it's not honey. I keep thinking
This is not the first time.
the flowers to eat honey, but that's not true.
No. Bees collect nectar, and then that is transported back to the bee's hive, where it's turned into honey. Let me just there's quite an interesting fact that I
Do you
want
know
to
what,
share
sir?
here.
I love interesting facts.
I love interesting facts too, and here is the interesting fact. Did you know that when bees collect nectar, they take it back
This is not the
to the
first time
hive
that
and they
these
chew
two have tried to
that
raise money
nectar
this
in
way.
their mouth,
During
mixing
COVID,
it with their
they did the
saliva.
first
They
telethon,
don't stop there
raising
though. They
£6,000,
take that nectar and that
which
saliva and they
helped
pass
buy
it
laptops,
to another bee,
Wi-Fi
who
dongles
then
for
chews the
children
nectar and
in order.
chews the saliva, adding its own enzymes and its own saliva to break it down.
I love
It passes it again.
It was a Teach-A-Thon, not a telephone, just in case.
Teach-A-Thon.
Teach-A-Thon, not telephone.
Passes it on and passes it on and passes it on.
Yeah.
Until it
This
breaks
is not
down
the
into
first
honey.
time
So
that
basically,
these
when
two
you
have
eat
tried
honey,
something
it's
like
not the first time that
The
honey's been
first
chewed.
Teach-A-Thon
It's been chewed
took
by
place
loads of
during
bees.
And they helped raise
Whoa.
£6,000 for laptops and Wi-Fi equipment so that children could continue their lessons from home.
Bee spit, yeah. Oh, delicious bee spit.
Do you know what? I love bee spit. Now look, let me carry on with this because that bee spit, that sweet taste must have come from somewhere.
Yes.
And yes, those colours are like that big.
Ooh.
Ooh. How exciting.
Started off with bee
Continue.
spit, if you wouldn't mind.
Is it what?
Start off on bee spit.
Okay, bee spit.
Okay, bee spit.
Yeah,
Back to bee
bee
spit.
spit. Right. Tell me when.
Go.
So what you're telling me is when I'm spreading that honey, I'm actually eating bee spit.
Absolutely. Not just one bee spit, lots of bee spit.
Lots of bee spit. Well, do you know what? I think
Delicious,
bee
sweet
spit is
bee spit.
delicious. Now, it can't just be that
No.
they are coming here for. There must be something sweet and delicious in. We were just talking, like you said, about it being like a landing pad. Is that right?
Yes.
Yeah, it's attractive, it's interesting for them, it attracts them towards us. So once they get in there, so there must be something sweet they want.
We said nectar. That's what they have. They take that drink, they drink the nectar, and then they take it back.
I
to
love
the
it. It's
hive.
almost like I haven't
Now,
used drink.
You haven't, but the bee or the pollinator or whatever goes inside of that plant gets covered in the pollen. And we're going to pause there because I don't want to give too much away when we talk about pollination, which is going to come up next. So I'm going to pause at this point, and what I'm going to say to you at home is, can you remember, now that Sir and I have talked about it, the jobs that each part of the plant has? I'll come back to this slide in a moment, but maybe tell a partner. If you're watching from school, tell your teacher. And if you're writing this down, write down what are the 4 jobs for the 4 parts of the plant. And actually, there's more than 4 jobs because some of them have.
That's just right. That we're doing this at one level now, and that later on we're going to come and look at this in a much deeper level.
Oh, absolutely. This is just year 1, year 2 knowledge, but we will visit other knowledge. And actually, as we build through plants, we'll be building up that knowledge. But we will revisit this in a moment to go through those answers.
I like that. Now, one of the good things about our curriculum as well, as we're starting off, we start to introduce little concepts, don't we?
Yeah.
And year on year, we come back to those and we slowly build on them and we consolidate the children's understanding.
It's just like a plant.
It's just like
We
a plant.
start with the seed, we water, we nurture, it builds up until we have that great knowledge.
And that's what it's all about.
That's what it's all about. So,
right,
quick
test
true
time.
or false, true or false, true or false. Now, you can indicate this in the chat if you want to, adding true or false, or you can do a thumbs up, thumbs down, or if you're in class at the moment or in the hall, because I know this is streaming in our school in the hall at the minute. If you've got people, Causeway Green, if we've got people around, you can give thumbs up or thumbs down. Let's see if you think any of these statements are true. And I'll ask you, sir, see what you think as well.
Okay, I'm ready for this.
Okay, so I'm going to take your answer first,
So my answer
and then I'll
first.
tell you if you're correct or
Okay,
wrong.
great.
Okay, are we ready? Okay,
Yeah.
ready. Okay. Plants grow.
Oh, I've never seen a plant grow. They're just the size they are, aren't they?
So true or false?
I'm going for false, surely.
What do you think? Tell your partners right now. True or false? Thumbs up, thumbs down. I'm afraid, Mr. Jordan, you are wrong.
I'm wrong.
Plants do indeed grow.
Well, I've
Otherwise, they
never
would
seen them
stay as a seed. Sometimes it takes them a long time to grow. And we've got some videos later on where we will show you plants growing.
Fantastic.
A time lapse where it's a lot longer.
Can't wait. Okay, next question. I'm ready for this.
Right, here we go. Plants have leaves.
Okay, I've got this one. Do you know what? I actually know the answer to this one.
Okay.
That one is true.
Thumbs up, thumbs down.
course they do. We talked about the 4 parts of the plant before. We said that they have the roots, we said that it has the leaves, the stem, and it has the flower.
Yep.
Okay, plants are made from plastic.
I'm on a run here. I got the last one right.
Yes, you did.
I don't think it's going to be a problem with this. 100% I know plants are definitely made from plastic. I've got one on my desk. I can prove it to you.
Okay, plants are made from plastic. Thumbs up, thumbs down. Now, whilst you may have a plastic plant on your desk, sir, that's not actually a living plant.
What?
Real
It
plants
has a
and
flower?
living plants that are alive and that grow are not made of plastic. In fact,
Hold on a second. It has a stem,
Right.
It has leaves.
Yeah.
It has a flower on top of it.
but it is not living. That has been made by a human.
Oh.
And in fact, all things made of plastic have been made by humans, whereas
Ooh.
plants are natural and they are not made from plastic.
Okay.
Plastic not natural and cannot break down, so actually damaging to our environment.
We're going to find out more about plastic and oil pollution and all that later, you know.
I cannot wait to
Yeah,
learn that
I am
lesson.
really excited about that.
Plants only grow where people want them to. Now, actually, this goes back to knowledge that we talked about a little bit before,
Right.
and that was common flowers, common wild and garden plants. So the children should actually have this knowledge already, but
This
you missed that,
morning-
sir. So
I did miss it, but I remember also this morning that when the children came on here, they were able to name a lot of flowers. Do you remember that they knew about roses?
Yeah.
They knew about bluebells. They knew about daisies. They knew about daffodils.
Yeah.
Were there more?
Yeah, I think there was lots and lots and lots.
So I'm assuming if they knew it, they planted it, and I can see this is surely plants only bother where we are, right?
That is incorrect, sir, because there are wildflowers, and when we talk about seed dispersal, they don't need to be planted by humans. In fact, nature is geared up in a way that plants can grow and thrive without humans being here. And actually, mine thrive more if humans weren't, in certain areas, such as the urban areas.
I've seen one of those scary post-apocalyptic movies, and in it, the plants were thriving.
Absolutely, may take over if humans vacate a certain place.
In a way, we're kind of limiting their growth, aren't we?
We can limit their
Is that
growth.
anything to do with urbanization, sir?
Absolutely. So the growing of the cities, the concrete in the ground, the building of the roads, we're restricting spaces where plants can grow.
Gosh, we're a bit cruel, aren't we? to the world?
Sometimes we can be.
Yeah.
Some plants have flowers.
Right. I'm gonna pick this plant up here. I can see that it doesn't have a flower. However, you didn't say all plants have flowers, did you?
Let me put this diagram on to maybe help you, sir.
I mean, this one doesn't, but that one does.
And let's think about the wording. Some plants have flowers.
Okay, it is true.
It is true. Okay, it is absolutely true. So well done if you got that one too. Let's have a little look then at some wildflowers. Now you mentioned some of the names of wildflowers. Do you want to go through a few of these, sir?
Right, I know a lot of these. Now, a dandelion is often referred to as a weed. And do you know what? People are quite mean to dandelions.
To be honest, sir, I have already today referred to it as a weed.
I think it gets a rather bad rap.
I disagree because I feel like dandelions in my own garden, in my own space, tend to take over and they're unwanted. And if a plant is unwanted, then it is classified as a weed.
And now I'm going to stop Mr. Keeling here for 1 second because it's unwanted by
me.
But who do you think might really love dandelions?
You?
It's not me, sir. It's the pollinators, the insects.
Oh, wow.
They find dandelions absolutely amazing. These are an incredible source of nectar. They're an incredible source of food for them. And actually, our war on dandelions is a little bit unfair on all those pollinators out there who really need them. Now, I know you say that they grow and they can become a bit unsightly for a little while, but nature doesn't normally have a way of evening these things out. And it has a good way of managing things so that they don't become too dominant. And actually, maybe our interference in our gardens and the way that we manage things is part of the reason why these things aren't appreciated quite in the same way as I think they should be. They're brave, they're soldiers. I'm going to keep talking.
Sure.
So I know another one over here. A daisy. Now, a daisy is, don't worry about it, a little bit of noise going on. We're just trying to maximize our coverage here. A daisy is great. You can actually play a little game with a daisy. You can pull the flowers off one by one and you can ask questions. Okay, they're really good fun for that, although obviously we shouldn't be damaging the environment, shouldn't be damaging flowers. Just checking that live stream's still going, so just flick it off. Yeah, we do see it's still going. Now, here's one of the plants. Now, by the way, do you remember, if you go back in the stream earlier on this morning, then you'll notice that not all of the daisies are really, really small.
Some of the daisies are really,
Double
really
lights
big.
going here.
Okay, we've got giant daisies outside, we've got tiny daisies that are also sort of things. And I can't remember back to it, but if you go back and you look at what year one was telling us first thing this morning, they were able to name that giant, they look to me like giant daisies outside. Now, buttercups. These are fantastic. Buttercups, these are famously, if you've got a buttercup, you can show it underneath here and you can see if you like butter. Well, is that true or is that just a little bit of a myth? It is true that the buttercup, when it shines onto your skin, that it will show a yellow reflection. The yellow reflection is more to do with the light shining down and bouncing off onto your chin. It doesn't really tell you whether you like dairy products or not. But they are beautiful little flowers, which I really, really like. Okay, we're moving on to one of my favourites on this list, and you might say to yourself, how on earth is this a favourite of yours?
Oh, the stick there.
Well, it is a favourite of mine.
No, that's no worries.
I love nettles. I love nettles. I think they're fascinating. Nettles have an incredible history. Did you know that nettles were first brought to the United Kingdom by the Romans and the Roman Empire? They were spread over here with all sorts of other products because nettles have a load of amazing nutritional values that we don't sometimes realise. It's a bit like when I was talking about the dandelion. And Mr. Keeling said, that's just a weed because I don't want it. We say the same about nettles, they're just weeds because I don't want them. But nettles have a lot to offer to the natural environment around them. They communicate with other plants, they help to regulate the environment. They also do, because they they allow other plants to nestle in between them safely, and they sting predators who come in. So they're kind of like protectors of certain of the wildflower plants, which is pretty cool. The other thing about nettles, like I said, they have a high nutritional value. You can actually take the nettle leaves. Now, I'm not saying necessarily you should go and do this, but it is a bit of fun to try it. The stings of the nettle are only on the outside of the leaf. So if you grab the nettle by the top and the bottom of the leaf, what will happen, maybe later on we'll go out and find it. Grab it by the top and the bottom, and you can remove the leaf, which is really, really cool. Right, what else can I tell you about nettle? I can tell you something else about nettle. It makes incredible nettle tea, and nettle tea is absolutely delicious. You can also mix it into soup, and you can mix it into cheese,
We will certainly get some kind of war at some point. I think we've planned in
this is one that we definitely got a lot of,
such
so I can go and have a little look at. Ivy's a little bit different to some of the other plants. These are just
where the other person
nettles don't hurt well.
So we have thought about that, but
what ivy does, ivy's known as a creeper, a crawler, and what it's able to do is it grows and it grabs onto things.
We might start to do that one, and I think last time
so you'll often see ivy might be winding around trees. You might see that it's
we reached out
of hedges and all over the place. So yeah, ivy, a winder.
Maybe this time she might.
You know what, I really want to go outside.
We'll see
and I
how
want to go and
it
see some of
works.
that ivy. So we might go and do that later.
And how is it energised?
Okay, we've got another flower down here.
The children.
And my endless knowledge of also, I think that's completely lost my
it's
one thing I do
something
know,
that they
often the roses that you get in shops and barns, they're not a real, like, natural thing. It wouldn't have come about like that naturally. And the more natural roses you see don't quite look like the sort of things that you'll be given on Valentine's Day. The things that we give on Valentine's Day have been really carefully selected and pollinated, and they've been grown to be the way that they are. A bit like dogs. If you think about dogs, dogs don't exist naturally in the way they are. We might have a little bit of that when it comes to evolution as well. All dogs come from a kind of wolf. So I know that all of the modern roses, they come from a natural, original wild rose that you can see all over the place. Clover, fantastic. One of the things I like the Irish, you know, about the clover.
giving site, or it's via our QR code, which is.
So if people want to check or want to donate, you've got 4-leaf clover. That is meant to be a sort of sign of luck, which is really cool. I've got another one of these
right now how much we've got
on this list. Now I said that I love the nettles. I said that I love the dandelions. I love brambles, and I'll tell you why I think brambles are so great. Brambles, they interweave in between all of the other plants. Okay, they have these spikes on them, and they kind of make a defensive barrier, right? all these spikes make a defensive barrier around the hedges, and they protect a lot of the wild. So you might find that a hedge that's got full of brambles has little nesting wild birds inside them. You might have little mice and all sorts of little creatures that use that as a kind of defensive position. If you think about a bit like a castle has all of these defensive positions. It has ramparts. It has all sorts of things that keep it safe. And as
If they go
inside a
direct
safe,
to
well, I always think of brambles being a little bit like the castle walls, the hedges. They protect the small birds, they keep them safe. And the other most amazing thing about brambles, not only do they grow incredibly and they'll grow all sorts of places, no matter what the soil, but they produce a delicious fruit. They have a beautiful little flower on them, and they produce a lovely fruit, which we call blackberry. And blackberry is absolutely delicious, right? One of my favourite fruits. So a lot of these things, sometimes when we say, oh, they're a bit of a weed, they're a bit of a problem, they actually are providing something really important to the wider ecosystem. So as we said earlier, yes, people call dandelions a weed. What they're providing to the wider ecosystem is an opportunity for insects to drink nectar, an opportunity for them to get energy. They're a little bit like these mini little landing pads that keep all of our bees and insects running and alive. You might say to yourself, well, I'm not a big fan of bees. Why are bees so important? Well, if it wasn't for bees, we wouldn't have all the food that we've got today. These bees allow all of our things like apples, let's say, or many of the fruits that you eat. They are the little workers who go and pollinate all of them and allow those fruits to grow. And they are one of the most underappreciated creatures in our world, and we really need to do a lot to protect those bees. And actually, by leaving some of these flowers, it really helps and supports them to grow and develop. Now over here we've got the bluebell, and the bluebell is an absolutely beautiful flower, and it has a really sweet, delicious smell. It only comes out for a really short period of time. For me, it marks the end of the kind of winter months, and it's that signal that spring is coming. I come from the Peak District up in Derbyshire, and there are forests absolutely laden with bluebells. You can see them as far as the sky can tell, as far as the eye can see, like a sort of ocean.
We're tethering to that for our hotspot, so that'll be out.
There is an invasive species of bluebells, however, and you've got to be a little bit careful because there is a Spanish bluebell that is coming into our environment too. We need to be a little bit careful to make sure that that's safe. Do you want to speak to any of the other younger children at all, or you're okay? You're happy, that's fine. If you want to get any energy out of them, it's up to you. So I got this wonderful scene over here as well, and this is a wildflower meadow. Now I know that the quality of that picture isn't absolutely fantastic, however, what I can see in there is a large variety of different colours, different flowers, a lot of different plants. And I think that's absolutely.
Do you want me to jump back in a second?
Yeah, so if we look, I've actually gone through each of these individually and spoken about the positives and the negatives about all of them.
Thank you, sir. Really good. Okay, so as Sir was saying, there are positives and there are negatives. And some people do really like these plants, even though a lot of people might call them weeds. I certainly would call the bluebell weeds because they tend to grow almost everywhere and they do take over. So bluebells certainly might need to be looked at as a weed. I certainly do. Now these are garden plants. So the difference between the wild plants and the garden plants, as we said earlier, is that the wild plants will grow in the wild without human intervention. However, garden plants are plants that are so pretty and so beautiful and so nice that humans have decided that they should be in their gardens and should be cultivated. So they are purposefully planted into gardens for the purpose of them to grow. So let's have a look at some purposely planted plants that exist in gardens across the world. So we have fuchsia, we have pansies, thank you so much. We have sweet peas, we have sunflowers, we have rose, we have lavender, and iris. What I would like you to do as a little challenge, a little task, if you have a garden at home or if you have a nearby park, I would like you to draw me some of the flowers that you have around you. And if you can, label them, name them, and tell me what is in your local area. I'd love to find out. Write it in the chat if you find any, if you just want to pop out and see, or if you just know the names of any of these different flowers, let me know. So, quick test, and then I'm going to go back to the different parts of the plant to see if you can remember what their jobs are. So a little test on these. Wild plants
are, garden plants are. What is the difference between a wild plant and a garden plant? Have a think, tell someone around you, or if you are working along with this live stream, write the answer down. I'm going to go back to the parts of a plant now, and I'm going to give you the answers for that before I give you the answers for this. Parts of a plant. Let's check if you've got the jobs correct. So the roots of the plant go out into the soil and they search for water and nutrients. That's one job. Well done if you got that right. The second job for the roots is to anchor that plant in place. So that keeps the plant stuck there so that the wind doesn't blow it away. That's job 2. Well done if you've got those. Then we have the stem. The stem of the plant has 2 jobs as well. The first job is to hold that flower up off of the soil. The second job of the stem is to take water from the soil and deliver it to the leaves and to the flower. The leaves, as we mentioned, Mr. Jordan and I, they collect the water and use sunlight and that water to photosynthesize and create food for the plant. The flower itself, its job is to be beautiful because it attracts insects inside so that they will drink the sweet nectar. Once they're inside, they get covered in pollen and then they can pollinate other plants. Did we know the answers to wild plants and garden plants? Well, wild plants are plants that grow in the wild that have no human intervention. What about garden plants? Well, garden plants are purposely planted by humans. Oh, this is one of Causeway Green's questions. So the children at Causeway Green Primary School sent some questions to me. And I chose this question because I thought it was really, really interesting. The question is, and we're just going to pause plants for a moment, Mr. Keeling, why is the sky blue? Now that sometimes is posed as one of those unanswerable questions, but it is answerable. We can talk about why the sky is blue, and it actually comes down to light, which we will again talk about a little bit later in the stream. I know I keep saying we'll talk about this a little bit later in the stream, but it's true, we will. So let's get up a slide and let's talk about why the sky is blue. Let's have a look. So, a new slide. Why is the sky blue? When we look up, we see that the sky is blue. We don't always see the sky is blue. Sometimes we see that the sky is orange. Sometimes we see that the sky is red. Oh, that's the science bell. I need to give you a science fact. Did you know that light is made up of not just one color? People think that light is just bright white. It's not. It's actually made up of every color that you can see. The fact that you can see color is because of light. And it relates to this. Thank you, Science Bell. It relates to this. Why do we see the sky as blue? Well, we live on planet Earth. Let's imagine that this line is planet Earth for now. I know it's blue and it's green, but we're just going to imagine this is Earth. Around the Earth, there is a protective layer of gases. This protective layer of gas is known as the ozone layer. The Earth's atmosphere. Now, when the sun's light, so let's draw the sun because the sun is involved. When the sun's light travels to Earth, it takes 8 minutes for the sun's light to travel to Earth. So that means, and you should absolutely never look at the sun, but it means that when you catch a glimpse of the sun in the sky, not directly, indirectly, you're actually seeing the sun, or rather you're seeing what the sun looked like 8 minutes ago. You're not seeing the sun as it is now. That's because the light from the sun takes 8 minutes to reach the Earth. After 8 minutes, the sun's rays will hit the Earth's atmosphere, at which point the light will scatter. And as the light scatters in different directions, it reveals different colours. Because let's go back to that fact. Light is made up of every colour you can see. You can see colour because it hits an object, it reflects off of that object, and it goes into your eye. Your eye translates that light into a colour, the colour that is seen. Some colours are absorbed by the object and others are reflected, making the colours that we can see. The colour scatters when it hits the Earth's atmosphere. Let's go back to our slides. Here we can see the white light entering a prism. As the light bends or changes direction, it scatters, revealing all of the different colours. The colour that is revealed once light is scattered as it hits our atmosphere is blue light. And because blue light is revealed, we see the sky as blue. But that's also why the sky isn't always blue. It changes colour based on the position of the sun and how the light is scattered when it hits our atmosphere. So, Mr. Keeling, why is the sky blue? Well, the sky is blue because of the scattering of light in the atmosphere. Okay, we did kind of year 1 level, some year 2 level on plants. Now we're moving more into the year 2 area. So, year 2 learning, plants. We are going to know that a seed grows into a plant, which we've done, but we're going to look at it in more depth. We're going to know that a bulb grows into a plant, and I did briefly mention it last time. We are also going to discuss the journey from seed to plant. And if there's anything repeated, we might just test you at home on those things. So quick retrieval. I'm going to give you 30 seconds. Look at the plant. What are the different parts? Can you tell me the different parts of the plant that you see? Left, can you label the different parts of the plant? Okay, coming back then. So we have our plant. Our 4 labels down here. So the top of the plant is the flower that attracts the insects. Then we've got the root, not the root, sorry, the stem that runs down the middle. We have the leaves, and then we have the roots at the bottom. Well done, you've got all 4 of those correct. Word of the session. So this session, we're going to introduce a word. The word is a science word, and it is observe. Now, this has come up a couple of times. That is because it is one of our key science skills. I do apologize if you can't quite see the slides. It's okay if you can't see them in their entirety or what they say today, because I will be going through them, explaining them anyway, and they're just really there so that we can have a little chat. But the word of the session is to observe, and observe is the skill at looking really carefully at an object. So really zooming in and looking carefully at something. Synonyms for that word are include but not limited to watch, notice, to see, and to discover. So, scientists will observe nature using the 5 senses. So it's not just about looking with your eyes, it's also about listening, smelling, touching, tasting, hearing. It's using the 5 senses to understand the world around us. Where do seeds come from? So we've talked a little bit about seeds. Generally, seeds are part of the plant, either in the fruit of the plant, or they are part of the internal structure of that plant. Seeds are part of a plant and grow as the plant grows. Dandelion seeds are light and can be blown away, and that's what we were talking about earlier, that idea of seed dispersal. Sunflowers grow their seeds in the middle of their petals. So when you look at a sunflower, you can actually see all of the seeds in the center of the flower. These seeds are found inside acorns, which grow on oak trees. They could grow into a new oak tree. So that is part of the seed being inside something else.
Wow. I love fruit and vegetables. Those are two of my favorite of the food types.
Fabulous.
Do you know what we need to do at some point, Sarah? We need to stop and eat at some point. We're going to have to take it intensely. Have you eaten anything yet?
I have not done
I
anything
have not
yet,
eaten anything yet either. The only thing I've had is a little bit of water. And I think what we need to do is pace ourselves a little bit. I want to make you aware that your last little surprise is at 4:20-ish.
Okay. Well, do you think maybe I could take a 5?
You take a 5.
Go through maybe one of your areas of
And then
science
we'll
that you're
swap
going to look
after
at.
that.
Yeah?
Yeah.
All right. So I'll take a 5. I'll stay here and still chat to you, so I'm still on the screen.
Perfect. I'm going to just go to the other screen, if that's all right with you.
That's absolutely fine. And I will just take a quick
5. And do you know what? It's really good that Mr. Keeling said take a quick 5 because I wish I had something to come up to that. I felt like if I started saying that, then I would know what piece of science I wanted next. Let's have a look. Where is the pen? Mr. Keeling put the pen here. Fantastic. Right. Do you know what? I think it'd be really good. We've got a little opportunity now. I'm going to check in with the live chat. I'm going to see what people have been saying. We've got lots of things. Science Kings we've got down here, which is really good. Keep up the good work. We've got Flower from Mrs. Penn, which is really, really good. Mr. Keeling got the merit, which is absolutely fantastic. We're still going. Thumbs up. Now, what would be great as you're getting home, make sure you get back onto this live stream. Don't leave us for too long. Make sure that we're still on, because you know what? The more likes we get, the more subscribes we get, the more this is going to go up through the YouTube algorithm, and then the more interest we're going to get in what we are doing. So, seeing as I've got food on my mind and I can't stop thinking about food right now, I thought that might be quite a good opportunity to think about some of the main food groups. Okay, food. And one thing I know from last time around is when I write things in yellow, people can't see it. So I'm going to change that over to a bit of blue. So we've got food groups. Now, I am sure that you are aware that having a really healthy, balanced diet is absolutely essential. It's one of the most important things, actually, if you want to have a healthy life. If you remember earlier on, and we might come back to this a little bit later, that year 4, when they came in and they were talking about the digestive system, they were mentioning how important our microbiome is. Now, you're just going to follow me a little bit because I'm going to fill up this little drink. And do you know what? I need a little bit of cola. It's got some sugar in, and I'm feeling that that little bit of sugar is just going to keep me going for a minute. And that's interesting. That's one of our little sugar groups, food groups that we might talk about in a little minute. I'll drink a little bit of Coke. Oh, sweetness. So good. So we were talking about your microbiome, okay? Earlier on, we just touched on it very gently, and we were talking about something called a symbiotic relationship. Now, I've just put food groups up on the board, and now I'm talking about symbiotic relationship, and you might be thinking, what on earth is he going on about? Having a healthy diet is really important for the relationship we have with our gut.
And you're thinking, what are you talking about, Mr. Jordan? You don't have a relationship with your gut. Your gut is just you. Well, that's not quite true. You are actually full of, believe it or not, trillions of other creatures, okay, living inside you. You are just one living organism, but inside you are a multitude of other organisms that rely on you. And actually, not only do they rely on you, but you rely on them, okay? They are what keep you going. They do all sorts of amazing roles, amazing jobs inside your body. So let's think about what those kind of jobs might be and why food groups links to that. Because not only do you need your microbiome to be healthy and fit so that it can help you to break down your food, so that it can help you to digest things.
Don't forget Yakult.
Don't forget Yakult. Why does he talk about Yakult and other things like Benecol? Benecol, because they come from a healthy gut biome. I'm really slowly getting to food groups.
Wonderful.
And the way I'm doing that is talking a lot about symbiotic relationships and microbiome. So yeah, don't forget about Yakult. Don't forget about Benecol, because these things are coming from a healthy gut. If we don't eat healthily, then our microbiome doesn't eat healthy. If we aren't putting the right things into us, then the little creatures that help and support us and make us who we are, then they aren't going to be healthy, and they aren't going to help us to stay healthy. So one thing that would be really nice to know is at what time that Midlands News things comes on, so that we can make sure we're doing something good after it.
We've already been on BBC TV once already today.
Have we?
Yeah, so
We've
we've
already been on BBC TV once
featured this
today.
morning. So
Did we really?
Somebody sent me a video of it. We can just share that on the live stream, I'm sure, no doubt.
Is this real? Turn the volume up a little bit, sir.
I can't.
I don't even remember doing that. When did we film that?
No idea.
I've got absolutely no idea when that was filmed.
Please feel free to carry on with bio, sir.
I will, sir. So we were already on the news today, which is really, really exciting. Can't remember when that was filmed. Fine. So that wasn't filmed, was it, sir?
Well, it's real, so it must have been.
Right. So food groups. Right. When you don't eat healthily, it's not just you who's suffering from not eating healthily. It is your microbiome as well that is suffering from eating healthily. So let's think about some of the things you need to eat and that are really important for you. One of those things is, and sir's going to be my spelling checker, because I'm a bit of not the best speller in the world. That's right, isn't it? Yeah, it is. Pretty sure of that. Carbohydrates. Now, carbohydrates, this is one of the main sources of food that we have, okay? It's often the kind of whitey, beigey, browny kind of stuff that you see about the place. I mean, white, beige, and brown are your favorite food colors, would I be right in saying?
White, beige, brown, and lots of green and healthy stuff too, thank you.
I don't believe that for 2 seconds.
Right, thank you.
If it's brown, he'll lap it up, okay? Carbohydrates, these are one of the main things. Now, carbohydrates are really important for us. A lot of people say to you, well, you don't want to stack up on your carbs. Well, it's true. And what we're going to understand as we go along with this is that we don't want anything in excess. But it's about keeping things in moderation. I might just need to leave at 4 o'clock just to check that those things, the surprise is running.
That's fine, so you keep going right here.
So the carbohydrates are a source of energy for us, and they're a really good source of energy for us because they are long-going, keep-going kind of energy sources. Yeah, they keep us pushing forward. I'm trying to think of things like potato. Is that a potato, sir?
That looks more like a bean with a beak.
It looks like a bean with a beak.
Can I do a news flash special?
We've also got things like this, which is pasta.
Sorry,
that is also really important.
We've got a news flash.
Okay, you've got a news flash. What is your news flash, miss?
My news flash, as opposed to my flash, is this. Basically, if you bring in £1 either Monday or Tuesday, if you're off school for Eid on Tuesday, you can have another go at naming that amazing dog, and you name the dog, and then you win this extremely exciting hamper. And sir, is it true that the second prize is 2 of those hampers?
The second prize is a high five from this.
A singing lesson, a free singing lesson. Right, so have fun, everyone.
So, whoa, what have I got here? This is another example of a
Nice to
carbohydrate.
see you.
Now, this here is a potato, and believe it or not, carbohydrates. Oh wow, these are really good. These crisps actually come from potatoes. I'm really sorry, but this is the first time Mr. Keeling and I have eaten all day.
Yeah, and as Sarah's saying, carbohydrates are so important to keep going and keep that energy up. So although they're stodgy and probably not the best for us right now, we do need them. So we are fueling up a little bit in between. Hope that's okay with you, but we are fueling up with our carbohydrates.
Oh, thank you so much for that, Sam. Now, one of the main carbohydrates in Britain that we consume, and this is my picture of it, is bread. So there are all sorts of different types of bread. You've got your naans, you've got your rotis. But these all come from ground flour and other grains. They are fantastic. They're just like little, I like to think of them sometimes as little batteries. You know, you have a piece of toast, and in it it's got enough carbohydrates to just keep running, just keep going for a little period of time, which is really important. Same with the potato. Yeah, it's just packed full of those starchy carbohydrates that really keep us going through the day. Now, I've said that energy, and earlier on, you saw me sipping on this Coca-Cola, so there is that Coca-Cola there. Oh, you're having that one? I'll drink this one first. Right. Earlier on, I was talking about that Coca-Cola that I was sipping on, and I was thinking, oh, sweetness, that's giving me energy too. Well, sugars is one of them as well, okay? And both of these are providing me with energy to get me through, but they're different kinds of energy. And one is, whoa, let's have a look at some sugars over here. Obviously, other brands are available. This is a Kit Kat. Now, the Kit Kat has all sorts of sugars in it. It also has carbohydrates in the wafer. These sugars are giving me a kind of kick, an instant amount of energy. Yeah. I'll come back and finish the rest of it. Really good. Gives me that kind of instant energy that just zoom. Let me run over there. Bam. Let me go over here and do this. That little bit that I need. The wafer inside it, which is one of the carbohydrates, is giving me that kind of longer energy, a kind of slow release energy. I don't want to have too many sugars though. It's not good for my body. One of the things my body will do, if I consume too many sugars, it will start, if I'm right, sir, on this, converting those sugars into fats. And it'll do, is that right, sir?
What's that, sorry, sir?
I mean, that fast check. If we're having too many sugars, it's a bit like it converts into fats. Is that right? I want to check that.
Check.
Don't write that down yet until the fact checker has fact checked that fact. Okay, really important. Too many sugars are not good for us.
Yeah, it will eventually be stored as fat if you consume too much.
And this is a bit of a problem for us, isn't it? Because we know that sugars are one of the most sweet, delicious, amazing things that we really want to have loads of. I'm thinking to myself, what is it about sugar that makes it so appealing, that makes it so attractive? Because I love it. But wait a second, Mr. Keeling also loves it, and Miss Galloway loves it, and I know Mr. Pemberton loves it. So what is it about this one substance, sugar, sweetness, that makes it so attractive to us? Let me think. It can't be that it's good for us, because we all know, when we're told all the time, too much sugar is bad for you. Mr. Keeling has just fact-checked and confirmed that if I consume too many sugars, then it's going to turn into fats eventually. I also know, and maybe we'll do this experiment a little bit later, that if we have too many sugars, it's not good for our teeth. It's good for our teeth enamel. Maybe that's something that we can note down for later on. So when we come to the tooth enamel bit. And so they're bad for us, they're bad for us, they're bad for us. They give us a bit of energy, but they're bad for us. So why on earth would we be so attracted to it? Well, this is something that we're going to talk about later. It's to do with our evolutionary history, because it has only been a very short period of time. Look, if this line over here, I'm going to make a line, if this line is as long as humans have been around, and by the way, humans didn't just start at the start point, they evolved from all sorts of creatures that would carry on going, not just over here, but they'd carry on all the way right outside of that building. They passed down into Birmingham proper, okay? But let's just take this little snapshot of human existence, that kind of 100,000 plus years that we know from Stone Age man, when we first started using tools and equipment. That's what this little snippet is going to be, a tiny bit. And genuinely, I'm going to do another number line. No, I'll do that afterwards. So that's our little snippet from Stone Age. So how much of that have we had easy access to food? Well, let me get out another colour, because easy access to food, I wonder, sir, would you like to tell me when you think it's going to stop?
Easy access to food.
Easy, like every single day kind of access to food.
Oh, I think it's going to be up here somewhere.
Oh, Mr. Keeling knows he's not going to be tricked out. Oh my gosh, we're in at halfway, and now we're up here and over here, and what do you reckon?
Wow.
Now, yeah.
So what time period would this be?
I'm around here. Yeah. I guess as we're coming into the kind now, you look at back in the history books and you look at the medieval periods and all that kind of thing, and you see people being healthy, but actually there were still food hardships in those times. Their diets were not rich, they were not balanced. For example, they wouldn't have heard of a potato.
Wow.
A potato is not a British vegetable. It's not something.
No, it was brought over, wasn't it?
It was brought over from the explorers, which is science.
Yeah.
When the explorers went over to South America, they were searching the place. They were exploring the biology of the environment, and they realized that people over there were eating this amazing. Is it a vegetable?
It's a root.
It's a root vegetable, yeah. They were eating this amazing root vegetable that was giving them, it's like little, again, I would call them battery packs, yeah. And they brought them over to Britain, and we were like, whoa,
Ooh,
potatoes, chips, yeah, we did. And we turned them into chips, which is one of the greatest things on earth, and crisps, which are also one of the greatest things on earth.
Might be true. There's a not sure if it's a myth, but there's a story that it was a French chef that made the first crisps, wasn't it?
I didn't know
that. Cut them down as a bit of an insult to one of the people that were dining there.
Right.
I don't know if it's true, but that is a story about.
Can you fact check that, please?
Yeah.
You in the chat go and fact check that. Were crisps invented by a French restaurant who was
trying to insult one of the guests?
One of the guests. We'd like to know. Get it onto the stream, please. Also, I think this is a good place just to pause and check. Have you been tweeting Elon Musk? Have you been checking with him? Just send our link to him. Yeah, because...
And to check in on what we've raised. So at the moment, we're at £1,725.
Wow.
We are getting very close to that £2,000 mark, which is amazing. That is a big moment. So I think if we do get to 2,000, you said you'll eat a Scotch bonnet chili, didn't you say, sir?
I said
and then you'll talk about what's going on whilst you've eaten that chili.
If we get to £3,000, I will eat myself a Scotch bonnet chili.
And then you'll talk about what's happening.
And I will talk about
whilst you're eating it.
£3,000.
At £3,000.
I will eat a Scotch bonnet chili, and I'll talk about what's happening whilst I'm eating it.
Fabulous. Okay. So if you haven't donated yet, and you have a spare £3,000, could you please donate, because it will be really funny to see Mr. Jordan eat a Scotch bonnet chili.
And by the way, we're not messing about here. This is science.
This is science.
Yeah. So if we get to £3,000, I'm going to put one of these in my mouth. I'm going to chew it all up.
This is for science.
And we're going to see what happens to the body. How does it react? What's going on? What is the science behind it? And it is part of a healthy diet, I think. Occasionally a little bit of chili.
Sure is.
So yeah, we were over there, and so back to where we were talking about with sugar and why is it so delicious and why is it so important to us? Why are we so keen on consuming this thing? Well, this is our history. And easy access to food is a tiny, tiny part of it. It really is a very insignificant part of our entire history. So what's it been like the whole other rest of the time? Because now, if I want some food, I just go to Tesco's, I just go to Aldi, I just go to Asda. I know where Waseem Zaffar will go.
Where's that?
Aldi, he loves it.
Oh, Aldi. Yeah, he loves Aldi Coke.
Aldi Coke, he says.
That's
one of
all
the
he
best
said
ones.
to me.
Yeah, Waseem loves Aldi Coke, and that's good. And he's a very big supporter of our school.
He is, and we loved having him on. So thank you again so much for coming.
So, right, what was the problem then? Okay, so now I just go to the shop, I just go do these things, I can just order stuff online, I haven't got any kind of problem. That wasn't the way in the past, okay? Food was not easy to access, food was scarce. And actually, what is one of the most important things that we need on a day-to-day basis? It's a little bit of sugar just to keep us going, that little bit of energy, keeps us alive, keeps us healthy. So
actually, sir, you're speaking about how hard it was to find food in the past, but actually, it's a real problem right now, because have you ever heard of something called a food desert?
I've heard of food, and I've heard of deserts.
Yes.
So let me combine the two. A desert is something you have after your main meal. Let's say a blancmange.
No, you're thinking of food and dessert, sir.
We're not talking about food and dessert.
We're talking about food deserts. Now, actually, even today, even in the age that we're living in, where you can get food at the touch of a button on and out, wherever, there are still places all around the world where you cannot get healthy food.
Is that right?
Not locally, you cannot buy healthy food. There are places in the world where there are food deserts, and basically they are surrounded by food at the touch of a button, but it is all takeaway food, sugar, fast food, and not good healthy food. No access to good healthy food within these deserts. There are places, I think a lot of places actually in America, where there is just not enough healthy food. So even today, isn't as easy as just going down the street and getting it from the shop, especially if you want to eat healthily. And actually, sometimes shops are geared up in ways to sell more of the sweet, sugary, lab-made food rather than the fresh and healthy food.
It does sound delicious, though.
It does sound delicious.
Much watery.
It does, and that's the problem, isn't it? You know, because we are built, we crave that because it gives us certain chemicals in our brain that are positive rewards from the food that we're consuming.
So let me think a little bit about this whole journey, before food was easily accessible,
Yeah.
and why our brain would train itself to want that positive reward and to have that excitement when it comes to sugars. Well, you know what? You might not find some sugars for several days. You might be in a situation where you're desperate. And you know what? You need to love, that sweet thing. You need your body to see a sweet thing and to think, yes, give it to me now, quick. Because that might be your only opportunity of survival, right? That is the main thing. Now, a lot of kids are like, vegetables, yucky, 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 right? Well, vegetables are important, vegetables are good, but the thing that kept us going in our early stages, we weren't going around growing vegetables and picking vegetables out of the ground. That's not something that we were doing earlier on. We would have been scavenging any old bits of meat. We'd have been scavenging old bits of bone, little things that we could get our hands on, little berries that we found about the place. The sweet, sweet berries we liked because that was part of our integral diet. That was something that we needed. That was something that we had to consume. That was something that was vital to keep us going. Meat, why do we like meat so much? Well, yeah, that was an early thing. If we found some sort of dead creature, something going, we'd get in there quickly. Humans, we might bang on about how strong we are, but actually, do you know we're an incredibly weak animal? Wow. Yeah. To compare to many other animals around, we are not very strong. Mr. Keeling is built like an absolute machine. There's no question about that. Absolute pure muscle stack. However, if there was another creature, let's say a lion in here, well, he's not going to stand much chance against it, right? It might not even be an animal that's bigger than him. It could be a dog. It could be, let's say, a chimp, okay? And Mr. Keeling is a lot bigger than a chimp, but that little chimp would come and it's so strong and tough. Humans are weak. We are fragile. We were not built to be attack animals. We don't have those massive canine teeth. We don't have giant claws. However, sir, we do have something that sets us aside from all of those other creatures I was just naming.
Giant teeth and claws.
It's not the giant teeth and claws, or the giant teeth and claws.
Right.
It's neither of those. Neither teeth, claws, or claws.
Are you doing okay with that?
I'm fine.
Right.
So it's none of those. Would you like to take another guess? What do you think it is?
Probably the massive claws and teeth.
Now that's interesting that you said that.
Right.
It's actually not the massive claws and teeth.
Okay.
So is there anything else that you think might put us to a bit
Intelligence.
Wow.
I don't know where that came from.
I don't know where that's come from, but that's amazing. And Mr. Keeling's totally right. One of the things that sets us aside from those other creatures is our incredible intellect. Maybe that's something that we'll come and look at later. So we needed to get food when we could. We weren't able to go around killing and fighting and get it in, and we were scavengers basically much of this time.
Right.
And so we needed to desire these things. We needed to desire that sweetness because the second there was an opportunity for it, we needed to gobble it all down. Because you know what, sir? There might be some on Tuesday, but you might not see it again until Sunday or for several weeks after that. So that is why sugars are so appealing to us, and that's why it's a little bit dangerous and why we need to be a little bit careful because
it's actually the least beneficial food group of them all, isn't it? The sugars, because really you don't get anything from sugar. You can replace sugar.
You do get a little bit of energy.
A little bit of energy, but you can get that from all the other foods as well, from the breakdown of sugars within the other foods as well.
Right.
So actually added sugar is not necessary. It's just as that kind of response for us.
Mm-hmm. I love it. Yeah, not important. Get your carbs in instead. Not too many carbs.
Not too many.
Get your carbs in instead. A much better way of getting your sugars in because your body can deal with them in a different way. They can break them down slowly. Healthy slow release. And we're all about the slow release, aren't we, sir?
Yes.
Now, let's talk about another food group, sir. And do you know what? This is one of my absolute favourite of the food groups. Goodness knows what we've done with pens.
Well, there's one right here.
Oh! Wow. Definitely going to have to eat something because I was staring at that for quite a long time and didn't see it. So, wow.
Yeah, maybe you grab it on your next jaw.
Yeah. So, the next one I'm going to talk about I absolutely love these things. They are known as proteins. Okay, proteins are absolutely amazing. I'm a big protein eater. I like to consume high quantities of protein. Proteins are not putting huge amounts of fat onto me. They're not like sugars, but they do something which is really good. And it reminds me a little bit, if you remember earlier on, when we had those hearts out, because those hearts, and I mean, you can just come with me 1 second whilst we go over to this side of the room. These hearts, which are all, where are the hearts? All in
there.
In here.
Yeah.
Oh, wow. Lovely. These hearts, I'm not sure if I'm going to take the camera all the way over here. I'll just kind of unclip it for 1 second and we'll have a little look. These hearts are...
Just a quick warning to any children watching, there are some hearts that are going to be displayed.
Yeah, I'm going to just show you these little hearts that we have got in earlier. Now, these hearts, as you can see, these are rich and red and beautiful. Do you know what that redness is? That redness is lovely protein. That is what is going on here. And protein is the muscles. The muscles are the protein. And the more protein I can get into my diet, the bigger and stronger my muscles can become. And that's really, really important for my development. So it's really important that I have quite a nice high protein-rich diet, especially if I'm building my muscles or anything like that. Very, very important. And do you know, sir, meat, all I'm really doing is I'm just eating an animal's muscle, aren't I?
Yeah.
Yeah. So the animal's muscle is going into me, and the enzymes in my body are breaking them down.
It's eating your own muscles.
And
It's muscle for muscle, isn't it? I think you need to go and get yourself a little bit of food. And I feel like I haven't talked about plants in like a whole 20 minutes. So
the thing is, I'm actually going to be busy now.
Yeah.
Or take it next thing. I'm going to come back.
I think take something with you, and I'll take over for now. So we're going to pause what Mr. Jordan was talking about. I'm sure he will come back to that a little bit later, and I'm very excited for that. But right now, we are going to move back into plants. Now, I'm going to load that up. But what I'm noticing at the moment is my computer is currently shutting down every 15 minutes or so. So I'm just going to play with the settings very quickly, just to change the power settings. So please bear with me. I'll only be a second. Power and sleep, and I don't want it to sleep 5 hours. 5 hours. Okay. Hopefully that means when we're switching back, I don't have to keep logging in, because that'll be a little bit easier. So we got to talk a little bit about where seeds came from, and now we're going to move on to fruit and vegetable seeds. Now, again, I know that this isn't as clear for you at home as it is for me. I know you can't necessarily read everything that is on the screen, but don't worry about that. I will make it a bit bigger, so maybe that will help a little bit, but you don't need to be able to read everything that's on the screen. Really, this is just a prompt for me, and I'll be teaching it to you. So yeah, just listen to me as I go through it. So fruit and vegetable seeds. Fruits usually have the seeds as part of them, so on their skin or inside of them. When you bite into an apple, we know that the seeds in the apple, not very good for eating because they contain something called cyanide, only in minute amounts, but it's not good to ingest. So eating apple seeds, although whilst it won't really hurt, you shouldn't be done. But the apple seeds are in the middle of the fruit. So fruits usually have the seeds as part of them. Vegetables don't usually have seeds because the seeds will grow on another part of the plant. So if we think about vegetables, there might be a flower that grows out of the ground from that vegetable, and that may contain the seeds that will then be dispersed, whilst the vegetable itself can just grow and be the part that you eat. If you are unsure if something is a fruit or vegetable, then just remember, if it has seeds, it's a fruit. If it doesn't have seeds, it's a vegetable. And that can get a little confusing because people don't always realize, I know it's a lot more common now that people do, but not always do people realize that tomato was actually a fruit. Peppers and chili peppers are fruit. Why? Because they have seeds inside of them. I think people go on taste, don't they, with this? So with vegetables, they're more kind of earthy, umami kind of flavors, where fruit is more sweet. And anything that's not sweet, we don't necessarily in our minds class it as fruit. But technically speaking, if it has seeds on it or inside it, it is a fruit and not a vegetable. So Melons have seeds inside them. Strawberries grow their seeds on their outer skin, and they are both fruits. Potatoes and carrots don't have seeds inside them or on their outer skin, and they are both vegetables. Okay. Fruit or vegetable? How can we tell? Well, I've just taught you how we can tell. So if you are riding along or if you're with someone at the moment, turn to them now and tell them how you can recognize a fruit or a vegetable. I'll give you 30 seconds to do that. If you want to type it into the chat, you can now. How do you recognize a fruit or a vegetable? How can you tell the difference? How long is this? This will be 26 hours in total. We have been going for 7 hours. So that means we have got 18 hours left. Wow, a long time still left to go. Any answers on fruit and vegetable? How can we tell which is which? Type it into the chat if you know. Well done for getting a mouthful. 26 hours. Hey! If it has a seed, it's a fruit, and if it doesn't, it's a vegetable. Well done. Great answer. There we go. And that's very clear, isn't it? How can we tell? It's a fruit, it will have a seed. If it's a vegetable, it won't. Thank you for answering along in the chat. Moving on then. True or false? Now, we've just had this answer, so we should get this. Most vegetables have their seeds inside of them. True or false? Seeds are always black. True or false? Seeds are part of a plant. True or false? What do we think? Let's have a look at what people are saying. But tomatoes have seeds, but it's a vegetable. No, a vegetable. By its very classification, tomato is a fruit, just because, like you say, tomatoes have seeds inside. It isn't. No, you're right. It isn't. All right, most vegetables have seeds inside them. That is wrong. Seeds are always black. That is wrong. Seeds are part of the plant. Yes, absolutely. They form as part of the plant. So here on the screen right now, and I wonder if you can see. Let me just check. Yeah, I think we can see. Okay, I might just move you a bit closer just so you can have a real good look at them. Here we have the different types of seeds, and this is why I said before, is it true or false that all seeds are black? Well, no, they're not. They're not all small and black. Poppy seeds are. Can't really think of many others that are, but these are lots of types of seeds, and as you can see, there are actually lots of different colours and lots of shapes. So this one, it almost looks like the surface of the moon, doesn't it? We've got white, we've got green, with all these veins going through. Again, a craterous one. This one almost looks like a vegetable, doesn't it? That one looks like a fruit there. The seeds, in a way, in some ways, almost look like mini versions of fruit, which is pretty cool. Like a baby version of what it's going to grow into. I really like this one here with the kind of splodgers all over the black outer skin. That one's pretty cool with the reflective element to it. I like the stripes going down this one. They go faster stripes, don't you know? Go faster stripes, absolutely. So this one is it's almost like a piece of art, isn't it? And that gets us on to a task that you can do at home. So if you're watching along and you have paper and you want to do this task, I would love to see you bring this task into school. What you can do is you can choose one of these seeds or two of these seeds or maybe all of these seeds if you like them. You can pause the video and you can create me a piece of art where you zoom in on the seed and draw it and do an observational drawing of it. Now, you could draw the actual seed itself or all of the seeds themselves, or what you could choose to do is you could take an element of them and build up a repeating pattern. So this one, I really love the pattern on the seed. And if I replicated this pattern all over this blank square, I would have something that looks really, really cool. So you could take an element of the seed or you can take the seed itself, but why not try and create a piece of art with the seeds that we have up? Bulbs then, moving on away from seeds and on to bulbs. unlike seeds. Oh, I can see Mr. Jordan's just getting outside from Mrs. Jordan. Wow. Bulbs, unlike seeds, bulbs are plants that actually live under the ground, but are visible above the ground when their leaves grow up through the surface. So bulbs, almost more so, look like mini versions of vegetables. Some of them anyway, like onions, look like what they're going to grow into. And potatoes, you actually plant potatoes to grow more potatoes. But bulbs, a little bit bigger than seeds, and usually grow underground, but then the stem will come up and a flower will come up with them. Some plants grow first from a seed, then develop a bulb. Hi, sir.
Is there anything we need from Tesco's? That's the cornstarch.
I think we're going to have less time to eat full meals, and anything that's kind of snacky, carbohydratey would be good for us. Some plants grow first from a seed and then develop a bulb that helps them to grow back year after year. A bulb lets the plant rest underground over the winter when it is too cold, then grow back later in the year when conditions are right. Now this is a bulb, and this is a kind of a inside look at a tulip, a little bit like the hearts we were looking at earlier, except less disgusting. We can see the inside part of a tulip. So this is what is going on.
My wife's brought you a nice warm sugary drink.
Oh, wonderful.
Yeah. Not sure. Let's try it together. Is that
safe?
I think it's safe.
I know what it is. It's pink chai, carrot chai. Chai.
That's delicious.
It's delicious.
They're healthy.
It's healthy. Well, it's got high sugars and lots of dairy, though.
Oh, I do love high sugar dairy. Anyway, these are the parts of the tulip. So if we cut open the tulip, this is what we see. The tunic. Now you can see that part of the bulb without having to cut it open, because that's the kind of papery brown bits on the outside. In fact, when you have an onion, the kind of outer layer of the onion, that papery brown thing, think of that. That's the tunic. This is the papery outer covering that protects the bulb from damage or from drying out. And you might look at that, you might think, Mr. Keeling, that is an onion. No, it's not an onion, but it certainly looks like one. That's because obviously the onion grows underground as well, being the bulb. But actually, if you leave an onion too long, a stem will come out and a plant will grow on the top, and that tells you that the onion's been down there for far too long.
I just don't believe it's a...
No, that's true.
If only there was some evidence in the garden, we might be able to check
Oh,
this out.
I think maybe we can. When it's a bit darker and not too dark, I'm guessing with this camera.
I'm excited for that.
But yes, that tunic, the papery outer covering, protects the bulb from drying out, so it's still moist inside. And you know when you cut inside of an onion, you can see that, can't you? Because it's always a little bit damp and a little bit slimy inside of the onion. Then in the center you've got the flower bud, and you can see this as well. The kind of this get an onion, cut it in half. Look at it. The flower bud. It's a tender baby flower. The bud is in the center of the bulb, and that will eventually grow out of the ground, and that will form the flower with seeds in it. Then it has scales. These white modified leaves hold the stored food in the bulb, so it gets what it needs to grow. It holds its food inside, not like from a seed, and not like from the leaves of the other plants that we've looked at, where they generate the food for the plant. It stores food inside the bulb. The roots, just like a seed, actually, the roots come out from the basal stem. The roots take up water and nutrients for the tulip. So that's pretty much the same, seed or bulb. And then finally, we've got the basal stem. This is compressed stem. It connects the flower, scales, and roots. So basically, if you think about the stem of a plant that comes from a seed, it's very similar to that.
So the base is starting in that part. I didn't actually realize that. That's quite interesting.
I mean, everything's within that bulb, even the flower that comes up eventually. But it does look like an onion, doesn't it? It looks like you could, chop that up, fry it up, and have it on a hot dog.
So the roots would sort of spring out from down at the bottom. Now, here's the question. What if that onion falls into the ground or lands in the ground upside down? Then what's going to happen?
So it would start to grow, but it would right itself and it would start searching for the light, because ultimately that's what it needs. It needs that sunlight, so it would eventually find its way and grow up, although it would be much harder for it to do that. Okay. Here's a visual guide. Now, I'm not going to go through what all these bulbs are, but you can see that the planting depth of different seeds and bulbs are different. And if you are into gardening and you do want to do gardening in the future, you need to read the instructions very carefully because some plants need to be very, very low down because they need time to grow and to extend and to grow up. And some don't actually grow beyond the soil anyway. Potatoes, for example, won't grow up beyond the soil. Whereas others need to be nearer the top because they immediately need sunlight when they first germinate. But there we go. I think that's quite interesting. It's like the ocean, isn't it? You know, the lower down you go in the ocean, the different kind of ocean life. It's the same within our soil, within our seeds. It's weird, that kind of way that life reflects itself. Oh, I think we've got a special guest, a visitor.
This special guest
that's
is not
coming on the stream. Is that correct?
She's not keen on coming on the stream.
It's okay.
She's okay. She's fine.
She's okay. She doesn't want to.
She doesn't want to come on the stream, which is absolutely fine. Is this your one? Or is that your one?
That one's my one, the one that I'm drinking.
For sure, it's definitely mine.
For sure, Z.
Right.
Okay, so as I mentioned earlier, we've got a time lapse that I want to show you. Now, I am going to turn the sound off because I don't want to get any copyright strikes or anything to get this video taken off.
Brilliant.
So I'm going to turn it down.
But
I think this is absolutely fascinating.
Just in case you're wondering what a time lapse is, that is when, rather than just videoing the whole thing, we take little snippets, little segments, like little photos as it's going along, and then we mash them all together. What that allows us to do is it allows us to see something that is growing really slowly or moving really slowly and speed it up a lot. So in this, we're going to turn the sound off first. Perfect. In this, and we'll try and, I'm going to cover the screen for a second whilst this advert is on as well. So in this, we're going to see time-lapse sort of slow growth of a thing. Is it on behind me?
Yeah, so it's going to be 2 minutes, and within that 2 minutes, it's actually going to take the course of 89 days, and we're going to see sunflower grow
I
to
really can't wait
maturity.
for this because sunflowers, they grow really big and tall.
They're beautiful, and the seeds, we've already spoken about sunflowers, they're in the middle, so we'll be able to see the seeds.
Nutritious and delicious.
Nutritious, delicious, and
Cheerios are good.
giving birth to new life.
Yeah, that was it. So this is chocolate that they're putting this in?
That will be soil, sir. So they've measured the depth carefully, and now they're implanting the sunflower seed. We just looked at a depth chart.
Yeah.
So some plants need to be nearer the surface because they need sunlight immediately.
Right. Oh, I like that. And I noticed they're putting on, is that vinegar that they're pouring?
No, vinegar wouldn't be very good for the plant. It is water, though, so that it can take up the water straight
Whoa,
away.
this
Wow,
is
look,
going
day
quickly.
3, it's already germinated and it started sprouting and it's growing. We can see the stem extending, we can see the leaves. The leaves now are collecting that sunlight and the water is going up the stem to the leaf so that it can start the process of photosynthesis.
And we all know that photosynthesis is really important. Photosynthesis is when the sun's energy combines with the carbon dioxide that it takes on board, and of course the water and everything the plant needs. And what it does is it synthesizes, there's that synthesis word in there, it synthesizes and turns the sun's energy into energy for itself to grow. An absolutely amazing technique that plants can use. Imagine if humans had the ability to photosynthesize, we'd probably solve all of world hunger, because instead of having to go out and eat, we could just lay out our hands and put them up. However, there is one problem with photosynthesis and why it wouldn't be very good for humans. You know what that is? It actually is not the best, most efficient way of taking energy on board. And actually, the methodology that we have developed of just consuming food gives us a much bigger punch and much greater amount of energy. We'd have to be laying out in the sun for a seriously long time. So what's happening? What is this?
I mean, I don't know what you're talking about.
What is this?
But I can make my own food. Yeah, I'm an adult, I can make my own food. So obviously it's lifting up the flower, and actually it's for a very short period of time that flower is up there. So it's taken 70 days to get up here. And now the flower is big and it's beautiful and it's trying to attract those pollinators so that it can be pollinated and so that the seeds can be used to reproduce. But as you can see, this is an 89-day time lapse. This started, the flower started on day 70, but look, it's already starting to.
So we've gone past 11 weeks.
It's already starting to die. It's already starting to lose its beauty, to lose its colour. Within about 10 days, so it only has that time window to pollinate and to reproduce, which is quite a short time period.
It is a really short time period for them to reproduce. And actually, it's part of the reason why we were talking earlier, we looked at all those plants, some of which Mr. Keeling was very meanly calling weeds. And certain flowers...
I mean, they were weeds. Especially the bluebells.
Certain flowers are only out for a very short period of time, the bluebells being another example.
I like bluebells.
Bluebells are beautiful.
No.
But if we only have the flowers that we just like and we get rid of all of the other flowers, then we are not giving those pollinators the opportunity to get the food that they need. And as we know, when we have fewer bees, pollinators and things like that, it damages our food supplies.
So what Mr. Jordan is saying is we need to dig up all the daffodils and the bluebells and replace them with other plants that could help our pollinators that look prettier. Thank you for
quite
adding that in,
not
Mr.
quite
Jordan. So, okay. task then, so you just watched that video and you saw the plant growing, you saw it from a seed being put into the soil, you saw what was added to the soil, and then you watched it grow. And we talked a little bit through it about what exactly was going on. So here is a little task
Very nice
for you.
Chai box.
Oh, and if you're watching Chai Box, please do donate.
Yeah, we'll
to
have
the
more
stream.
free ones of these.
Yeah,
This is tasty.
donate, please.
Thank you very much.
Can you draw and annotate the growth of a sunflower from seed to flower? So you just saw it.
Are they putting that in the chat?
That, I mean, I don't think they'll be able to draw it in the chat, sir.
If you did little dots and just kept putting them in, we might see it slowly growing. I don't know.
I mean, it is possible.
Yeah.
Everything's possible. Believe in yourself. But if you want to, and you've got some paper at home, why not draw images of the different stages in that flower's life cycle and annotate it? So write little paragraphs about what's going on right next to it. I know people in my class, for example, are really, really good at drawing, so it'd be beautiful to see some of those. Okay, let's keep on going. How can we keep plants healthy? How can we keep plants healthy? That is a key question. So 3 things, obviously, as you know. 1 is to make sure that it is well watered and it has the right amount of water, not too much, not too little. 2 is sunlight. It needs access to sun to grow, to produce food for itself through photosynthesis. And it needs a good nutritious soil. Maybe some might need compost to grow with added nutrients. But is there anything else we can do to keep a plant healthy? Well, yes. Weather is a big factor in whether or not a plant is healthy. So one of the things we can do is we can provide that plant with a temperature that it needs. Now, my wife, Mrs. Keeling, she decided one year that she wanted to grow tomatoes. Now, luckily for us, we're quite lucky because we have a greenhouse in the garden. With a greenhouse, we can control the temperature to some degree. Tomato plants need warmer conditions than just being outside, especially in the United Kingdom where our weather is so changeable that we can have frost and we can have cold. So one thing that she had to do to make sure those tomatoes grew, and I can't remember if they succeeded or not, but that's not the point, to make sure that those tomatoes grew was she had to put them in the greenhouse and provide them with a consistent temperature. So another thing, as well as providing its base needs, is to ensure that the plants are at a constant or consistent temperature that they need and that they do not fall below a certain threshold. A lot of plants cannot put up with frost, and that's why in winter a lot of the plants die and then we lose the plants ready for the spring when they will regrow or be reborn, or we will have new plants. So, as I was saying, plants need water to grow and keep healthy. Water helps the plants take in nutrients from the soil, so it can suck up that water, and as part of sucking up that water, it takes in the nutrients from the soil. It also keeps the plants moist and flexible. If you don't give them enough water, they can wither and die. And I know, I don't know about you, but if you've ever come across a plant that's died or a plant that hasn't had enough water, it just the leaves go really crinkly and crisp, and especially when it does die, they just dry out completely.
I was wondering, sir, if we could maybe have a little pausey pause from this.
Pausey pause.
Yeah, because what I would like to start talking about, if you don't mind, sir, and I would love.
You're not enjoying my plant stuff.
Oh my gosh, I love the plant stuff. And the only reason I'm pausing is because I told Mr. Keeling I had a series of special guests for him, and you've got your final special guest coming along now. Okay. Excited?
I don't know.
No.
It's been interesting.
Yeah. Keep you on your toes. A lot of work.
Keep me on my toast.
A lot of work. Right, so we are going to do a little experiment, I think, unless you can think of a better wow experiment or something about tooth enamel.
Didn't you want to do elephant's toothpaste?
I don't know how that's even done, so I think that's something that we need to spend a little bit of time to do properly.
Okay, maybe you research that while I'm doing something.
Exactly.
All right.
Exactly. So this is the setup that we've got over here, but I tell you what, I won't start talking about that later.
Okay.
What we will do is get a nice big diagram of a tooth. Do you say tooth, sir, or do you say tooth?
I say
tooth. All right, good. Mr. Keeling, not Mr. Keeling, Mr. Singh, what did you say? Tooth.
Did you say tough? Never noticed that about it.
Yeah, he was a tough man. Not a tough man, but a tough man.
Tough man.
Now, would you say this is a reasonable diagram of a
London Bridge?
A tooth? It does look a bit like London Bridge. I see exactly what you're saying.
Yeah, that was suitably tooth-like to me.
Would it be right to say, sir, that a tooth is made out of calcium? Is that right?
Yeah, it certainly is composed of calcium. Drinking calcium helps your teeth.
And we'll probably go over all of these things again in a second when our guest comes in. But would it also be right to say that the outer layer of your tooth is made of enamel.
Yes, sir.
Right.
Which is clear, apparently. I'd have to fact check that.
Let's fact check that in a minute.
Yeah.
I can't quite remember how the inside of a tooth looks.
Right. Brown, isn't it?
Brown, isn't it? Yeah.
Dentine.
So we've got calcium. Shall I draw some sort of veins or something?
Are we getting a dentist? Is a dentist coming? Because I don't want him to look in my mouth.
Yeah, we might be getting a dentist.
No, don't get a dentist. Have you got a dentist?
It's a pretty good cat. It's not a bad cat. Tooth. Right. What we're going to be doing, I'm going to tell you the experiment first, and you guys on here are going to have a little sort of pre-knowledge of this, and then we're going to do it again. Okay, we're not repeating ourselves.
No.
What we're doing is preparing ourselves, ready for an experiment. We've got a tooth here, and we're going to talk about healthy eating.
Oh, just could I pause and
Yeah,
just
of course
throw in
you
a fact because there's a really cool one here. It says you
brilliant.
can check the plant to know how acidic or alkaline you need the soil for a better chance for it to grow.
Is that right?
That is fascinating, isn't it? You
I
know,
am
so
absolutely
checking the
fascinated.
type of soil that you plant it in will help that grow. Fantastic.
Yeah, that is fantastic.
Very nice.
I was sort of hoping that this would. I'm going to just.
Getting great slideshow, 100%. That's good. Thank you very much.
It is a great slideshow, 100%. What other things can you tell me about it? Do you know what if I could do? I could just open this.
You seem to be pacing, sir.
Well,
Well, while Sir is pacing and looking for this special guest, we could talk again and just have a recap quiz on teeth because you have mentioned teeth before, and there were different types of teeth, and there were different types of animals that have these different types of teeth. So, the question I'm going to ask is, what kind of teeth might you see a carnivore having more of? You can type it into the chat. I'll check. 20 seconds. What type of teeth would you expect a carnivore to have? Anyone? Add it in if you know. And while we're waiting for the answer on that one, what type of teeth might a carnivore have? Can you tell me what kind of teeth a herbivore might have? Now, herbivores will need those flat teeth for crushing vegetables and plants. So what teeth might a herbivore have? Sharp teeth, yes. Canines, sharp teeth for tearing. So, well done, great answer. They will need those sharp teeth for tearing. And then herbivores will need flat teeth. Can we tell me what sort of teeth they are? We tend to have these on the side. They run at the sides of our mouths. We would have more molars because molars would be really good for crushing down vegetable. Finally, omnivores. Well, omnivores have a mixture of teeth because we eat different types of food. We eat vegetables and we eat meat. So that is a mixture of molars, a mixture of canines, and a mixture of incisors for cutting, for tearing, and for crushing.
I love it, sir. Now, look, we have had a series of special guests all through the day. We had Waseem Zaffar, our local councillor, who came on. We had Kahlid Mahmood, the MP. We've had the BBC who turned up. We now have a very special guest from the West Midlands who's turned up. It is Mayor Richard Parker.
Wow.
Okay,
nice to see you.
So you come and stand in here.
It's great to meet you.
This, by the way, this is Mr. Keeling.
Nice to meet you.
He's nice to meet you as well. I'm just going to check. Yeah, we're all in the middle. So you know what we're doing today. We're trying to raise money so that we can get devices out to children in the community, both at Causeway Green and over here in Sandwell and over here at Anglesey and Lozells. You know, one of the things that we've noticed is that there is a serious lack of that technology in homes, and a lot more needs to be done to provide for our kids. And our children are, and your children, we live in some of the more disadvantaged communities. And it's really unfortunate that some of the most disadvantaged pupils are sort of being hobbled even further by not having that access to technology. I know that's something that's important to you.
No, it is. And look, my biggest priority is helping people and young people make the best of their lives and get access to the skills they need that will help them get good jobs and progress in lives and be able to feel that they're fully participating in what they do. And I want to help address every obstacle that helps young people achieving their aims and ambitions and progressing. So a reason I came here today is I wanted to support the great work you're doing. It's going to make a difference to lots of people, and at the time when you can have a great impact on their lives. So that's really important. But also, I do want you to contact the team at the Command Authority that works for me, because there are a lot of people there that are seeking to address these issues, and there may well be other funds or networks they can introduce you to that might help you access some of the equipment that will help help the young people that study and learn at each of your schools.
That's amazing. We absolutely would, yeah. Well, look, we haven't just brought you here to chat. We've talked for real things. We're here for science. Okay. Now we've just been talking about the tooth, and we've been talking about that inside it is calcium and outside it is enamel, and we're talking about how different liquids might affect our teeth. Now, we wanted to do an experiment to try and work out how we can see what effect different liquids have on our teeth. And we thought it might not be very nice if we just pulled out some teeth and tested it on those. And I don't know if you were aware earlier on, but if you look over there, so we've already been dissecting hearts. Oh God! And we've had those out. So we've that went very successfully. It went very successfully. We only lost one child to fainting. Yes, so only one. So we're a roll. So we're not going to pull any more teeth out, but we do have something here, which is pretty similar to a tooth. Now, I know you might be saying, how on earth is an egg similar to a tooth? Because I drop a tooth in the throat, it's strong, no problem. What does an egg have? Well, the outer layer of a tooth is coloured in enamel. And that is the exact same thing that's on the outside of the egg. Right. So what we can do as scientists is we can use this as an equivalence for our teeth. We can see whatever's happening to this egg, we know, obviously not exactly, but we know that it's a pretty good reflection on what might be happening to our teeth.
So, interesting fact about an egg, actually, it's not necessarily that the structure of an egg or the outer layer of an egg is weak. In fact, it's not. It's designed to protect what's inside of the egg. But actually, the structure of the egg is made in a way that if you press the top and the bottom of the egg really hard, there is absolutely no way that you can break that egg. Would you like to have a try?
I'm too scared to have a
You're too. Well, I'll give it a go in front of the camera. I'll press the top and bottom really, really hard as I can, and that egg will not smash. Would you like to give it a go?
I will do, yeah.
Top and bottom. Hold it away, just in case I'm wrong. But you shouldn't be able to break that egg.
That is pretty impressive.
Wowzers. There we
And
go.
you know what? We did a...
It would work that way.
We did an experiment, actually, where we were trying to protect these eggs, and we were throwing them up and how high you can go. And actually, this egg, when it lands on grass, it pretty much don't break. This is sort of evolved.
And we might be trying something about that.
We are trying that later.
Well. Yeah.
Right. One thing I'm going to just talk about quickly. We talked about a fair test, and we need to keep certain things constant. So one of the things we're definitely going to keep constant is the container that we're keeping it in. The other thing we're keeping constant are the eggs that we're using. They're all of the same size. So it's really important that we have certain things that are constant and certain things that are variables. The variables in this test are going to be the liquids that we add to it. So the different liquids will be the things that we're testing. That's the variable. Now, sir, I just wondering, would you think dropping that in is a good idea? Could you think for the children, if they were doing it at home, what might be a better way rather than just dropping it in case they've got a hard thing? This is a challenge I put to my class to see like a little brain test. How do you get the egg in there without dropping? Oh, he knew it straight away.
Oh, there we are. Look
if
at
you're going to do this along with us at home, I had this in class where kids, they dropped it immediately.
It broke.
Pop it to the side, roll it in. And that way, not just in case. I know Mr. Keeling was right about that, but just in case. So we're going to pop these over here. Now, these are the different liquids that we're going to be testing. We've got a really high sugary content. This is apple squash. So we've got the apple squash here. We've got a vinegar, which we used earlier on for an experiment, which is an acid we learned earlier on in the live stream, and it reacts quite violently with alkaline. So I think that's developing that learning. We've got this milk. And so, do you know anything about milk and teeth? Is there anything about milk?
Well, they've got calcium in, I think, isn't it?
Yes, calcium. There we go.
So that's interesting. We're using a bit of prior knowledge, and when we predict which egg might be affected most, we can use that prior knowledge, can't we, to think that it might or might not be this one based on the calcium content. We've got a common drink. Now, Waseem Zaffar, I don't know if you've met him, the local councillor. He was not happy about us having Sainsbury's.
No, he wanted the little cola.
Oh, was it Aldi? Aldi is the best, but obviously other brands are available. But anyway, we've got what's remaining after Waseem knocked off the rest of it. Okay, so that's the remaining little bit of coke. And we thought, as our kind of balance liquid, water. Because
I don't know about water, but water seems pretty safe to me. I don't know what you think.
Yeah, I think so. I think in water it should be okay.
So I'm going to just alter this camera a little bit so that we can move over to that little experimenty area and I can get both of these in. So what we'll see on the big screen what's happening over here.
Sure.
And if you guys, are you able, sir, just to lead a little bit of the pouring in? And
Absolutely.
oh,
So I think so that we put the same amount in, we fill it up to this little original glass here.
I was a bad scientist. I'm sorry, I forgot one thing. Predictions.
Predictions. Okay.
So
our hypothesis.
Our hypothesis. So could you make, so seeing as you're with us, what would you predict is going to react the most, the least? What do you think might happen with these different liquids that we provided?
I think the sweet one here, and the sweet ones and the acid will have the biggest reaction.
Right.
Okay.
And the water probably 0, and I'm not sure about the calcium one, but I imagine, or the milk, but I imagine that will be, would not be negative.
I like that because I know milk does other things when you leave it out, and it can kind of change, can't it?
Yeah, so it curdles and gets smelly. I think there is a chance there that something might negatively.
But hey,
with that.
we're using a bit of pride knowledge.
I'm not a scientist.
But do you know
we
what?
all are today.
That's
we
what we
all are
learned.
today.
So we're all scientists, okay? As long as we can do fair tests, we make these predictions.
Absolutely.
We're all scientists.
And I think as well, we just need to point out that this needs to be a longitudinal study, doesn't it? It's not something that will happen.
It's not immediate.
We're not going to pour it in and it'll happen. We're going to do this at the very end.
We've taken the mayor's predictions, and when we get to the end of the stream, we're going to see
See if
whether
the
you
mayor
were
was
right.
right.
And if you were wrong, well, shame on you, really.
Well, that would be
lessons next week.
Yeah,
absolutely. So, would you like to choose one that you want to pour in? The vinegar, yeah, that's a good one. So, would you like to choose one as well?
Yep, I'm going to do the.
I'm going to go for milk. I'm going to fill up to that.
Just
bridge,
go to that,
yeah. To that line.
Oh, do you know what? Yours is going to come out really slowly. Oh, you'll get there.
So there we go. That one is now in the milk.
This, I can see this one's fizzing.
Okay, we're going to add the water to this one. Very nice.
Okay. Tiny bit over there. I'm sorry about that.
That's fine.
This is the sugary one?
Here we are. And then a control one with nothing.
Yeah, and will you do the sugary one? Yeah, it's really important that when we do a test that we also have something known as the control. The control is when we've added nothing to it. Because what if the egg on its own was going to start disintegrating, right? Then if we see the egg in liquids disintegrating, it doesn't really tell us anything about the liquids if the egg was already going to disintegrate on its own. So we have a control that isn't surrounded by that liquid to make sure that this is a reasonable and fair test.
Absolutely. Right? And I've always kind of wanted to do one of those kind of opening ceremonies. So should we do kind of like we officially call this experiment open or something?
Does
like
the mayor
that?
not have to do the official calling this experiment open?
I think that needs to
That's
happen.
the job of the mayor, right?
That's yeah. So we
would you be able to officially announce that this
experiment is good to go?
Yeah, I'd just like to formally announce that the experiment is good to go live.
Fabulous, wonderful. We should have brought something to cover.
We should have brought
something to cover. That is on us. That is our fault. So let's line these up maybe on the.
Just do you know what? And I don't want to keep them there for too long.
No.
I've actually interestingly noticed one bit of reaction that's just started happening. The mayor mentioned the vinegar being one of the ones that reacted. And if you look very carefully, I don't know if you can see, and I saw a little bit earlier. I do see bubbles starting to form and come up. And that's interesting because there are bubbles coming off the Coke, but what do we know about Coke? It's already fizzy, isn't it? So I don't know if those bubbles coming off the Coke are the fizz or what they are, whereas the bubbles that are coming off this one, I presume, are probably from an initial part of the reaction, which is amazing how quick it's happening, because you think of the teeth as being really touched. Yeah, absolutely incredible, isn't it?
Fabulous.
Right,
well,
so, thank you so much for being here.
No, that has been absolutely wonderful.
Good. Hello. Yeah, good.
You can take a few little photos.
I can, yes. I thought it was 4:45.
That's okay.
No,
well, I'll tell you what,
absolutely fine.
I'll keep on talking a little bit. If you want to get a look,
take a couple of photos, just that natural.
Absolutely. Yeah, that's great.
Yeah, we've got a few photos of you with the kids anyway.
Yeah, you're going to send some pictures through with the kids. Anyway,
Amazing. Right, so as we can see, and
I'll the kids already got, they're going to send some photos.
Okay. I'll just focus back in on that just for a second, whilst we're getting a couple of photos just popped up, just before we probably say.
You got a drink?
Okay. Well,
yeah, you're here.
Whoa, really? Egg.
We do have a challenge, by the way, and this is part of science, but when it do get to £3,000 that we have earned, we are going to eat a Scotch bonnet.
And then we're going to see.
He says weed. It's not a weed.
We're going to see the science, the reactions, what's going to happen afterwards. So we really need to. If you can help us get to that £3,000, that would make that's
absolutely. And
that's our
he
first
will
goal.
definitely eat one of those.
And we'll both eat it. At
He will
6,000.
eat it
at 6,000.
At 6,000.
We'll both.
At 10,000, I will eat it.
Okay. So yeah, we've got these reactions going. Is there? And that's good. So I guess I love. Actually, I'm just probably I'll just watch you guys do this. It's good for the kids to see. We can see maybe that there are fizzes and there are bubbles already coming off the vinegar. And interestingly, was this the apple?
That was the apple, yeah.
I'm amazed by this because
it's
even
already
the apple. If you see there is a kind of ring around it, we know that wasn't fizzy when it went in. There's already a reaction. I think this is one of those things when they tell us all about brushing our teeth so regularly, why it's so important. But when we do have these high sugar content drinks, or we drink those things that are quite acidic, they're very quickly and rapidly affecting our teeth. And it's one of the important reasons, one of the main reasons why we need to keep really good, healthy teeth hygiene. I notice if we look at, for example, the water, which we expected wouldn't have much of a reaction, there are no bubbles. So that's the thing that we can use to compare. Because if we noticed that the bubbles were coming off the water, then that might be something that just an egg does. But now we can see, because those bubbles aren't coming from the water one, and we compare it to the sugary drink, or we compare it to the vinegar, then we can see that definitely some reaction is happening.
And actually, earlier we talked about those kinds of changes, didn't we? So we did discuss that there are physical changes where you can change something physically, and then there are chemical changes. And the fact that a gas is being given off, those bubbles are being produced at the moment, does indicate that some form of chemical change is happening to these eggs. And again, you know, imagine that with your teeth. Every time that you're drinking something like Coca-Cola or apple juice, and, you know, this is an extreme version of that, and it wears away at the egg a lot quicker, I think.
We've all had that experience of acid in the mouth, because I know this sounds a bit disgusting, but earlier on the children were talking about digestion. And we were talking about what happens in the stomach, and how the stomach produces that acid, and how if you're sick, you sometimes have that funny feeling on your teeth. So that's that immediate reaction between the enamel on your teeth that the acid is creating. So that's really, really good. Is there anything else you want to say, sir, or I don't want to keep you for too long?
No, it's just been that I've enjoyed the visit. I think it's been great to meet some of the children earlier. I also, could you thank them on behalf of the letters that they sent to me?
I will. So that's if you get year 4 with the ones.
Okay, so I'd like just to say to come to Anglesey Junior School this afternoon. I'd like to thank all the children in year 4 that wrote to me as mayor, congratulating on my win, but also asking for my support in raising the funds to support the IT equipment that the children in this school and other schools need. So I'm delighted to be here to support the fundraising campaign, and it's been a fantastic trip out to Lozells today. And I'd also like to thank the 2 teachers that have been behind this initiative and have inspired me to come out here to meet with you all. And I wish you the very best in raising the funds you need, and also for all the children at this school and other schools in Birmingham and West Midlands. Best wishes for your education, and I hope you keep working hard and make the best of your lives. Thank you.
Thank you so much for that. It's been lovely to have you here. Thank you so much.
Thank you.
That's really good. I'm going to just walk out of the
Absolutely.
building.
I'll get to my plans, shall I?
Brilliant.
Fabulous. So
we need to keep checking in on these eggs. I'm very excited.
We will. We'll do that every hour on the hour.
If the mayor knows what he's talking about.
Absolutely. We have to check that.
Okay.
I think a lot of that prediction was probably quite accurate. So I think we're going to see some good things. Thank you so much. Thank you. Take care. All right, here we go then. So let's get back into plans and let's figure out where we were. Oh, that trying to keep the screen on didn't work very well, did it? Well, let's go back into where we were. So we did last time. I was vanishing there. We were looking at. Apologies. Let's get this up. Sorry, 1 second. There we go. And let's get back to our PowerPoint. So how we can keep plants healthy. So we said that plants need sunlight to grow to keep healthy. The sun provides warmth and energy for plants to survive. Plants use the sun's energy to make their own food. energy in their leaves. And wow, wasn't that amazing to have the mayor of the West Midlands on our humble little video. Hopefully that can help us, and the BBC can help us to raise more money for our cause. And if you haven't donated yet, could you please go to the links below this video, our Just Giving site, or alternatively, could you scan this QR code and give generously? It really will affect these children's lives, and we will be able to provide them with fantastic tech equipment. Okay, carrying on. If the plant does not get enough sun, it can slow its growth. It can even kill the plant. Did you know that too much sun can be a problem too? It can quickly dry the plant and the soil too quickly. And as we were talking about earlier, and it transports that water, and we will look at water transportation in a moment. It transports the water to the leaves, and the process of photosynthesis actually aids evaporation of water from the leaves. So it's constantly using that water, but that water is evaporating. So too much sunlight would cause that water to evaporate too quickly and may end up killing the plant, drying the plant out. So we're moving on now to lower key stage 2. We're staying with our plant topic. We've got lots of other exciting topics to come, so don't you worry. I'm so excited for space later, but we're going to stick with our plants for now. So lower key stage 2. And we can see that as we're going into lower key stage 2, we have many more labels for the different parts of the plant. If you can't quite see the labels that are on the screen, don't worry about that. I'm going to point to them and I'm going to tell you what each of the parts are. Now, we've alluded to some of these already. We've spoken about some of these already. We've talked about some of these parts already, but now we're just going to refer to them more specifically. So we have pollen inside the plant. We have pollen, and the pollen, as you can see, is here. It may also be on these parts just here. Pollen is near the top of the plant, and the reason that it's near the top of the plant or in the entrance to the flower is because we want those pollinators to become covered in pollen. Is that one yours, sir? Because I couldn't tell earlier.
I've been putting mine on here.
Okay, fabulous.
And also mine's got a bit of goo here.
Lovely.
What did you think? You're a little surprised.
I thought it's amazing how many guests you've had on so far. I'm hoping that they share this quite a lot, because it would be really nice after all this effort to see that people are joining and donating.
Been busy little people.
You've been very, very busy, and that's really nice. And now, hopefully, in the next few hours, people log on and it starts paying off.
We're going to get donations.
Fingers crossed. Fingers crossed. If we get to 2,000-3,000, I will be very, very happy. But let's push. Let's try and get past that, and let's try and get as much as we can.
I think we should go further than that, personally.
Okay. Well, do you want to do a check-in, see how much we've got?
I think it is perfect time for a check-in, and I think that's exactly what we need to do right now.
While you're checking it up, I'll just carry on listening to some of these parts of the plant. So we have the pollen. Then we have the petal. Here at the top of the plant as well, we have the stigma, we have the style, and we have the ovary where the eggs are kept. All of these are parts of the carpel. Then we have the ovule, we have the stem, we have the sepal, we have the filament, the anther, which make up the stamen, so the two parts of that filament and the anther. And then we have the functions of each of these. But Serge, we have a total at the minute.
We do have a total, sir. We haven't gone up much since you last said it.
Okay, so what are we at?
We're at £1,725.
I think that's pretty much where we were before.
That's where we were before.
So I think
what's been nice to see, there's a couple of comments I noticed that people have watched on the TV. They saw it on the news earlier.
Lovely.
And they've donated.
That's really lovely.
Yeah.
And hopefully a few more people will see when the mayor shares and when the BBC.
Where were we on the TV earlier in case people wanted to watch?
I think it was BBC something. Or
BBC
other.
something or other.
Tune in.
To
BBC
BBC
have been very nice
or
because they've sent out a full team.
They've been great.
Where will that be, by the way, sir?
So that is a great question. There's going to be a news. I've got no idea.
Right.
Maybe I'll find out very quickly. What time
Okay,
is
and I'll
BBC?
keep going through these. So basically, the petal. The petal is part of the flower. So we talked about the flower attracting those pollinators earlier. The petal is the part that attracts the insects and the other animals. The anther, this part here, which is part of the stamen, the upper part of the stamen, helps create pollen. So it starts developing pollen. And we said that pollen needs to be up there at the top of the plant so that when the pollinators come into the plant, they get covered in that pollen. Then we've got the filament, which carries the nutrients to the anther, because the anther needs those nutrients. Why does it need those nutrients? Because it is creating that pollen. It's a hard job to create pollen. So
It's
how
not
much
easy.
pollen can you create in a day
Me personally,
on an empty stomach?
on an empty stomach, I'm gonna say around 7 or 8 pollens.
Right, that's a lie because you as a human don't create pollen.
No, you caught me out.
Thank you.
I'm not a pollen producer.
All right, no, you're not.
Do you know what? So what I like about this is we did this earlier, but this now looks a little bit more detailed than what we did earlier.
That's because we're now in lower key stage 2, sir. So we're developing our knowledge. We're going further. We're moving along.
Have you spoken about the male and female parts? And is that
No, that's going to be later. So
Oh,
that's
gosh.
going to be year 5.
That's a later on thing.
That's a later on thing.
It's really good that you have a grip on what happens in the curriculum. I like that.
Good, yeah.
It's really good.
Well, I put that. I sat and put this together.
This is quite something that we've got here. We've got an absolute marathon.
No. I mean, this is something that I've got here. Yours are going to be in between.
This is quite something that we have got here.
I have got.
This is quite something.
So anyway, let's carry on through. So we've got the stem. The stem still does the same job as we learned earlier, which is to transport that water through the plant to the different parts of it. Then we've got the sepal. Now this is new. We've got the sepal here and here. The sepal helps to stop the flower from drying out, so it protects that upper flower just by wrapping.
Now
the
that's
bottom of it
fascinating.
there.
I was just wondering, sir, as we've got a little bit of an opportunity and the school is a little bit quiet, and you seem to be going through a lot of information very quickly, what if we slowed this down a second and went and looked at some flowers and plants and actually checked out what you're talking about?
Absolutely.
Okay, I like it. So we've got this
But
opportunity.
will it be too bright outside? That's my only concern,
Should
'cause
we
you could always
do?
fetch one inside.
Do you know what I like, sir?
Yes, sir.
You know what I like about science is when
I
you
like-
test things out. You
Right.
test. You have a hypothesis.
Okay.
Do you think it's still too bright? What's your prediction?
100% that camera can't hack it.
You reckon 100% that camera can't hack it? Well, I'm reckoning there's about a 50% chance that we might be able to do okay. So
100%.
here's what we're going to do. We're going to test that theory. Are you up for testing it?
I'm up for testing it.
Right, because Mr. Bradley has brought an amazing new camera device for us.
Is it an umbrella?
This is an umbrella. And what the umbrella does, and everyone says it's always good luck to put an umbrella up indoors. The umbrella is going to offer a layer.
Well, that's just giving us bad luck for the stream, hasn't it?
It's going to give us a layer of shade. Is there a thing such as luck? We'll have to find that out in a second.
Probably.
It's going to give us a little bit of shade, and that should darken it so that we can go and have a look at some flowers whilst we've still got a little bit of sunlight.
We can go and try.
Should we try it? And if
We
it doesn't
should
work
try
out,
it.
sir, it doesn't work out. We'll come back and we'll do it later.
Absolutely.
Right. I am going to pick this up. You've been carrying this a lot, sir, so I'm going to carry it this time. That's okay with you.
Fine. I'll go and try and find us some flowers if you follow me.
I'm going to follow you.
Microphone.
Hold this onto here.
Absolutely.
This so I can see what the live stream's doing. There it is.
So just while we're waiting, the last thing on there was pollen. And as we talked about earlier, pollen gets stuck to the pollinators, and that is what pollinates the other plant. As I said, we will look at a little bit later. Plants do have male and female parts. However, generally, plants cannot pollinate themselves. So they rely on pollinators to take that pollen to other plants that also have male and female parts to start the reproduction cycle. So let's have a step outside and let's see if it's too bright for us. How are we doing?
Yeah, your prediction was pretty accurate. Pretty accurate. It is probably still. What are we thinking, chat? I think if we get up close to a flower, it's not too bad. If I put the computer down maybe for a second.
Yeah.
I'll pop this behind me.
Okay.
I'm going to pop this computer down here 1 second. And you know what? We're out. Do you know what? It's nice to be outside. We'll come back outside again later.
Ghost hunt later. Don't forget that.
You can see. Will you have a little look at the screen, sir, and make sure that that's.
Yeah.
Does it look okay?
No, you can't. You can't see the flower.
Do you think we need to come out a little bit later then?
Or is there any flowers that we could pick? Perhaps. I mean, these are very beautiful flowers that have been planted by the school. So they're not wildflowers like we were looking at earlier.
Should we go and have a little hunt?
But is there anything that we can bring back with us? Perhaps. Do you think?
We have a little hunt, yeah?
We have a little hunt.
Let's have a little hunt.
Yeah.
I'll leave this umbrella in for a second. Right, I'm going to pick that up there. I'm going to pick this up here. And we're going to go on a little hunt now. High saturation levels. Don't you worry about that. It isn't actually snowing out here.